Hello and welcome to the 2025 Truth and Beauty E-Summit. I'm Jen Novakovich and I'm behind the sci-comm platform The EcoL, host of this event, and I'll be today's MC. Thank you for registering and spending your Sunday with us. Over the last few years, we've all seen how misinformation, especially online, has shaped consumer perceptions, business practices, and even policy. Beauty is not immune, and it's actually often the center of these conversations, sometimes taking up disproportionate media space in terms of headlines. From exaggerated claims to greenwashing to fear-mongering, misinformation doesn't just confuse consumers, it can stifle the needed progress to do better and make better products from a safety, sustainability, and performance perspective. It undermines trust across our entire sector. We live in what many people call an infodemic. There's so much information out there, right and wrong. Algorithms reward sensationalism over accuracy, even from so-called experts. Bad science, research fraud, and predatory journals are adding fuel to the fire. Critical appraisal of science is fundamental, but it requires expertise many of us don't have. No matter who you are, even if you're a PhD scientist, finding truth, especially when faced with areas that aren't our expertise, is extremely difficult. Misinformation is a giant problem, and finding solutions, a daunting task. That's why I've organized the Truth and Beauty E-Summit. With a lineup of global experts, throughout today, we'll dive into some of the layers of misinformation I thought were most pressing to grapple with in this current moment, specific to beauty, but broadly relevant. From the rampant misinformation from the media, we'll have a series of presentations about separating headlines from reality, focusing on microplastic, product safety, and endocrine disruption. To basics of quality systems, I think this is a topic a lot of people don't think about when it comes to product safety, but definitely should, especially in light of some of the recent headlines that came up this year. The theme in general for the summit is navigating the infodemic. We'll be touching on how to identify credible expertise, how to separate fact from fiction, and how to build more resilient systems, whether that's in regulation, product development, communication, and so on. And importantly, we're not just here to talk about problems, we're here to highlight solutions. The Truth and Beauty E-Summit is part of my broader free e-conference initiative. Traditional industry conferences are an incredible space for knowledge sharing, but they have an accessibility problem. High registration fees and travel costs create barriers that leave many people out of the conversation. Those barriers matter. They limit student opportunities to connect with the industry. They leave smaller businesses without the tools they need to succeed. And they widen the gap between credible science and the misinformation that fills the void. The goal of this free e-summit series is to offer an alternative, an event that rivals the best industry conferences in quality but remains 100% free, fully virtual, and always available on replay. That way, whoever you are, wherever you're watching from, nothing should stand in your way in accessing this knowledge. So far, I've hosted 13 e-summits on topics ranging from sunscreen to sustainability, formulation to claims. All of the replays are available on the EcoL blog. If you're looking for free professional development, I encourage you to explore them after the event. I want to pause to thank the companies that make it possible to keep these events free and accessible. A heartfelt thank you to our silver sponsor for this summit, Kenvue, and BASF, a longtime supporter and bronze sponsor for all of our e-summits this year. Without the support of our sponsors, these events wouldn't be possible, so thank you so much for your industry leadership to support this work. If you're a company interested in sponsoring a future summit, please reach out to us at info@theecol.com. I also want to thank our speakers. Each one was hand-selected because I knew they would do the topics justice. Thank you so much for taking the time to share your expertise with us today. A couple of quick housekeeping notes. All sessions will be recorded and shared with registrants, so don't worry if you can't catch everything live. You'll also receive an ebook summary of the event once it's ready. Thank you so much to Luciana Smaldor for taking this project on and for all your help in the summit prep. Please use the YouTube chat to engage with our speakers for Q&A and with other attendees. Your questions and perspective make the conversation stronger. Before we dive in, I have two small requests. First, I'll be sending out a short feedback survey with the replay link. It only takes about a minute, but it's incredibly helpful to me to keep improving these events. I've come a long way since the first summit, and the feedback from you has been a big part of that. Second, there was a ton of work that went into this event from many people who care about the initiative to democratize accurate and high-quality education. At this point, the ball is in your court to share. Whether that's on your social media, in your classroom, or with your colleagues. An inspiration and challenge for anyone on social media. If you're taking notes, maybe do a little recap of what you learned at the summit. I would love to hear your takes on some of the learnings today because maybe they'll be a bit different from mine. However you share on social media, please tag me at the EcoL or Jen Novakovich on LinkedIn so I can see and further amplify. At the heart of this summit is the belief that truth and beauty matters. It matters for consumer trust, for genuine progress, for safety and sustainability, and for the future of our industry. My hope is that you leave the summit both challenged and inspired. Take what you learned back into your labs, your classrooms, your businesses, and your communities. And together, let's keep pushing for a beauty industry and media landscape that values accuracy and reputability. Thank you so much for being here. And with that, let's get the summit started. To kick off the day, our first presentation will be a headlines versus reality format on the topic of microplastics, featuring Dr. Oliver Jones, who is professor of analytical, biological, and environmental chemistry at RMIT University in Melbourne. With a PhD from Imperial College London, he has published nearly 150 peer-reviewed papers on tracking pollutants in the environment and assessing their impacts on biological systems. A fellow of both the Royal Society of Chemistry and the Royal Australian Chemical Institute, Ollie also dedicates much of his time to public engagement, debunking myths about chemicals on TV, radio, podcasts, and social media under @Dr_Ollie_Jones. Without further ado, here's his presentation.
Hi everyone, my name's Oliver Jones. I'm a professor of chemistry at RMIT University here in Melbourne, Australia. Thanks for coming along to my talk, and thanks to Jen for giving me the opportunity to talk to you today. I want to talk to you about microplastics, and particularly the difference between the headlines that we often see about the dangers of microplastics and the reality that the scientific evidence tells us about microplastics in the environment. But before we get on to the main talk, I thought I'd just give you a little bit of background to me, or a bit of an introduction. Why should you listen to me talking about microplastics? As I said, I'm a full professor of chemistry at RMIT. I'm originally from the UK. I got my PhD from Imperial College in London in 2005, looking at the issue of pharmaceuticals in the environment. And I've worked in the issue of environmental contamination since that time, so over 20 years now. I worked at the University of Cambridge following my PhD as I was a postdoc there for 4 years, looking at the effects of pollution by studying biochemical profiles. I then worked at the University of Durham, teaching environmental engineering and environmental science and chemistry, before moving to RMIT to get a few years experience working abroad, and I've been here ever since. So I've been working in the field of environmental pollution, particularly trace environmental pollution, for almost 20 years now. I've got almost 150 publications, and full disclosure, I have had some funding from the water industry and the environmental regulator here in Victoria, which is EPA Victoria, but I've never had any funding from the plastics industry. So what I'm going to tell you is just my honest opinion, based on my experience in the field of environmental pollution and measuring things analytically and assessing their effects biochemically. And we should probably start by defining what is a microplastic, because it actually becomes a bit of a tricky question in some respects, as there's no, although you might think there'd be a single definition, there's actually quite a few floating about, and no one necessarily agrees exactly what the definition is. Generally, people go with small pieces of plastic, less than 5 millimeters long in sort of one dimension. So you can have either quite small particles where you've got 5 millimeters in diameter, or you can have long sort of fibers. Usually they're much smaller than 5 millimeters. When we're talking about microplastics, we're really thinking of things that are less than a millimeter long. And there's also something called nanoplastics, which are generally defined as being between 1 and 1,000 nanometers. So remember, you go from millimeters, divide that by 1,000, you go to micrometers, and you divide that by 1,000, you get to nanometers. So we're talking quite a wide range of sizes. And sometimes in the press, people, when they say microplastics, they can mean anything from, a nanometer up to a millimeter or more. And they come in a range of shapes. So if we look at these two diagrams on the bottom here, these are just some particles that were found in two samples. These ones, this bar, the scale bar is 5 millimeters. And in this one, the scale bar is 1,000 nanometers. Note that we see a lot of these fibers. If you look at environmental samples, you often see a lot of fibers which are generally assumed to come from clothes, so things like fleeces and whatnot, which are made of plastic. But actually, there's some research that shows a lot of the fibers that we find in the environment are actually not plastic, they're actually natural fibers. And in some cases, the majority of the fibers are actually natural products. So that's what a microplastic is. So there are two main types of microplastic. There's what's called primary microplastics, which are made to be that size, so they start out small. And these are actually a fairly small proportion of microplastics in the environment, and they really come from things like cosmetic microbeads, which really aren't so much of a problem. They're a teeny tiny percentage if they're even still around. And then we've got secondary microplastics, which come from the breakdown of larger pieces. So plastic packaging, tire abrasion, things like that. So as plastics sort of smash together in the environment, they crumble into smaller particles, just like most other materials. And these diagrams here show some microbeads that were extracted from different beauty products at RMIT about a decade ago. And this is just microplastics that you might find from an environmental sample under the microscope. So you just see all the different particles. They come in different colors depending on what the original plastic was used for or what additives might have been added to it. So that's what is a microplastic, but what is not a microplastic? And this is also important because several places actually misclassify things as microplastics, or they claim they're microplastics when they're not. So soluble polymers, they are not microplastic, they're not solid particles, so by definition they're not a microplastic. Silicon-based polymers, such as dimethicone, which is generally a liquid, is not a microplastic. Okay, you can get silicon-based plastics, or silicon-based polymers, I should say, but if they're a liquid, they're not a microplastic. And plastics that are larger than 5 millimeters are not microplastics. These are termed either mesoplastics or macroplastics, depending on the size. So one could argue that macroplastics are a bigger issue than microplastics, because when we look at animals that have eaten plastic in the environment, like turtles or birds or whatnot, these are generally macroplastics. And when we see plastics in the environment at the side of the road or in rivers and streams and so forth, these are often bigger pieces of plastic. The other thing that aren't microplastics, or plastics at all actually, are other polymers. So all plastics are polymers, so you have repeating subunits, which are called monomers. So polystyrene is multiple styrene molecules stuck together, for example, into these long chains. But not all polymers are plastics. There are plenty of natural polymers. DNA is a polymer, proteins are polymers, starch, cellulose, chitin, they're all polymers. And here's an example of cellulose at the bottom here, which is just these repeating subunits. And in fact, cellulose, starch, chitin are all made of these glucose monomers, just in different structures. So that is what microplastics are and what microplastics aren't, and the different types of microplastics that you might encounter. Why do we worry about them? Well, let's look at some of the recent headlines. Here's some just from the last few years. There's a paper about plastic particles being reported in human blood. There's reports of microplastics in human arteries. And quite recently, there was the microplastics in human brains that was reported. But you can look at almost anything, testicles, bones, placenta. There's all these reports of microplastics being found in human tissue. These get a lot of attention. For example, if we look here at the bottom, this is the altmetric score for this Neihart et al. Study that was talking about microplastics in brains. You can see it got over 2,000 tweets, over 900 news outlets repeated it. It's listed on 6 Wikipedia pages. And this is one of the most tracked articles they've ever had on altmetric, I think. And that's all from this paper on brains in 2025. But as we'll see, sometimes the headlines don't match the reality, or in fact, quite often they don't match the reality. So let's have a look at those studies that we just saw the headlines from and look at the actual reality of it. In this case of microplastics in the blood, someone did this for me. So there was this nice letter to the editor that was published in Environment International. I note here he said, "I expected to find solid evidence supporting this public announcement. I was very disappointed. Instead, the author's assertions rely on unprecedented hypothesis that is not supported by their data." One of the interesting things that was done in this article is the original study had duplicates, so duplicate samples, and if they were arranged randomly in the original paper. But when you lined them up, which this letter did, in order, you actually see that the duplicate samples don't match each other. So what we've got on the left of this chart here are sample 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. And then on the right are the duplicates, so 1b, 2b, 3b, 4b, etc. So 1b should be a duplicate of 1a, and etc, etc. So this really ought to give you the same pattern on each side of the line. But as you can see, it doesn't. So how can duplicate samples of the same blood sample give you such different results? So there's different particle makeup, different amounts. In fact, the only ones that actually show reproducibility are the ones at the end, and they don't have any microplastics in them. That doesn't make sense. Let's also have a look at the microplastics in artery study. Now, there were a lot of headlines about this at the time. People claiming that microplastics were causing blockages in arteries, that they may be responsible for heart attacks, and all sorts of other worries about health. But if you actually read the original paper, the authors stated that the results did not prove causality, and the association was merely an association, not correlation. And it could actually, all the results in terms of heart disease were likely to be, or potentially from, other residual unmeasured confounding variables, such as unknown exposures, or other health problems, or behaviors of the patients, etc., etc. And in addition, they did not consider levels of PM2.5 and PM10, which we'll come back to in a few slides' time, which is an emerging risk factor for cardiovascular disease. So essentially what they're saying is all we found was an association, and even we're not sure it's actually correct. But think of all the headlines that generated, even though this was quite clearly stated in the paper. And finally, let's look at the most famous one, I think, which is the microplastics in brain study. This one I commented on in the media at the time, and there's a number of things I thought were potentially interesting. Firstly, they only had 28 brain samples from 2016 and 24 samples from 2024, and that's these red ones here. And all those samples came from New Mexico, so it's really a bit of a stretch to say that applies everywhere. You've only got 52 samples. If you look at the data here, this one shows you microplastic concentrations in liver and kidney and brain, and you can see the samples are quite spread out for liver and kidney, and in fact brain, except for the brain in 2024 where they all clustered together, which is a bit odd. If you look at the types of microplastic, they also vary quite a lot, so the liver becomes more diverse in terms of types of microplastic found between 2016 and 2024, but kidney becomes less diverse. So that doesn't make any sense. Why would the liver be less diverse in 2016 and more diverse than kidneys in 2024? The brain tissue stays roughly the same, so no changes in brain, but changes in the composition of the microplastics in the other tissues, which is a bit odd. They also report a higher level of plastic in brains than we find in raw sewage. So the headline at the time for this one was, everyone's got a tablespoon of plastics in their brains. Despite the fact that none of the people, all these samples came from people who had died, but none of them had died with particular health issues. So it's just like, if you had that much plastic, was it actually causing a problem? It doesn't seem likely that you've got more plastic in your brain than raw sewage. And how would the particles get to your brain in any case? There are also some issues with the methods they used and possible lab contamination, which I'll come on to in the next slide. The trick with some of these microplastic stories is that I don't think people really appreciate how difficult it is to actually measure microplastics. Remember, in many cases, we're looking at things that are smaller than the eye can see. So we have to measure them with very, very sensitive techniques, usually mass spectrometry. People tend to think that mass spectrometry works just like it does on NCIS or CSI, where you put your sample in the instrument and it goes bing and you get an exact quantitative result and there's no problems with it. There's no question about the sample preparation or anything like that. You just believe what comes out of the instrument. And if you do any sort of analytical chemistry, you'll know that that's not the case. Particularly with plastics, the polymer molecules themselves are too big to go into mass spectrometers. So you need to use proxies to measure, or you're measuring proxies to guess, or estimate, I should say, your plastic concentrations. And this causes problems. So if you want to measure polyethylene, for example, the breakdown products of polyethylene are all the same breakdown products that you get from fats. Now, I'm oversimplifying this a little bit, but so essentially it's very easy to mistake fats for polyethylene. Okay. If you want to measure polystyrene, the marker is styrene, but there's actually other sources of styrene than polystyrene plastic. If you measure polyvinyl chloride, the marker is often naphthalene. Again, it's not unique to plastics. So unless you've got a definitive measurement to exclude all other chemicals from consideration, the authors of any of these papers can't be certain that the microplastics are present in their samples. All they can be thinking of is the indicative that plastics might be there, but that's not the story that we get told in the press. And in fact, if you look, there's a lot of problems with some of the methods that we use for assessing microplastics. So these are just a few papers that I picked up. This one here says assessing the efficacy of pyrolysis, gas chromatography, mass spectrometry for nanoplastic and microplastic analysis in human blood. This is the technique that they used in the brain study. And essentially, this paper concludes that pyrolysis GCMS is not a suitable analysis method for biological matrices, right? Because it's too likely to give you misleading results. This paper down here showed that essentially lab gloves, apart from all the other stuff that you get in a lab that's made of plastic, but lab gloves have stearate. If you have a latex glove, it's got some powder on the inside to help you put the glove on. That's made of stearate or stearic acid, and that can give you false readings of microplastics for what we just discussed a minute ago, where you get the fats break down the same way as plastics do to give you the same monomer units. They showed that they got misleading readings. Even when they had black samples, they were finding plastics from the gloves. There's also a lot of background contamination for microplastics. Okay, so often we're talking about very, very, very small amounts. There's a lot of plastic sort of floating around in the air. So how do you know if you find some plastics from a sample, was it from the lab or was it background contamination from, well, I should say, is it from your sample or is it background contamination from your lab? And one group in Queensland actually went to the trouble of building a laboratory that's specifically designed to keep airborne particles from outside the lab outside. And they found that background levels of micro and nanoplastics and phthalates were over 100 times lower compared to even a PC2 laboratory. And a PC2 is where, that's supposed to be fairly well controlled for keeping microbes out or in, depending on what you're doing. If you can have a specialized lab and reduce things by 100 times, it seems pretty likely that if you don't have a specialized lab, you're going to get background contamination. And you really need to have very, very, very strict quality control on your samples if you're going to do any sort of microplastic work. Now, mass spec isn't the only technique you can use. Some people use microscopy. So another common thing that you'll see in these papers is that they'll put a picture up like this. This is again from the Nyhart study, and they'll say, look, we found some particles in our samples. But the microscopy can only say you've got particles. It can't define what the particles are. Okay, so this could be anything, right? These actually look more like biological particles to me. Lots of things will crystallize out in a body or in a tissue sample after you've extracted it and preserved it. Another method that people use, you'll see in news stories sometimes, is spectroscopy. And that can be Raman spectroscopy or infrared spectroscopy. What happens here is essentially both of these are based on light, either scattering of light or absorption of light. And this is the IR spectrum here of polyethylene. So essentially what you do is you shine a light on what particle you think is plastic, and then you look at which wavelengths of light are absorbed and which ones are transmitted, and that gives you a little spectra, and you can compare that against libraries of known samples and see what you've got. And this can be quite useful as long as you get a decent spectra off your particle. That's not always the case, particularly from plastics in the environment. They're often the surface is often roughed up, and you don't get a good spectra from it. Also, you have to do each particle individually, although there are some methods to automate it, but it's tricky to do on large scale, and it's very sensitive to sample preparation, and it's not always accurate because sometimes it's very hard to work out if your spectra could be one thing or another thing. How do you decide what it is? So there are problems with all of these techniques, and there is no one method to do it. There's no universal process on how we should be doing microplastic analysis. People use different things. When you're looking at these studies, it's good to think about, is it biologically plausible? Can stuff actually, what's being suggested actually happen? Sometimes that's really not the case. What's your background contamination? What's your confidence criteria for detection and measurement? Are you implying something or did you prove it? Did you use small sample sizes? Are you making your data available, etc., etc.? And there's a very nice article that came out in Nature earlier this year that sort of discusses all these problems, which is really good to read if you've got the time. Okay, so now we've discussed what microplastics are, what they aren't. We've looked at the analytical problems for detecting microplastics and the fact that they're often sort of understated, what the issues are. But if we assume that some microplastics do get through, then what are the risks? There are sort of two main routes of exposure to humans from microplastics. One is ingestion and one is inhalation. You do sometimes see people talking about dermal absorption, but there's no real evidence that actually happens, and it seems to be unlikely because the skin is generally there to form a barrier. It doesn't randomly absorb particles from the environment. It's actually quite difficult to get stuff through your skin. So let's look at ingestion first. Now, ingestion, I'm saying, we see reports of microplastics in water, we see reports of microplastics in food. So assuming you might swallow some particles, what would happen? Well, if they are in our food and water, we've all been drinking and eating them for many years, and we're all still here. But the gut wall is actually comparatively quite thick and well regulated, right? So it's unlikely that any particle is going to pass through the gut unless it is less than 10 micrometers in size. And even then, that's not actually proven. That's just theoretically possible. The plastics are largely inert, which is why we use them a lot in medical applications. And if they're present, they're probably just going to go straight through. Some people talk about, okay, well, maybe it's not the microplastics, maybe it's the additives in the plastic that are added. And these are compounds that are added to the polymer chain to change the properties. So it might make it more flexible or change the color or make it stronger, something like that. So there's a suggestion that maybe the additives could leach out, or maybe a pollutant in the environment has been sort of absorbed by the microplastics and then it can be released as they go through the digestive tract. So nasties like PFAS and pesticides, people go, microplastics could act like a sponge and then sort of release them again in the body. It's one of these things that's theoretically possible, but it's not very likely. And even if it was going to happen, the particles themselves are incredibly small. So even when you have, say it was actually true that we had 1,000 particles or 2,000 particles per however much, the physical amount of plastic will be very small because the particles are only nanometers or micrometers in size. It's possible that the gut lining could be irritated, but again, it's not very likely. And in fact, I tend to think these are sort of like changing the goalposts. So firstly, people talk about microplastics themselves, and then when we show there's no real evidence for harm from microplastics, they go, well, what about the additives? And then they say, what about the irritation of the gut? And then what about X, Y, Z? So, it just keeps moving. You disprove one thing and pop up with something else. So that's ingestion, but what about inhalation? What about breathing these particles in? If they're in the background, if they're in the air, could we breathe them in? I actually think this is probably an area where we could think there might be a risk, because we know that particulate pollution is a problem for air quality, and that's why we measure it quite regularly, right? Lung tissue is quite thin to allow for exchange of gases, so maybe very small particles could get in that way. But we don't know quite a lot about air pollution. We know that particles smaller than 10 micrometers can potentially get into the lungs. And that's why when you look at air quality measurements, you see things like PM10 and PM2.5 levels. For example, this diagram at the bottom here is the air quality in central Melbourne, measuring PM2.5. So that's a particulate matter less than 2.5 microns in diameter. And you can see it sort of bobbing around. When I was recording this, it was 12.2 micrograms per meter cubed. Now, the reason we look at these particles is because we know a lot about how small particles behave, and we know that they have to be smaller than 10 micrometers in order to get past the nose. So anything smaller than that, you can breathe in. But actually, as far as we can tell, most of the microplastic particulates in the air, or particles in the air, are larger than 10 micrometers, or possibly we aren't measuring the smaller ones. But let me show you an example. So this is a relatively recent study from 2024, and they were basically looking at the characteristics of microplastics in large megacities in China, in Beijing and Shanghai. Okay, so the theory was these places can be pretty polluted, and so this would probably be the place to find plastic particles if they were going to be there. So here, this bar chart, the green shows Beijing, and the sort of orangey, creamy color shows Shanghai, and you can see that most of the time Beijing is worse, but at certain parts Shanghai goes higher. But the important thing here is, if you look at the particle size, all of the particles are well above 10 micrometers. So the smallest one, possibly here, it's probably around 40. So they're just not seeing any of these really small particles. And even if they're there, when we measure PM2.5 and PM10, we measure all particulates. So we're already measuring whether there are small particles of that size in our air quality assessments. So again, yes, air pollution is a problem. We know it causes a lot of health issues, but we're already assessing it and measuring it. And plastics are, if they're there, they are assessed as part of that. Now, we're a bit short on time. I can't talk about every issue with microplastic studies, and there are more than the ones I've talked about here, but there's a few other ones. People tend to use the wrong plastic, i.e. they'll pick something like polystyrene, even though that is not the most common plastic in the environment by quite a long way, but it is quite easy to order it. A lot of studies talk about in vitro or use in vitro assays, even though they don't mimic what the body's really like. They're cheap to do, they're quick, don't need ethical approval, but they don't mimic the complex system. And a lot of studies use these really vague statements that we see in response to a lot of other chemicals in the environment type stories, where they'll talk about endocrine disrupting effects or toxicity or things like that. Well, what do you mean by endocrine disrupting? Which part of the endocrine system? What level of exposure are you talking about? What duration of exposure are you talking about for these effects? And if that's a real effect, you ought to be able to provide that information, right? But often it's not there. It's just a scary sounding headline. Now, you might say, well, that's all very well, Ollie, but why should I believe you? You're just one person. But actually, the US Food and Drug Administration and the World Health Organization have both done big reviews about the health risks of microplastics in the environment. And they both basically come to the same conclusion, which that the scientific evidence does not demonstrate levels of microplastics or nanoplastics pose a risk to human health. And these are just some of the more recent reports. You can go and look those up. The WHO one goes into a little bit more depth. Essentially, they've looked at all the evidence. There's thousands of papers on microplastics that come out every year, and they're saying, well, we don't see any evidence of harm. Now, that's not the same as saying they're safe. It's just showing that there's no evidence of harm. So then you might ask, well, if that's all true, why are there so many scary headlines about microplastics? I think this really reflects why there's so many scary headlines about chemistry in general, or chemical pollution in general. Firstly, academics and universities like impact. You're always supposed to show as an academic that your work has had impact, and media stories are a good way to show this because you can generate data on how many people read your article or how many people were influenced by it. Many people, I'm going to be blunt, many people don't understand the analytical challenges, and even doctors get this wrong, right? No one really understands it unless you do it. You don't understand how difficult it is to do and how many things can go wrong. And those that do understand the analytical challenges often don't understand the biology. It's also very easy to say something. You make a big claim and then you just walk away. You don't have to back it up with evidence. You just say, microplastics are doing X, and then, it's up to someone else. Someone else has to come along and disprove it. And it's much harder to disprove things than it is to just make general statements. Social media rewards clicks and likes, and views. So if you're trying to make money from social media, you need likes. But you're not going to get those unless you make quite emotive statements. So there's a financial incentive for print media as well to generate headlines that grab the attention and grab readers. And of course, if you're on social media, once you've seen one scary story about microplastics, the algorithm says, oh, Ollie's interested in microplastic stories, here's some more. And it just reinforces the message. So you get more and more stories saying the same thing, even though that's not giving you a representative balance of what's actually out there in terms of evidence. And of course, anyone can say anything they like on social media. There's very little regulation on it. But science works by a weight of evidence approach, right? We don't go on one study, we don't go on feelings, we don't go on vibes. We look at the evidence and logical conclusions from that evidence, which is what the US FDA and the World Health Organization have done. So next time you see a scary story just about microplastics, just think about what might be the problems with it. And in fact, think about, if you're an expert in any one area, when you see a story in the press about your particular area, you usually see there's something wrong with it because while the journalist has done their best, they're not an expert in that area. And it's the same with microplastics. It's the same with other pesticides and other things there's just a lot of misleading information out there and once it's been repeated often enough, it gets stuck. And you say it often enough, it becomes the truth, and it's very difficult to dislodge it. I think that's the end of my time. Thank you very much for listening. If you want to get in contact with me, there's my email. I'll take questions now, obviously, but you can also find me on social media and LinkedIn, and feel free to send any questions that you have, and I'll do my best to answer. Thank you.
And bear with me as I bring Ollie onto the main screen. Thank you so much to Ollie for that presentation. That was so good.
Oh, thank you.
That was really, really good. Okay, so here we are. Those in the chat, let us know if the volume is up throughout the day, and I'll correct it as we go. But the first question I will ask comes from Dan. I thought this was a really good question. As a fellow chemist and microplastic and chemistry debunker, sci-commer, I'm getting more fed up of the awful studies and misinformation on microplastic. Me too. Me too. My question is how. My question is how do we tackle fellow scientists, engineers, and sci-commers that seem to have a blind spot for the microplastic misinformation? What's your point of view?
Oh, well, that's a really good question. I don't think I've got a simple answer for you, I'm afraid. I also get a bit disappointed with the stories on microplastics and PFAS and a lot of the stuff we read about health and cosmetics. And there's all sorts of stuff. It's not just microplastics. Um, there's lots of misinformation out there, and I think we just have to try our best um, to come back with the actual facts and evidence, and try and get both points of view across, and just basically keep fighting. It does sometimes feel like a bit of a losing battle sometimes. But I have found that if you talk to journalists, they're usually reasonable people willing to listen and to put both sides forward and to listen to the facts. So I guess, yeah, keep trying. I'm afraid. I know that doesn't sound very helpful, but I think that's all we can do.
I guess this really speaks to the need for sci-comm in between disciplines because it's also interdisciplinary. This next question comes from JD, who asks, why are a lot of toxicologists saying that when you warm up food in plastic containers, a lot of plastic particles comes available, and then this can lead to a lot of welfare diseases because it's the daily exposure that eventually builds up. So the question is, are microplastics actually found in the brain or not? And if so, is the question we need to ask ourselves, is it really dangerous or actually not really for our health? That was a lot, but what do you think?
Yeah. Oh, well, look, there's quite a few questions in there. I don't know. There's only been one study, as far as I'm aware, that reported microplastics in brains, which was that Nyhart study that I mentioned in the talk. And that had a number of issues with it, I thought. So I don't think there's a lot of evidence that microplastics are in brains at all. And I think it's rather difficult to imagine how they would get there. And even if there were some there, as Michelle Wong pointed out a while back, if you really did have a plastic spoon's worth of plastic in your brain and nothing happened, that would sort of show they were quite safe. So, which I don't think is the message they're trying to get across. Um, Plastics have been around since the 1950s and 60s, and then there was a big spike in use in the 90s. So they've been around for a while. And I think if they were having large impacts on our health, there'd be stronger evidence than we have. People wouldn't have to go around making up scary sounding headlines. You'd be able to present strong evidence like they could do with smoking. In terms of plastics in food containers, there is some evidence that if you heat plastic that's not designed for certain temperatures, then you might get microplastics in the food. I stress the might, but and then other people talk about additives leaching out of plastics, which again is a so there's no actual proven harm from this. And we have to remember that food contact materials like plastics are extensively tested before they're allowed on to the market, at least in most Western countries like Australia, UK, New Zealand, Canada, etc. You can't just take any kind of plastic and sell it as a food container. You have to do quite extensive testing on the leaching and the potential breakdown, etc. And all that data is there. It's just with the regulators, it's not published because it doesn't make an exciting paper saying, yeah, hey, this is safe. It's very hard to publish that in a journal, but that doesn't mean the data's not there. It's just with the regulator that people tend not to read because it comes in a very long, complex report. So it sort of links back to the previous question that we have to do a better job of getting that safety message out there and showing that the data is there. It's not that people are trying to hide it. And even if, it doesn't make any sensible logic. If you were a manufacturer of plastic, even if all your only intent was to make money, like you still have to live in the world, your family lives in the world, why would you put something out there that was causing harm? It's just logically it doesn't make sense, and scientifically there's not a lot of evidence for it.
Now, I recently came across this perspective in a few papers on microplastic misinformation and impacts, and I would love to hear your point of view on this. That there has been disproportionate attention in the environmental related topics in the media to microplastics in terms of like the actual impacts associated with microplastics versus other things like climate change. So there's seemingly, and this was this viewpoint of the paper, more attention right now to microplastic in the media, despite the lack of sufficient evidence to show the outcomes that are reported on compared to climate change. And so they were cautioning that maybe this is creating a distraction and maybe could be seen as a climate delayism kind of thing going on with the misreporting in the media. What do you think about that viewpoint?
Yeah, look, I actually agree with it. I haven't come across that myself, but I think it's a good point that we have all these scary stories about microplastics, which I think probably are there because it's like climate change is quite esoteric in some respects. It's hard to connect with it if you're not a climate scientist, and it's not something you can go and see by looking out of the window or going down to the beach. Those changes sort of happen slowly, but you can, if you're a member of the public, it's easy to connect with plastic waste. You've got plastic in your house, you might see plastic rubbish. So that story has that sort of personal connection. And that helps, newspapers sell papers, influencers sell videos and so forth. But it does distract from real problems. So we have a lot of people really worried because they read all this stuff in the press about microplastics, PFAS, pesticides, all these other things that it really just does distract us from big problems that we really have to sort of think about, like climate change. So yeah, I agree with that message.
And I find it also does, it misinforms about the material and environmental impacts of packaging. And so maybe we're opting for options that may have substantially higher environmental impacts and causing like a net harm in terms of what we're using. In terms of, in cosmetics, we're frequently switching to like glass packaging. From a carbon emissions point of view, there's a lot of other aspects where if you look at an LCA, it has a higher impact. But from an emissions viewpoint, that seems like it's bad. What do you think? I guess it's really complex, and maybe this is the challenge. It's complex, and people are looking for simple solutions.
Yeah, well, I think you hit the nail on the head there. Yes, it is a complex situation. Toxicology is a complex science. Material science is complex, and there isn't an easy answer. But in today's news cycle, people seem to want very quick, sound bites like that. And is it yes or no? Is it a problem? Is it not a problem? And you have to take the time to think about all the ins and outs of it. If you replace plastic bottles with glass bottles, they're heavier, so it takes more fuel to transport them, so they bring more greenhouse gases. It's not that glasses are safer than plastic; it just has other risks. If you drop a plastic bottle and it shatters, you've got an issue. But we hear a lot of negative stories about plastic, but we never hear any positive stories, like all the benefits it brings to medicine, or saving greenhouse gas emissions from transporting lighter bottles, or being safer because it doesn't shatter into a million pieces if you drop it.
Or
So that balance
waste reduction. Or waste reduction. There was a LCA specific to cucumbers that I came across. This next question comes from Anna, who asks, have there been any animal studies looking at microplastics in brains?
Well, it's a good question. I'm not, on the top of my head, I can't think of any. That doesn't mean they don't exist. It's just that I can't think of one off the top of my head. It's a bit tricky because you have to sort of. It's a very tricky experiment to do. You can't take an animal and just open it up and pour some plastics into the brain and see what happens, because sort of even if you could do that without killing it, that would actually have an impact in itself. So you can only really look at sort of associations and potentially feed the animal plastic and see if it got through to the brain. Usually that doesn't happen. They have actually done some experiments. I think there was some done with Teflon where they were showing that they fed the animal plastics to see if it would stop them eating as much because they felt full because the stomach had plastic in it. Now, I don't think that's a good idea, but it didn't affect their brains. The plastic just sort of passed through.
This next question comes from JD. Oh, and Dan, I see your question about the review. I will have to look at it. I'll have to look through all my sources, but I will try to find it, and once I find it, I'll put it in the chat. Okay, this next question comes from JD, who asks, any books or websites that you would suggest to... The question is understand how the body works and learn, but maybe I'll reframe this because I'm not sure if that's your direct wheelhouse, but I mean, correct me if I'm wrong, but specific to this topic, would there be any books, articles, or other resources that you'd recommend people look to for more information past this presentation? PDFs will be available for the presentation after the fact, and this was so thorough. It was really, really good.
Oh, thank you. I think well, look, I don't think there's any specific book. I used to teach molecular biology when I was at Cambridge. Now we use Molecular Biology of the Cell by Albert, but I presume they're referring to the comment saying that people don't understand how biology works in my talk. And it's just generally like you can't necessarily things. How do you absorb particles from the digestive tract? Well, there's biological membranes usually are there to control how things cross, right? Same with dermal absorption. Your skin is generally there to keep things out. It's hard to get stuff through the skin. Your brain, if you're a pharmacologist, getting things past the blood-brain barrier is extremely tricky. So a lot of the times we see claims in the media about, this chemical does this, and it's just not biologically plausible. Like endocrine disruption is a good one. Like it's a very vague term. The endocrine system is quite complex. Which hormone do you mean? Now, most of the time when people say endocrine disruption, they mean estrogenic or anti-estrogenic effects. But even then, that's a very complex system. Are you alleging that you're stimulating the the estrogen receptor? Are you stimulating it more than natural estrogen? Are you blocking the action of any of the male hormones, and therefore sort of seeing more female hormones having an effect? Sometimes it's just the stuff they say just doesn't make sense from a biological viewpoint. So if you know a little bit about how the body works, you can go, well, hang on, just a bit of logical thought, that doesn't work like that. There's a really good on one of your podcasts, Kyle Burgoon does a very good description of the endocrine disruption and why it doesn't necessarily mean what we think it means in the press.
And stay tuned. We'll have a whole presentation with one of his co-authors on some of his work, Dr. Chris Borgert, who also is going to come on the podcast later in the season when I relaunch, which is probably going to be next week. Thank you so much, Ollie, for contributing to the eSummit. This is all the time we have for this chat or this Q&A live, but if you feel like it, there's still more questions that have been coming in the live chat. So if you feel like going over to YouTube, by all means, people are still asking you questions. But yeah, thank you so much, Ollie, for contributing your time and expertise to the summit.
No, thank you very much for having me.
Our next presentation will be on the topic of misinformation. What is it? What do we know? This is going to be presented by Danielle Shine, who is an accredited practicing dietitian and PhD candidate studying nutrition misinformation on social media. After personally experiencing the misinformation rabbit hole, she became committed to researching how it spreads and strategies to counter it. Alongside her research, Danielle is a science communicator who uses her platform at danielleshine.dietitian to share evidence-based insights and promote critical thinking about nutrition. Without further ado, here's Danielle.
Hi everyone, thanks so much for tuning in. I want to start by defining a couple of key terms that are central to this presentation. Because did you know, there's no single universally agreed upon definition of misinformation. In 2023, El Mikatai and colleagues conducted a scoping review of health-related research and identified 75 different definitions for misinformation and related terms. These included 20 definitions of misinformation, 19 of disinformation, 10 of fake news, 24 of infodemic, and 2 of malinformation. Despite some variability in terminology, most definitions were broadly consistent in their core meaning. For example, disinformation is almost always described as false or misleading information that's intentionally created to deceive, manipulate, or cause harm. Definitions of misinformation, however, were far less consistent. Specifically, 7 described it as unintentional, 5 said it's intentional, and 8 didn't mention intent at all. When we don't have a shared definition of what misinformation actually is, we can't reliably identify or track it. It also makes designing comparable research and coordinating effective, unified responses much harder. And even when misinformation is detected, identifying the intent behind it isn't straightforward. For example, a false claim might begin as a deliberate attempt to deceive, but once it's out in the world, people who genuinely believe it may reshare it, not to mislead, but to inform or protect others. At that point, the intent behind the misinformation shifts. And as it spreads further, tracing it back to the original source or understanding why it was created becomes nearly impossible. These challenges are even more pronounced when it comes to science because scientific knowledge evolves, new findings emerge, and the line between accurate and inaccurate information isn't always clear. So to help bring some clarity to this issue, the National Academies of Sciences, Engineering and Medicine convened a committee in 2024 to take a deeper look at science-related misinformation. In their published report displayed on this slide, they examine the sources, spread and consequences of science misinformation and present evidence-based strategies to help mitigate its harms. As part of this work, the committee introduced a clearer definition of science-related misinformation. They describe it as any information that asserts or implies claims that are inconsistent with the weight of accepted scientific evidence at the time, taking into account both the quality and quantity of that evidence. This definition focuses only on the accuracy of the information itself, not the intent behind it, because even well-meaning misinformation can still cause harm. As part of this new definition, the committee emphasises another key point. What we call misinformation isn't fixed because science is always evolving. So a claim supported by today's best evidence could be overturned in the future if stronger, more reliable research emerges. As for disinformation, the committee defines it as a subcategory of misinformation, specifically false information knowingly shared by individuals intending to mislead. So in other words, it's misinformation with intent. However, the authors stress that proving intent is difficult and ultimately it's the impact of the information, not the motive behind it, that matters most. Okay, so with those key definitions clarified, let's explore some of the reasons why people fall for misinformation and why changing their minds can be so challenging. First, it's important to recognise that no one is immune to misinformation. A recent meta-analysis by Salton and colleagues found that higher education doesn't necessarily improve a person's ability to distinguish between true and false information. In fact, people with more education were just as likely to fall for misinformation as those with less, showing that education alone isn't enough to protect us. Personality traits like extroversion, narcissism, psychopathy, and Machiavellianism can also influence vulnerability to misinformation. And our worldview, values, and identity also strongly influence how we interpret what we see and hear. So just briefly, our worldview is the lens through which we interpret everything around us. It's shaped by our beliefs, assumptions, and life experiences. Our values are our guiding principles, so things like freedom, safety, or equality that influence our priorities and decisions. And our identity is how we see ourselves and the groups we belong to, whether that be political, religious, cultural, or otherwise. Together, these factors act as filters. They shape what we notice, who we trust, and how we interpret information. Of course, they're not the only factors that can make us more vulnerable to misinformation. Many other cognitive, social, and emotional factors can also play a role, and I'm going to touch on some of the main ones now. starting with literacy, and not just the traditional kind. We often think of literacy as the ability to read and write, but really that's just the foundation. In today's complex information landscape, we need a broader set of literacies to confidently separate fact from fiction. For example, we need media literacy, which is the ability to critically evaluate media content, whether that be news, social media, or online videos, and ask questions like, is this accurate? Is this balanced? What's the source? Could this be misleading? It also involves recognizing sensationalized headlines and emotionally manipulative images. Closely linked to media literacy is digital literacy, which involves understanding and navigating the online world. This includes knowing how algorithms influence what we see, why certain content appears in our feeds, and how it can be amplified or suppressed, often to promote specific ideologies, agendas, or commercial interests. Then there's scientific literacy, which is the ability to understand and interpret scientific evidence. It involves knowing what makes a study reliable, how scientific consensus forms over time, and how to distinguish credible science from pseudoscience. Another important literacy is health literacy, which helps people access, understand, and use health information to make informed decisions. This includes interpreting medical advice, evaluating treatment options, and recognizing when health claims might be misleading or inaccurate. And then there's food literacy, which encompasses the knowledge, skills, and behaviours required to plan, manage, select, prepare, and eat foods to meet nutrition needs. It also involves the ability to critically assess nutrition-related information to make informed choices and identify misinformation. All of these literacies exist on a spectrum. For example, someone might have strong media literacy but limited food literacy, and that imbalance can influence how they interpret nutrition information and make food choices. In addition to literacy gaps, the way we process information, commonly referred to as our cognitive processing style, can also influence how vulnerable we are to misinformation. System 1 thinking is fast, intuitive, and automatic. System 2 thinking is slow, deliberate, and analytical. Neither is inherently good or bad. System 1 thinking is essential for quick adaptive responses, like slamming on the brakes to avoid a car accident. But because it operates so quickly, it can also make us more likely to believe false or misleading information, especially on social media, where everything moves fast. In contrast, System 2 thinking supports deliberate, reflective analysis, helping us to slow down and think critically. In other words, it can act as a protective factor against misinformation, and research supports this. For example, Swamy and colleagues found that people who rely more on System 2 thinking are less likely to believe conspiracy theories, which often overlap with misinformation. And Pennycook and Rand showed that individuals with stronger analytical thinking skills associated with System 2 thinking are better at identifying trustworthy news sources and less likely to fall for false ones. Importantly, heavy reliance on fast System 1 thinking increases the use of mental shortcuts, known as heuristics. These shortcuts operate unconsciously. We're rarely aware we're using them. They help us make quick, efficient decisions without analysing every detail, but they also increase our vulnerability to misinformation, especially in fast-paced digital environments like social media, where we're constantly scrolling and reacting. Some key heuristics to be aware of include the simplicity heuristic. This is our natural tendency to trust information that's simple and easy to process. When something is clear and straightforward, it can feel true because it takes less mental effort to understand. That's why claims like the ones on this slide can feel intuitively right, even if they're false or misleading. Misinformation often exploits this heuristic by being simple, catchy, and easy to remember. Another mental shortcut that can make us more vulnerable to misinformation is known as the repetition heuristic. This is closely linked to what's called the illusory truth effect, which is the tendency to believe information simply because we've heard it many times before. When something is repeated, it feels familiar, and our brains often mistake familiarity for truth. Social media supercharges this effect. False claims can be shared thousands of times, making them feel true just through sheer repetition. So that's why simple myths, when repeated often enough, can start to feel true even without evidence. We're also more likely to believe information from people we trust or feel connected to, even if we've never actually met them. This is called the trust heuristic. A lot of misinformation spreads this way. Trust in a friend, family member, or public figure can make false claims seem credible. This is especially common online, where parasocial relationships, which are one-sided emotional bonds that many people form with influencers or celebrities, can make their words feel even more credible, even when they're not. Emotions can also play a powerful role in what people believe and share. When misinformation triggers strong feelings like fear, anger, or outrage, it's more likely to be accepted without people pausing to check the facts. This is called the effect heuristic. For example, misinformation claiming that food companies are poisoning children with certain ingredients often sparks fear and anger, especially among parents, and prompts immediate sharing to warn others. This reaction comes from fast, automatic System 1 thinking, which leaves no room for careful analysis or fact-checking. And misinformation that spreads quickly online is often simple and emotionally charged. We don't always evaluate information on our own. Sometimes we look to what's popular or widely accepted to decide what to believe. This is known as the social proof heuristic. On social media, content with thousands of likes, comments, or shares can seem more credible just because it's popular. And that can lead people to think, well, if so many others believe this and are doing it, there must be something to it. But popularity doesn't equal accuracy, and online those two are often dangerously out of sync. For example, some influencers promote highly restrictive diets, like the carnivore diet depicted on this slide, which involves eating an animal-based diet consisting of foods including raw or cooked meat, raw or cooked eggs, sticks of butter, and sometimes raw dairy. Bold anecdotal claims are made about it healing the gut, skin, or overall health, and it's often paired with misinformation about plant-based foods like vegetables, fruits, and grains being dangerous to health. Because this content gets a lot of engagement and many people comment or share their own positive experiences, it can seem credible, especially for those with lower food or health literacy. That said, heuristics aren't inherently bad. They're essential for navigating daily life. For example, we might grab an umbrella because the sky looks dark, or reach for a familiar brand at the store without reading every label. In these cases, heuristics can help us make quick, reasonable decisions without overloading the brain. Problems arise when heuristics are applied in situations that need careful, analytical System 2 thinking, like evaluating science-related claims on social media. Defaulting to quick judgments in these moments can leave people vulnerable to misinformation that looks trustworthy on the surface but doesn't hold up under scrutiny. Now, beyond heuristics, it's also important to consider cognitive biases and how they shape the way we process information. Biases are systematic patterns in our thinking that can distort judgment. They act like built-in lenses, shaping what gets noticed, how information is evaluated, and even which memories come to mind. Most of the time, biases operate automatically, often without conscious awareness. Many stem from the mind's reliance on heuristics as a way to conserve mental effort. A common bias that can increase vulnerability to misinformation is confirmation bias. This is our natural tendency to seek out and trust information that confirms our existing beliefs, while ignoring or dismissing anything that challenges them. The cartoon on this slide illustrates it perfectly. Someone claims to be doing their own research, but in reality, they're just clicking on the first link that supports what they already believe. So many people fall into this trap without realizing it, because having beliefs confirmed feels familiar, comfortable, and reassuring. Confirmation bias also interacts with other cognitive shortcuts, which, as mentioned earlier, makes repeated claims feel more true, even when they're false. There are many cognitive biases that can increase our vulnerability to misinformation, far more than I can ever cover in this presentation. But if you're interested in exploring them further, I recommend checking out the Catalogue of Bias maintained by the Centre for Evidence-Based Medicine at Oxford University. Beyond individual psychology, the environments we spend time in, especially digital ones, can also shape what we see, believe, and share. One of the biggest forces behind this is the algorithm. Social media algorithms are designed to maximize engagement and keep us online as long as possible. They personalize our feeds by showing more of what we've already watched, liked, commented on, saved, or shared. They also promote content that generates high engagement, regardless of its accuracy. So algorithms don't just reflect what people are interested in, they can also increase the likelihood of being exposed to misinformation. One way they do this is by creating echo chambers, which are digital spaces where people mostly encounter content and opinions that align with their own. The same perspectives are repeated again and again, which plays into the repetition heuristic. Researchers don't always agree on how widespread or severe echo chambers are across platforms and topics, but evidence shows that algorithms can reinforce existing beliefs and help misinformation to spread. Algorithms can also create filter bubbles, where content is tailored to match existing preferences. Instead of being exposed to a diverse range of views, users mostly see information that reinforces what they already believe, while other perspectives, including more balanced or corrective content, can get filtered out. This fuels confirmation bias and creates a feedback loop where engagement tells the algorithm to show more of the same, which helps misinformation to spread. That said, echo chambers and filter bubbles aren't always complete or uniform. Their impact can vary based on the platform, the topic, and the user's own behaviour. Not everyone is equally affected. Some people actively seek out diverse views and sources. But for people who are unaware of these dynamics, echo chambers and filter bubbles can make false information feel familiar, trustworthy, and true. Additionally, algorithms don't just decide what we see, they also influence how far and fast information spreads. And when it comes to misinformation, that spread is especially rapid. For example, Visagi and colleagues analysed over 126,000 stories shared on Twitter by around 3 million users over 11 years. They found that false information consistently outperformed truthful content. On average, it was 70% more likely to be retweeted and reached large audiences much faster than accurate information. This speed and reach make it extremely difficult for fact-checking tools and experts to keep up. By the time corrections appear, the damage is often already done. Misinformation has often already spread, reached large audiences, and influenced what people believe. In other words, the rapid spread of misinformation is a major challenge for anyone trying to counter it. Anyone who's ever corrected misinformation knows how time-consuming and resource-intensive it can be to produce clear, well-researched evidence-based responses. This imbalance is captured by Brandolini's law, an adage which states that it takes significantly more effort to refute misinformation than to produce it. Unlike misinformation, which can be created quickly, corrections take time. They require fact-checking, credible sources, and jargon-free explanation, so they're easy to understand for a wide range of people with varying levels of literacy. And even when corrections are made, they're not always successful. The same factors that make people vulnerable to misinformation, like System 1 thinking, heuristics, and biases, can make it hard for them to change their minds. The continued influence effect can also play a role. This is a psychological phenomenon where people keep relying on misinformation even after seeing a correction. Another major barrier for people is their distrust towards the source providing the correction. This distrust is often fueled by anti-intellectualism, which is a mindset that dismisses expertise and values personal intuition over evidence. It fosters skepticism towards institutions like universities, public agencies, and qualified professionals, portraying them as elitist or out of touch. Unfortunately, many influencers, activist groups, and others who spread misinformation actively amplify this distrust. One common tactic they use is called the shill gambit, which is an ad hominem attack, also known as a poisoning the well fallacy. It accuses experts of having hidden agendas or financial ties to industries like food, pharmaceuticals, or biotechnology. The shill gambit is effective because it diverts attention from the facts and exploits people's natural skepticism towards these industries. It undermines credible voices before anyone even has a chance to engage with the reliable information they share. With all this said, while misinformation is undeniably tough to fight, we're not powerless. There are practical evidence-based strategies we can use to push back effectively. One of the most useful resources on this topic is the Debunking Handbook, published in 2020 by leading cognitive scientists and misinformation experts. It offers practical guidance on how to correct misinformation while minimizing the risk of accidentally reinforcing it. The authors explain that although fact-checking does help reduce belief in false claims, misinformation is often sticky. This is largely due to the continued influence effect, which, as mentioned earlier, occurs when false information continues to shape people's thinking even after they've seen a correction. To address this, the handbook recommends preventing misinformation from taking hold in the first place wherever possible. This means proactively teaching people about the deceptive tactics often used to spread misinformation. When people know what to look for, they're more likely to spot and reject these tactics. This preventative approach is called inoculation. It helps to build resistance to manipulation. Inoculation works best before exposure, but staying ahead of misinformation isn't always possible. Often people have already encountered false claims by the time a correction reaches them. So in these cases, the next best approach is clear, evidence-based debunking. And according to the debunking handbook, simple corrections on their own usually aren't enough to fully unstick misinformation. Just highlighting something as questionable or pointing out that it comes from an untrustworthy source isn't typically enough, especially if people have been repeatedly exposed to misinformation. Debunking is more likely to succeed when it includes 4 key steps. The first step is to present the truth in simple, easy to understand language. This establishes the context for what follows. Corrections should be just as clear and visible as the misinformation, not buried or vague. Don't just say, "This isn't true." Provide a straightforward, factual explanation that fills the same gap the misinformation created. This helps people swap false beliefs for accurate information. Be careful not to make the correction more complicated than the misinformation itself. For complex topics, explain why the false claim is wrong before presenting the correct information. Step 2 involves stating the misinformation, but only once, immediately before correcting it. One repetition can help people update their beliefs, but repeating a false claim too many times, even to debunk it, can actually make it feel more true. So mention it once, correct it, and move on. Encourage critical thinking by prompting people to consider where the claim came from and why it was shared. Step 3 involves explaining why the misinformation is wrong. So don't just say it's false. Explain why it may seem believable, why it doesn't hold up under scrutiny, and what's actually true. Highlight any logical or argumentative fallacies if possible, because this helps people update their beliefs and become more resilient to misinformation across a wide range of topics, not just the one being corrected. And step 4 is to end with the truth. So finish by repeating the accurate information so it's the last thing people hear. And try to reinforce it over time, because misinformation can creep back in if corrections aren't sustained. So ultimately, effective debunking isn't just about setting the record straight. It's about building understanding, fostering people's trust, and encouraging them to think critically. People are better able to resist misinformation when they recognize their own vulnerability to it and are supported to spot manipulative tactics. With ongoing education and thoughtful corrections, minds can change, trust can be rebuilt, and truth can break through, even in a noisy, engagement-driven world. Now, with all that said, changing minds isn't always easy. Resistance, frustration, and setbacks are all part of the process. But it's worth the effort, because as this image so cleverly illustrates, misinformation isn't just harmless noise. It's an ever-present threat that can mislead people, cause real harm, and make it so much harder to make informed decisions. In fact, the World Economic Forum's 2025 Global Risks Report identified misinformation, along with the technologies that help it to spread, like social media, as a major global threat. That's why it's so important to understand how misinformation can infiltrate our thoughts and shape our beliefs, to regularly examine our own assumptions and biases, and to be mindful of the influence we have through what we choose to share and discuss. And that brings me to the end of my presentation. If you've made it this far, thank you so much for listening. I hope I've been able to shed a little light on what's ultimately a very big topic.
And bear with me as I bring Danielle over to the main screen for the Q&A. And here we are. If you guys have questions for Danielle, please ask them in the chat. I have a few of my own questions. The first question that I will ask, as people are thinking about their own questions in the chat, I told you ahead that people always have questions.
Our next presentation will be on the topic
Sorry, just 1 second.
Misinformation.
It just gave you guys more time. Sorry, the presentation started running again.
Oh no!
I forgot to exit it.
You don't want to hear me twice.
No, I was hearing me for your bio. There's a question that came up. I'll ask it before I start asking my own questions. Okay. So this question came from Dan. I hate the paid shill fallacy, but do you have any tips for when we have to do similar when reports are funded by misinformation generators? For example, reports from the EWG, PAN UK. I don't know that group. And others. Certainly I know EWG, and really good question. What do you think, Danielle?
Yeah. So what was that in a nutshell? When someone creates a report and uses the shill gambit against us, qualified professionals?
Well, the question is more around, people will direct that to us of we're paid shills. However, what if there's a report that's generated by, like, for example, the EWG, and probably, I know I do, you point to the fact that EWG isn't a reliable place to find information kind of thing. So how do you think about using that? Because it kind of is pointing at the shill gambit, like kind of along those lines. Or how do you fairly, honestly use that for debunking, pointing out?
Well, I think, yeah, I know what you mean. So Dr. Andrea Love and I we actually collaborated on content recently related to the EWG. So I'll use that as an example, because we shared a carousel of just essentially debunking the dirty dozen, but we did include a slide to talk about their funding, but it was wrapped up in more than just their paid shills. We brought a lot to the table. So I think it's really important to not only, with the shill gambit, with people like us, with qualified professionals, it's often just who paid you to say this, but they really can't poke holes in what we're saying because it's evidence-based. But when it's the other way around, I think it's really important to educate as well as to point out, and also pick your battles, because sometimes it's really not that important to actually share that information. It just depends on the context. So for Andrea and I, we made a call because it was important to also point out, as part of the dirty dozen, as part of this demonization of pesticides and, conventional produce, that it is important to know that they're being funded by organic brands. That's a really key part of the information to share along with everything else we were sharing. So I really think it depends on the context, but I absolutely encourage people to still share that information, because I think if you're sharing it wrapped up in education and also you've got evidence to support your counter argument, I think then it's very different to the shill gambit where someone's accusing us of being paid and has absolutely no evidence whatsoever that we are being paid in a nefarious way as well, because we also have to acknowledge that it's okay for scientists to be paid to do science. So I encourage people to go and have a look. There was a collaboration that I did with Dr. Andrea Love and Dr. Katie Tulita. We actually addressed the shill gambit and we also included that information. So feel free to go and have a look. There's some good talking points on there. Hopefully that answered the question.
I think it did. And this also brings up, when people are looking at studies, I have seen from certain accounts that they will immediately discount a study if it was funded by a certain group. But sometimes certain topics make sense for a certain group to fund it, because who else is going to? There was an example that came up on my podcast a little while ago about like the mushroom industry funding some study about the health impacts of mushrooms. Like, who else is going to do that?
Who's going to put the money forward? Exactly. Exactly. Yeah. Yeah, that's a really, I have spoken to multiple people about that. I am a tutor at university, and I speak to my students about this, and we talk about, we always look at limitations of studies, and we always look at conflicts of interest. We have a look at the entire study as well. So that also, I think, has to be wrapped up in education to educate the people about the particular study, and again, the context. I think, we're all qualified professionals, people that are watching now that have gone through uni, that have gone through multiple units about how to actually critically assess research, understand how to see a study and have a look at when a conflict of interest is likely weighing in on the overall findings, and when it's not. As you said, when it's research that's important, but who's going to fund it in order to find the information that we want to find. So again, I think it's, we are in industries filled with nuance and context, and I think it's our job to, hold space for each other and educate. It just comes with a lot of education and also patience, because it's not easy. We're not always going to get through to everybody as well. So I don't think there's a one size fits all approach to it.
This next question comes from Key. Is this how you say your name? Please correct me if I've said it wrong. But the question, first, hi. Not sure how to word this, but how do we get more used to processing info with System 2 in environments that rewards quickly processing information, such as on social media?
That's a great question. So I think the best way is just practice and awareness. And I mean, for me, and this is, one, N equals one, but for me, I did a lot of reading, and I did a lot of, as a dietitian, when I become a dietitian, there's a lot of reflecting that you do on your own practice, on your own professional development. And part of that is wrapped up into, like, what are my biases? What are the heuristics? What are shortcuts? So System 1, System 2 thinking really comes into that. So it's sort of in your face all the time when you are reflecting on your own practice. There's a really good book. It's everyone, I'm sure people have heard of this. It's Thinking Fast and Slow by Danielle Kahneman, who is like the godfather of System 1 and System 2 thinking. So, I mean, it's a great, really accessible book. And I think the more that you practice your awareness, the more that you remind yourself when you're on social media, hey, this tool encourages System 1 thinking, the more likely you are to be aware of that, and you're going to go, hang on a second, especially when it's like a claim or it's content that resonates with you. I think get into the habit of really stopping, taking a beat, and thinking, okay, I'm actually going to think this one through. I'm going to cross check. It's a little bit clunky at the start, but it starts to become more common and more comfortable the more you do it. But I think increasing awareness, reading books, reading about it.
Yeah, I guess critical thinking involves being critical of your own thinking, but like any skill that you have, It takes practice. This next
really
question comes from Ollie, who asks, why is being funded by industry often seen as a problem by many, but a study funded by, say, an environmental NGO is not seen as a potential conflict of interest?
Yeah, look, I think we've just got some very clever, intentional, manipulative behavior. And as I said in the presentation, there are influencers and activist groups, and there's people that are, they push this kind of narrative, and it's very frustrating because it's popular and it feeds into whatever misinformation these people tend to push, but it's become part of the furniture of their narrative, if you will. So I think people have become trained to just anything that pushes against what they already believe. It's like almost like a default button that's happened where people would just think, well, they're being paid. And it's really unfortunate. And I think, again, it's got to be part of our debunking strategy to educate people about the fact that it's okay, again, for a scientist or a dietitian to work in the industries that they work in and be paid for it. And I think it's wrapped up in that greater strategy of building trust with our audiences, and that takes time. It's going to take time, and it's also the way we communicate to people has to be different. So I think it's a great question, and I do think that there are some really nefarious actors out there and then I think there's some people that don't even intentionally do it. They just get wrapped up in the narrative of just pushing, parroting the fact that we're all paid shills, which is very frustrating.
Yeah, I guess this maybe when you're looking at information sources could be a red flag if that's where they stop. If they stop with funding sources, because I see this a lot with studies. I'll cite a study and they're like, but this was funded by that. But that's like, yes, when you're reading studies, you should be aware of funding sources and potential conflicts of interest. That's a part of critical appraisal, but it's not like all of it. You have to then critically appraise and do some hard work there. There is a final question I think that we have time for. It's just to rehash a name that you brought up, and I'm sorry I don't remember the name, but it's from Fran Japan, and I should know the name because I've read the book. What was the name of that person that wrote the book? The book
Daniel Kahn, Thinking Fast and Slow, Daniel Kahneman. I think the spelling is Kahneman. Excellent book. Highly recommend.
Oh, I'm going to ask one more question because I think it's really good. And after your presentation is Mo's presentation, but then it's going to be a break. So we have a little bit of a buffer here. So this question is from Dan again. I think it's really good. Who is currently writing an article on this topic. The question is, how do you think we should educate people on how to read peer review? So many people can't read the English or chemistry papers, even if they're educated. I have a lot of thoughts on this, but should we be encouraging people to read studies? I think I've changed my mind on this. Maybe a little cursory, check to make sure that that person is saying what the study is saying. But then that's only the tip of the iceberg of what you need to be doing there. Was that a good study? So yeah, what do you think about this?
I've thought long and hard about this, especially because I teach university students, and part of what I teach is we start, these are first year nutrition. They're doing this nutrition unit, they're first year students. And so even just the basics, we don't even get to, really fully analyzing a research paper, but teaching them the basics, but then it's a weekly thing as well. So it's really important that the education is ongoing. I don't think we can teach someone in a social media post. I don't think we can. It would have to be so well thought out, and I get very nervous about trying to teach people where we don't really have that direct one-on-one content, because it's so easy for people to misinterpret if they don't have options to ask us questions, and it's not a two-way conversation. I think it's a very challenging thing to do. I mean, look, I'm not one to gatekeep either, but I think about my own experience and the multiple units I had to do to really understand. And I feel like still to this day, as a PhD researcher, I'm always double, triple checking that I'm understanding the study, that I'm critically analyzing it correctly. I think it's an ongoing practice. So I just question how challenging it would be to teach people and how we would do that in a safe manner that wouldn't accidentally cause them to become overconfident with looking at research, misinterpreting it potentially, and also then perpetuating misinformation. So I don't think I have the perfect answer to that. Sorry about my clunky response. And I do waver. I'm a big fan of educating people and empowering people with education. I think that's so crucial. But when it comes to research, I mean, we've all been through it. Watching anyone that has a degree in science or health or nutrition, you will remember the multiple units that we did, and the examinations and the papers that we did, and how long it takes, the dedication it takes to really understand a study and critically analyze it perfectly. And again, perfectly is a terrible word to use, but I don't know. I think there's a possibility there to maybe teach the basics, but I would have to. It would have to be a collaborative. It would have to be a collaborative, peer-reviewed thing for me if I was going to jump into that. What do you think, Jen?
So I actually bring this up in my presentation later on the day, and I truly think that this
Excellent.
is part of the value of science communication. This speaks to, I bring it up in my presentation, but I'll just say this speaks to a study that was published in, I think it was 1992 by Nature, about the increasing inaccessibility of science. And people like to point that it was behind a paid wall, but that was not the point of the study. The point was because it is becoming increasingly hard for non-specialists to understand different areas of science because it's getting so complex. So, for example, if I, who doesn't have a background in neuroscience, go and read some new study about neuroscience, I will not have the skills, the knowledge of the jargon, the knowledge of the appropriate methodology to legitimately, I might delude myself in thinking this, which a lot of people do, but sufficiently, oh, was that rude? Critically appraise this study. And so what would be more appropriate for me would be to look at something like, so a form of science communication in science would be like an academic review. That's not perfect because it depends on like what's got in the review. So that's a challenging space, but there's a huge opportunity even within science for science communicators to help other scientists in fields that are not their own understand that field so we can all collaborate better. The value of science communications. Yeah. Stay tuned for my presentation.
Look forward to that.
If you're still awake, probably you won't be. Oh, wait, no, it's the morning for you. Okay. No, it's the evening for you. It's the evening for you.
Oh.
You won't be awake, probably, hopefully. Thank you so much.
I'll watch the replay.
Thank you so much to Danielle. I have quite a few Australians presenting today. And so to all of my Australians or people in like weird time zones for this, what time is it for you right now?
It is 11:30 p.m.
Yeah. I would have a hard time with that. So thank you so much. Thank you so much for agreeing to participate in the summit. Pleasure. Really, really great presentation. And with that, that concludes our Q&A here and Danielle's presentation.
Bye.
Our next presentation will be on putting product safety into context, featuring Mo Kanadil PharmD. Mo is a toxicologist, cosmetic safety assessor, and science communicator, best known for his platform, Mo Skin Lab. With a background as a pharmacist and lab technician, Mo shifted into regulatory toxicology after earning a master's degree in safety assessment and toxicology. Today, his work focuses on skincare and product safety, and he uses his channels to break down complex science into practical, trustworthy insights for consumers. Without further ado, here's Mo.
Hello, everyone, and welcome to my presentation that tackled the topic of safety. A quick introduction. My name is Mo Kanadil, and you can call me Mo. I'm a pharmacist, toxicologist, and personal care risk assessor, specifically cosmetics. And I just want to say a few words of thank you and appreciation for the organizers of this event. I know how difficult it can be to organize a event, especially in this industry, providing free and accessible information and elevating the true expert behind the scenes. So thank you for this opportunity, and I really appreciate it. So let's begin with the first slide that tackle the definition of safety. So before we want to understand any type of new topic or a new context, we need to identify it. And there is no better way of identifying things if we have a definition of it. And if we go to the basics of definition of safety when it comes to the literate definition, if we go to the Oxford University dictionary, as you can see here, as I'm using my laser pointer, it's free from hurt or damage or unharmed. If you take a second and look at this definition, you will understand that we are not defining the safety itself and what is safe. We are defining the opposite. It's something that means the non-existence of the opposite. So safe is non-existence of harm or damage. So that is why I use this cute ghost to describe safety, because it's something that we cannot measure. We measure the opposite, the harm that could happen. And when we switch to the context or the concept of safety when it comes to personal care product, the whole definition, the whole concept can get a little bit more complex. And what we measure to detect safety in cosmetic is called risk. And risk is how likely and the probability of this damage happening to you when you are using a specific ingredient or a specific personal care product. And when the risk is low, then that means the safety is high of this ingredient or of this product. And when we look at risk in the personal care space, or specifically cosmetics, we can see it's a collision of multiple concepts and definitions. We have the exposure, the hazard, and I added one, the susceptibility, which is not talked a lot about online. But as a quick run through the definition, the hazard is the intrinsic property of the chemical, what it can do if we give it at very high doses or at very low doses. So we unleash the true power of this compound or chemical. And in general, it answers the question what it can do. For the exposure, it's pretty simple. How much are we getting exposed to? How much of this chemical that we are studying, its risk, are we going to be exposed to when you are using an ingredient that is part of the formulation of the product that we are purchasing or using. And there is the susceptibility, which is describe the differentiation between us as a human, because when it comes to the adverse effect and negative effect, us human are not equal. What I mean by that, if I'm exposed to a certain chemical, if I have the genetic predisposition to be more sensitive toward that chemical, I can have a negative side effect or adverse effect compared to another person using the same amount of this chemical and being exposed to the same amount of chemical, having zero adverse effect. So, and part of the context that the safety sometimes is removed from, which is safety in general, if we just think about it logically, should mean one thing, but for everyone around the earth. It's something that we say it's something that does not cause damage. But here I just want you to understand that when it comes to personal care product, and the where you are geographically located, in which country, in which coalitions of country, the regulators and lawmakers can achieve the goal, the end goal, which is safety, in very different ways, in very variable ways. For example, let's take the EU, for example. They will tell you, and I will use an analogy of the activity of swimming because it can carry a risk, but it's also enjoyable at the same time. So the EU tells you cannot go into the swimming pool without having some type of safety equipment like the life jacket and some type of eye protection, and then you can go swimming. In the US, they tackle the issue differently. They say you can use no equipment, no safety equipment, but you have to prove that or provide us with a certificate that you can swim, that you finish a course about swimming, and that you can float in the pool without any type of help, and then you can enjoy the swimming. In the Middle East, which is a situation is a little bit more complicated, where I'm based, and we don't have a harmonized regulation around the region, but we have kind of like similarities when it comes to the regulation and safety of cosmetics. We will tell you to use arm floaters and some type of breathing tube and sometimes of eye protection as well. If we moved a little bit to the east, to the Far East, the Asian or the ASEAN coalition of countries, it's a similar coalition almost to the EU, but between Asian countries, they will tell you you can use a body floater and you will be fine. So the end result of all those different type of protocols, framework, regulation is that at the end goal, you will be enjoying swimming with minimal type of risk. And here where I want to explain the core of this presentation. I want you to understand that is when it comes to personal care, product and cosmetics, safety is such a complex puzzle. It has a lot of pieces. And unfortunately, this puzzle contain a lot of pieces that are all related, all intertwined, all needed to extract what's safe and what is not safe when it comes to the personal care industry and the ingredient used in it. And when the safety is removed from that context, like a small piece of puzzle, as you can see here, and I put some alert, because when that happens, a lot of negative reaction could happen, a lot of opportunity for misinformation, fear-based marketing could happen. So the whole puzzle is the context. So safety is related to risk, safety is related to the hazard of the chemical, safety related to the dose of the chemical, safety is related how much we are exposed to the chemical, for how long, how are we exposed topically, inhalation, ingestion by mistake, and who is using the product. Is it like an infant, a senior, an adult, a child, etc.? And is it banned in another country? Do we need to understand the regulation of the other country? So safety is only clear when we have all the pieces together, the whole pieces of the puzzle of the safety masterpiece or picture, because without some pieces, safety cannot be clear. As you try to do a puzzle of a big castle, the first few pieces you put, you will not know what is this picture until you have more and more pictures intertwined together. You start to understand what you are making. And the most information, as I'm saying here, regarding cosmetic safety online is rooted in taking safety out of context, and looking at one or two pieces is extremely misleading and can open the door for misinformation to spread super easy. And in this slide is the core of the concept and the science of risk assessment. As we understand from previous slides, that when we measure safety, we're actually measuring the probability or how likely the harm could happen to us if we are used a certain ingredient or a certain product. This equation explains it very, very simply in a very nice way. And I will use here a very simple chemical that can show us what those concepts are. So basically, I used water. It's an essential chemical that we need. We cannot live without. We need it to survive. I describe the hazard concept of a chemical is what is this chemical has the potential to do. And I can give it a similar image to humans. Humans are able to do good things and they are able to do bad things based on the circumstances that surround this individual. They can be a good citizen or a bad citizen based on how they grew up, the atmosphere that surrounded them, etc. Same with water. Water is essential for us. We cannot live without it. But the risk of suffocation from the potential power or the potential ability of the water to cause suffocation is when we are exposed to it in a wrong way. So if we inhale by mistake water, the water getting into our respiratory tract, then bad thing could happen. We have irritation, we have a severe response to the water, we have coughing, potential suffocation, and in extreme case, possible death, like the situation in drowning. But the same chemical has the potential to give us the ability to survive, to flourish, to grow. Same chemical, water, but when we are exposed to it in a right way through our digestive system, when we consume it, it gives us good results. It's completely safe. It's only can cause possible rare negative effect when we overconsume it through our digestive tract, but it's very rare situation that this could happen. So as you see, same chemical, different risk based on the exposure. So I will use cases here to help you understand how putting safety into specific context can change the picture and alleviate your mind from unwanted stress based on fear-mongering and clickbaity content. And it's a recent case that we all witnessed. If you are present online in the personal care community, and I will use the first one is putting safety into regulation. What I mean by that, if we remove safety from the regulation behind the the process of risk assessment. If we just look at risk assessment and look the outcome without understanding the regulation, that can be misleading and that can be a breeding ground for misinformation. The recent situation that happened with TPO, which is a photoinitiator in gel nail formulation here in the EU, it was recently banned, and the process of banning is actually, at the end of the day, is a conflict of regulation, not really related to a high risk to humans. So the process I would go over really briefly. One of the member states provided the European Commission with a new dossier regarding the TPO animal data safety, and they found out that it can cause at high doses when we are exposing the animals to TPO, it can cause reproductive health issues. And the European Commission asked the European Chemical Agency through their RAC, which is the Risk Assessment Committee, that to issue an opinion about this chemical, how safe it is. And there is a major point here that a lot of people missed during the covering of this topic is RAC is actually only give classification based on hazard, not risk assessment, no exposure, no dose. They will give you about the potential, the ability of this chemical to do whatever without looking at the dose, even if it's too high, even if it's unrealistic, and also the exposure, even if the exposure unrealistic, we don't care. We will see what this chemical is able to do, and we will give our opinion and classification. And that's what they did. They gave the European Commission an opinion about TPO that it should be classified as reprotoxic 1B, which may damage fertility and may damage the unborn child. And it's already had a previous classification as skin sensitizer and an aquatic chronic toxic agent. So the European Commission take this opinion and accepted it and added through amendment to the regulation, and now the TPO has a classification, a label that it's a reprotoxic. Here what's the whole story happened, that in cosmetic regulation, according to the Article 15 Section 2, that says any CMR labeling means automatic ban. CMR mean any type of carcinogenic, mutagenic, or reprotoxic. In this case, it was a reprotoxic. The chemical is automatically banned without any type of risk assessment or a new process of evaluating the safety of this chemical. So what they did is automatically banned, and they give a period for the industry to provide a new safety dossier to ask the SCCS, which is another committee to assess the safety of cosmetic ingredient, to maybe save this ingredient from the ban. But unfortunately, the industry did not provide it for many reasons that we can explain in another presentation. And so the story is that went viral is ban equal not safe. It's a small piece of puzzle that was removed out of context, and a lot of fake news and misinformation and fear-based article showed up saying TPO is toxic, the gel nail industry was lying to you, gel nail is killing your fertility, EU is safer. But if we add a little bit of context, another piece, which is regulation conflicts, the ban is okay. So TPO risk-based safety profile did not change. In reality, it's only changed the hazard classification of this ingredient. Regulation conflict was the cause, not a human-based reprotoxic effect. We don't have a new data that shows us there is a spike of TPO-related reprotoxic effect on human. We never had this. We will never have this because of how we are using it. But unfortunately, because of conflict of regulation, this happened. For the second case, we are putting safety into legal framework. And if you have scrolled online through the community of personal care product or cosmetics, I'm pretty sure you've seen a brand, an influencer trying to give you or fear you based on this piece of information that we will debunk here together. They will say the EU banned 1,600 chemical compared only 11 in the US, which means it's safest in the EU and less safe in the US, which is completely inaccurate because it's out of the context of safety regarding the legal framework. Because if we look at the spirit of law, which is the core that governs the EU law and regulation, it's safety and certainty. The EU wants you to make sure that your product is safe before placing it on the market, while in the US they have a different approach but gives the same end result, which is safe products. We don't see huge data that suggests that the US have an issue with regarding safety of cosmetics. We don't have report cases of people getting poisoned by products from the US and not from the EU. the spirit of law in the US and the core that govern all these regulations is different. It's based on responsibility and freedom. The responsibility is on the brand that is manufacturing this personal care product or a cosmetics, and it gives more freedom, more space for innovation and faster production and release. But the law will tell you if you faced legal issues, which is super easy to make based on consumer directed towards a brand. Any consumer can file a law case against any brand if they have an adverse effect. It's a different story in the EU. So in reality, the EU uses precautionary positive list system. It has long annexes of prohibited substance. Some of the substance never were found inside of cosmetic formulation, like jet fuel, bug extraction, some pharmaceutical. On the other hand, the US uses negative list system, so short list, but the liability if harms occur is on the manufacturer or the brand. So many EU banned chemicals, as I said, were never in cosmetic ingredient. The same products are often formulated to EU standard worldwide, and as let's say the essence of this case is that EU tells you prove it's safe first, then you may sell it, while the US, you may sell it, but you must answer if harms occur. And the same situation that happened with the puzzle pieces and the context, more bans equals safer, gives the rise of misinformation, like the EU cares about its people, the FDA wants to poison people, EU cosmetics are safer because they ban more. But in reality, if we add a little bit of context, which is the legal framework, that gives the same end result, which is safe product and adulterated products, we can have a better understanding. Legal framework that is different, more bans means different approaches. That's it. So the EU and the US have different systems. The two systems ensure safety in different ways. Many US products are sold in the EU and vice versa without any type of issues. So case number 3 is putting safety into one of the many fallacies that affect the judgment and cause a lot of confusion in the cosmetic industry and cosmetic space is the natural fallacy. And this case happened last year when a number of, let's say, expert and derm influencers started to promote citrus oil as a more safe, less expensive and as effective ingredient compared to hair or laser hair removal, and they promoted it, and this type of content collected millions and millions of views. And based on the mechanism of action that they say it worked, it's an anti-androgenic effect, which means it affects the receptors of the androgen receptor in our cells, so the hair will grow thinner. This raised immediately a red flag in my mind, and I did a preliminary risk assessment as I'm a risk assessor and a toxicologist. I went through literature and I found the most prevalent and most recurrent bioactive molecule in the different formulation or extraction of the citrus oil, and I found those two at those concentration. I ran them through a SimDoc, which is an in silico model that allow to do a virtual molecular docking, which means I can see if those molecules are actually able to interact with our androgen receptor and possibly cause the needed effect or the side effect. And I did find results that very, let's say, concerning in my opinion, because I used those two chemicals, as you can see here, compare them to positive control with this, in this case, the natural ligand, which is the ultimate most efficient key that is naturally happening, is the testosterone that bind to the androgen receptor, and another positive control, which is the isopropyl paraben, which is a banned paraben in the EU due to lack of data to classify it as an endocrine disruptor. And I found that the power and the power of binding came in between those two. This is banned, this is naturally happening, and those two came here. The lower the amount of the binding affinity power energy is, the higher, the stronger the binding. So what I did next is also used another in silico model to do the skin penetration, because as we understand from the risk assessment process, understanding hazard only is not enough. We need to see exposure, like is it able to penetrate into the skin and go to circulate our body and reach those androgen receptors. And I used this in another in silico model. One of them, the beta-acylenine, was not able to penetrate, which is a comforting result. But the other one, the cyperine, unfortunately was able to penetrate the skin with a range of 74% of the applied dose. And since this oil was promoted as natural, you can apply it on the chin, you can apply it on the face area, under the armpit, in the private area. So it's a huge area of application, and the amount can range a lot. And people, since they understand it's natural, they will over apply to get a better result. So in conclusion, it came out as something that I wouldn't recommend, something that carry an unwanted risk. And it also, the data regarding the safety and efficacy, or mainly the efficacy, was based on data that extremely, let's say, low quality, if I want to say it nicely. So in conclusion, we understand that natural stuff, natural ingredients that come from nature is not equal safe. We have arsenic, snake venom, and poison ivy are natural but extremely harmful. Synthetic equals unsafe, which is not the case, because we can make vitamin C, which is more efficient, less damaging to the environment compared extracting it from a lemon or an orange, but they will be identical molecule. So safety depends on dose, exposure, and context, not the source of the chemical. And case number 4 is putting safety into cosmetic definition. And I promise you, if you extract the correct information from this slide, you will have immense confidence in the safety of cosmetic products, because if we look at the definition of cosmetic product in the EU and the US, both of them share a lot of common definitions and common criteria, which is appearance and comfort, and they are not intended to cure or treat a disease, because cosmetics are being used by a huge number of people, huge number of population, from infant to seniors and everything in between. They don't require any type of prescription or any type of human interaction to get them, so you can just grab it, pay for it, and start using it. And because of the goal, the benefit of it is beauty, so the risk-benefit scale is in favor of not having high amount of risk. It's almost zero, because if we want to take another example, let's say a cancer curing drug, because the benefit of this drug is huge, is curing cancer, it's possibly able to save someone's life, we will accept a huge amount of risk with it. When you are using cancer drugs, you usually have a lot of side effects. We accept those side effects, we know about them, we will, let's say, tolerate them because the benefit is huge. But when it comes to cosmetics, and I'm not saying this in a negative way, but in reality regarding the risk assessment, is the benefit is very minuscule, it's very superficial, it's to enhance appearance, to visibly change something in your skin. It's very comfort based. So the amount of risk, we will not accept it. Plus, because it's easy to access, plus because a lot of people have access to it. So because the intended use is external, it's something that is very superficial, because no medical benefit is claimed, so the risk is nearly zero. And the EU and the US law demands wide safety margins for cosmetics, because there is not compared to anything with therapeutic goal. And if you want to dive deeper into the process of risk assessment, I made an example that I will explain super fast, which is putting safety into risk assessment science. Let's say I'm in my lab and I came up with this amazing ingredient called cosmetylene, and it's way beyond the properties of retinol and retinoid. It's super anti-aging, but I want to place it on the market. So I have to provide all of this in yellow for the regulators and regulatory bodies to prove the safety of this ingredient. And one of the main one is calculating the margin of safety. And that's why I put it in the heart, because I consider margin of safety as a concept is the heart of this risk assessment science. And the margin of safety needs to be over 100, and I will explain in a little bit. So I brought this cosmetylene because it's a cosmetic ingredient. I use the alternative method of safety testing. We are not using animal testing anymore because it's banned in the EU. And I use in silico model to calculate what is the toxic dose that could cause some effects in possibly humans. So I tested 5 milligram, 10 milligram, and 50 milligram. And at 50, I saw something that gave me a signs of concern. So I chose the 10 milligram. 10 milligram is what we call NOAEL, which is no observed adverse effect level, which is the highest dose in a safety or toxicological study that did not cause any effect. So as you can see here, 10 did not cause any effect, and it was lower than the 50. The toxic dose could be 11 or could be 49, but I chose the safest option here, which does not cause any type of adverse effect. So this dose that I will consider it as a threshold will not cause any type of side effect. If we move to the other part of the equation, so we understand what NOAEL is the systemic exposure dose. Systemic exposure dose is what you are actually being exposed to as a user of a product that contains cosmetolene. So how much you apply, how much the concentration, the dermal absorption, the retention, the body weight, and I calculate a number. The difference between those two numbers needs to be at least 100-fold difference. So if the cosmetolene NOAEL is 10 milligram, the systemic exposure dose needs to be 100 times lower, so 0.1 milligram per kilogram, or even lower if we can. If it's effective at a lower concentration, we can lower the concentration so the systemic exposure dose can go lower. And those 100, why did we choose 100? Because the factor, what we call them uncertainty factor, because it's another buffer of safety for you as a user. 10x factor is for interspecies difference. So if we have the studies from animal studies, or in this case in silico, we are not chips, we are not virtual computers, we are not animals. So things of mechanism of action and effect of toxicity and susceptibility can happen. So we added 10x factor. Another 10x factor, as I said, the susceptibility part between us humans, because maybe I can tolerate, let's say 10 milligrams and feel okay, but you at 10 milligrams could feel worse. So the another 10x factor happens. So at the end, you need to be exposed to a level 100 times lower than that which cause no harm in animal studies, or in this case in silico studies. So you see the amount of buffer that we are using. We use a lot of buffer, but I wanted to extract more from the SCS notes of and guidance for risk assessment. So if let's say assume I don't have dermal absorption for my ingredient cosmetolene, so the guidelines tells me and the rules tells me as a risk assessor I need to use 100% dermal absorption. So everything that I apply on my arm or on my hand or face is absorbed completely 100% to my blood, which is not the realistic let's say scenario, because no ingredients or very rare ingredients that can penetrate and be absorbed 100%, but because this will make proving safety harder for me and provide a better buffer of safety for you as a consumer, I have to follow the law. There is no human body weight data. If I don't know which population will use my product, I will have to use a 60 kilogram adult default, which is higher, lower than the default of the EU, and it gives higher milligram per kilogram exposure, which makes it even harder for me to prove safety and to reach that 100 margin of safety. And no retention factor. So let's say we are applying at least the product and none of them is going, so none of the product is leaving the skin, which is also unrealistic. But if I don't have the data, I have to prove that it's 100% remaining on the skin. And if there is no metabolism and clearance data, I have to assume 100% bioavailability, which again not realistic, but provide a huge conservative approach and safety for you as a consumer. For my last slide, my question is safety of cosmetic under pressure? Unfortunately it is, and big time, because as you can see here, when the perceived experts start to spread information, same as the cypress oil, which is one example, there are many of other examples. The misinformation spread by a perceived expert at the goal of getting clicks, views, and clickbait put a huge strain on the public, who must distinguish what is correct information, what is false information, and open the door for you as a consumer to be weaker and easier to be influenced by fear-based tactics and possibly unsafe product. Same the cypress oil. Because of this went viral last year, some businesses unfortunately opened based on providing cypress oil as an anti-hair solution. There is also the consumer trends like clean, natural, and chemical-free create pressures on formulators to meet marketing ideas that also not based on toxicological principles and understandings. So the regulator must protect the safety while the brand also navigates the demands of the consumer, and there will be a conflict and a pressure on safety and releasing of products that are unsafe. Then the brand, as you can see, it's a cycle. The expert affect the consumer create pressure on the brand, and the brand wants to maintain a marketing image, so they hire an influencer or an expert to market their idea, although sometimes it's not based on science, and most of the time unfortunately it isn't. As you can see here, the brand follow the pressure and they released like the situation with paraben free. They replaced it with a mi preservative. They are less safe, cause a lot of sensitization issues, less effective, so the risks are much higher of having adverse effect from these type of products, and the cycle unfortunately continues and erode the safety as it goes. And with this, I end my presentation. Thank you so much for watching. If you want to follow me and find me on other platform regarding the safety of the personal care industry and cosmetic, you can find me most active on Instagram at MoSkinLab. Same with YouTube. And I have a Substack where I go into deeper details for the nerds out there to be satisfied with information that they are looking for. And I finish my presentation as I finish my contact. See you in the next one. And as always, stay safe.
And bear with me as I bring Mo onto the main screen for the Q&A. Thank you so much, Mo, for that really thoughtful presentation. There was so much. I feel like this is a must watch for everyone. You may have to mute yourself while I'm talking because I think that there's some feedback, but I think that your presentation is a must watch for everyone on social media that talks about beauty seriously. Seriously. Okay. So here we are. We're back. So the first question comes, I will ask from Shalini, who asks, well, firstly, dear Mo, I follow you on Instagram and I'm a big fan. Do you have any take on the Indian regulatory practices? The follow-up also, since so much BPC manufacturing happens in China, does their regulatory environment play a role in EU/US formulation? So I guess like the global context of regulatory that impacts the global system that is the cosmetics industry.
So first of all, thank you for the follow and support. I really appreciate it. Regarding the questions, some countries unfortunately don't have a clear regulatory framework for the cosmetics because it's considered not as important as other sectors. I face this problem in the Middle East, where every country has their own specific regulatory framework that unfortunately isn't available online. And I have to communicate for some of my clients that I do like private consultation with. I have to communicate with the Ministry of Health of each country to understand what they are doing with the cosmetic regulation. I think India is in the same realm of the situation, so it's very difficult to have like access to their documentation, their regulatory framework, what they are following, the as simple as the notes for the risk assessors that they do risk assessment there. I have literally no let's say, idea about what's going on there. If you want my advice is to reach out to the Ministry of Health of India to see if they can share with you some of those documents.
Donatella asks, who is purring? This next question.
So this question, next question comes from Mr. Who asks, well, first, hi, Mo. I often reassure people about cosmetic safety by referring to the SCCS or the CIR, whose reviews I trust. However, some consumers express distrust in institutions. From your perspective as a toxicologist, how can we be confident that these safety assessments are truly transparent and independent? Also, what's your view on the claim that the dose makes the poison doesn't apply at very low concentrations because concepts behave differently? And stay tuned. I believe this is going to be covered by Chris Borgert, Dr. Chris Borgert, in the next presentation, and certainly on the podcast that he's going to be coming to. We ask about this like non-monotonic dose. Stay tuned for the podcast. But Mo, what do you think?
So basically, it's a very good question because if you understand, or if the public understand how these kind of assessment actually works, so basically regulatory bodies have a lot of money, but they don't have a lot of time to deal with safety assessment of a cosmetic product. So what they do is hire independent expert. They gave them they call them working group. They give them the money, and they bring the industry data, the data that the industry is trying to save an ingredient from a ban or a new classification, and tell them to work together to give us a final report about this. So the independent experts are completely independent. They are being paid by the regulatory bodies to do their job, not to, let's say, direct them into one, give them a full-on pass through for this ingredient or ban it. They give you let's say, the funding to do this risk assessment. You have to deal with the industry data completely without any influence of the regulatory bodies. What they want is to give them a final report, and this final report also will be assessed by the regulatory bodies themselves to see did they do a good job or not. So there is multiple layers of, let's say, protection to stop any type of manipulation or pressure or lobbying, let's say. So you should be 100% sure that those type of reports have no type of ill intent towards banning or allowing certain ingredients.
This was an interesting question, I thought, from Dan. Do you think the EU's hazard-based approach is limiting our ability to invent new, safer chemicals in formulation? My experience is it is. I've seen this with PFAS and pesticides right now. And it's just like also that tied into the animal testing restrictions and the requirements for animal testing for certain categories of ingredients like preservatives or UV filters. This might be beyond this presentation, but what do you think?
So yeah, basically, I want to explain this because I've seen it a lot online. The idea is that the EU is hazard-based. Although if you look at the SCCS report, they are risk-based. They are calculating your margin of safety. They are calculating your exposure. So the idea, it's not like this. Most of the time, it's conflict of regulation, as it happens, as I explained in my presentation. For example, let's take an example that an ingredient, a UV filter, we know that the animal testing is banned in the EU, and UV filters usually, we only use them maybe in sunscreen, but in reality, they are used in multiple industries. And when this type of ingredient is spreading to multiple industries, it will be prone to be following multiple layers of regulation in the EU. So, for example, a certain UV filter can be used in a sunscreen and can be used in some type of protection for a plastic to protect it against the sun. And when that happens, the regulation of cosmetics are not only applied, it's also for industries and specific, let's say, other type of industries that manufacture chemical in big quantities. It will allow this to give a type of exemption that this ingredient has to be tested on animals, whether it's only for cosmetics or not, it will be tested because other workers other than sunscreen formulators will be exposed to this chemical, and we need to understand the safety, so we need animal. And regarding the hazard-based, it is really not hazard. I think it's directing towards if the Green Deal passes completely and the European Commission follow all what they suggested in that deal. But in reality, it's still risk-based. What happened with the TPO situation is just a conflict of regulation, not a change of risk assessment report.
I'm going to ask a two-pronged question, one from my audience and one from myself, because I think it's important. We're running low on time, but I'm going to ask this anyways. I'm sorry to my audience. There's going to be a very, very tiny break. I know I promised you 10 minutes. Sorry. But I think you appreciate these answers. So the first question, it's going to just be a quick answer. This is from Brassfield Beauty. Hi Mo, I love your content. Can you recommend any good books for a master esthetician looking to broaden her education when it comes to skincare? And my question is around, well, Mo is one of, I think actually the only toxicologist who is regularly, in my view, publishing good quality content. And so you on social media, I think, is very important in like the information ecosystem that is beauty. That's my perspective. But there are a lot of challenges that are presented to people who do sci-comm, especially like you, who maybe don't do as much advertisement or plagiarism and whatever. We're going to get to specific challenges of sci-comm, and I bring up some specific cases that are relevant to Mo in my presentation. But my question is, what would you suggest industry think about for supporting or creating infrastructure for science communicators like you? What can industry be doing better? Because I know that there are many people from industry who are watching this right now.
So regarding the first question, I don't have specific names on my mind, but if you are following me on Instagram, I'll try to share some of my few favorites on my story. So please go there and follow, and I'll do it after this Q&A. Regarding the second part, the industry has a lot of power and has the money, the logistics to do a lot of big changes when it comes to hiring, directing the public around what's happening into this industry itself. Because I see a lot of, unfortunately, big names in the brands, big like main manufacturer, big names into that do skincare, sunscreen, etc. They reach, unfortunately, for individuals that are able to spread the word far and wide. They don't care, unfortunately, about the accuracy of this information shared, not the past or the track record of this individual, what they are talking about, is this in their field of expertise, etc. And it's something that happened to me like recently. A quick example is that I was talking about regulations and toxicology, which is my field of expertise. And I received a comment on YouTube saying, but dermatologists said X, Y, and Z. Like, why should we listen to you since dermatologists are saying this? The idea of this person saying this thing that dermatologists is generated, unfortunately, by the industry itself. They always, and I have nothing against dermatologists, they are amazing in their field of expertise, but they highlighted this idea that they have the ultimate expert into every field related to personal care, which is not the case. So the industry has a lot of tools, like logistics, to create programs to support each expert in their field. If they have, let's say, a burst of new misinformation about safety of UV filters, they shouldn't look for a dermatologist. They should look for a safety expert. If they have about a new burst of, let's say, a case report of allergy regarding ingredients, they should hire a cosmetic chemist to look at it. But the idea is that focusing on one lane of expertise for tackling every topic is really causing a lot more harm than good, in my opinion.
Really good answer. Mo, thank you so much for your time today. This concludes the Q&A with Mo. Mo, if you'd like, go to the chat on YouTube. People have asked a lot more questions, and everyone follow Mo at Mo Skin Lab on Instagram, and he also now has a Substack.
Thank you.
Thank you so much, Mo.
Thanks.
Our next presentation will be another headlines versus reality, this time on the topic of endocrine disruption from Dr. Chris Borgert. Chris is president of Applied Pharmacology and Toxicology, Inc., a consultancy specializing in toxicology, pharmacology, and safety assessment. He earned his PhD in pharmacology and therapeutics from the University of Florida and completed a postdoctoral fellowship in toxicology. Chris has advised the US EPA, testified before Congress, and contributed to numerous expert panels worldwide. His extensive publications focus on evaluating chemical mixtures, endocrine disruptors, and risk assessment, advancing methods to improve regulatory science. Without further ado, here's Chris.
Hello, I'm Chris Borgert, and I want to express my appreciation to Jen Novakovich for inviting me to share my perspectives with you on endocrine disruption. I've subtitled my talk Sensationalism versus Science because I think that's the issue, and I'd like to give you a historical perspective. I've been dealing with this issue now and working within this arena for more than 30 years, and I think that understanding the history of the issue and how it's been worked in the media and by scientists is important for understanding why we are where we are today. Many assume that the endocrine disruptor issue began with publication of Our Stolen Future, a book by Theo Colborn and co-authors that made a number of claims, but central to those claims was the notion that the really tragic adverse effects of diethylstilbestrol, a pharmaceutical prescribed to women during the first trimester of pregnancy, could be recapitulated and were being recapitulated by exposure to environmental endocrine disruptive chemicals, and that effects in wildlife were harbingers of effects that were occurring and would occur in the future in humans. However, Our Stolen Future was not the beginning. There was certainly a backdrop to the publication of that book. Recall that more than 3 decades earlier, Rachel Carson published Silent Spring, a book in which she alleged that chlorinated pesticides, and in particular DDT, were responsible for population declines in a number of species of wildlife, particularly in birds, and that human health effects like cancer were also occurring. The human health effects were much less well documented, but this led to considerable public alarm. So that, together with the DES catastrophe, which really was a catastrophe, set the stage for alleging that chemicals in the environment were disrupting the endocrine systems of both wildlife and humans, leading to catastrophic outcomes. In addition to Silent Spring and the DES scandal, there were published reports of a global decline in sperm counts. This was attributed to exposure to pesticides and plasticizers. These were sensationalized to warn of a general male infertility crisis, and although other factors would certainly have played into that if it were real, they took backseat to the idea that exposure to environmental chemicals was the cause. That, combined with observations of abnormalities in wildlife that included things like intersex in fish, deformities in frogs, and one that made particularly widespread news was a population of alligators in Lake Apopka, Florida, that were decimated by a pesticide spill from a plant that was located very near the banks of that lake. So together, these were combined, and the media reported these as harbingers of a total ecosystem collapse that would affect not only wildlife, but humans through endocrine disruptive chemicals. Long before the publication of Our Stolen Future, this backdrop led to the convening of a scientific conference at the Wing Spread Conference Center in Racine, Wisconsin. This was funded by the Johnson family, founders of SC Johnson Corporation. The title of the conference was Chemically Induced Alterations in Sexual Development, the Wildlife-Human Connection, which I've already explained. And this conference, of course, in the report memorialized the connections between, or what they perceived as the connections between, these effects in wildlife and the DES tragedy. But importantly, recognizable terms were coined, specifically the the term endocrine disruptor. Theo Colborn always argued for use of the word with the OR ending. She, for some reason, believed that connoted greater activity and would convey to the public the more active and serious nature of this group of chemicals. So think about it. From the beginning, the very words used to discuss this phenomenon, or this purported phenomenon, were at issue. So not only endocrine disruptor versus ER, which was viewed as being more passive, but think about the very title of the book, Our Stolen Future, which implies that we would not have a future because it had been taken away from us by exposure to endocrine disrupting chemicals. So from the very beginning, there was a sensational aspect to this. Now, a good example of the way headlines and sensationalization got way ahead of the science on endocrine disruption from the very beginning is illustrated by a report that came out in Environmental Toxicology and Chemistry in 1997, reporting estrogenic activity in 5 rivers in the United Kingdom, as evidenced by the measurement of vitellogenin protein in male trout. Male fish do not normally produce the egg yolk protein vitellogenin. That's normally produced only in females because of the higher levels of the natural estrogenic hormone, 17-beta estradiol. So the production of vitellogenin protein by males was thought to indicate exposure to an estrogenic influence or chemical, and the authors attributed this to alkyl-phenolic compounds that were coming through sewage treatment plants whose effluent emptied into these rivers. On the basis of this report, there was massive product deselection. Products were actually pulled off the shelves in the UK because of the public concern generated by the media focus on this report. To their credit, the researchers were more careful and continued their research. They fractionated the sewage treatment effluent into the various chemical categories, and they found significant estrogenic activity in the steroidal fraction, which comprised estrone and estradiol. Here I use the British spellings. Those are the natural estrogenic hormones in fish and in vertebrates, as well as the synthetic estrogen, ethinyl estradiol, which is used in oral contraceptives. The conclusion of that work was that all of the estrogenic activity was attributable to the steroid fraction. In other words, to natural and synthetic estrogens from human urine, and possibly from domestic and agricultural livestock. None of the activity was attributable to soaps and detergents, but the product deselection had already occurred, and stepping back from that is simply not possible. So the effects in the marketplace of this sensationalization of a report of endocrine disruption was permanent. Now, this rush to sensationalize the effects of endocrine disruption was not without its critics. There were skeptics from the outset. One of them was a scientist by the name of Riseborough, who was an ecologist. He published a paper in 1999 in which he made several arguments. He pointed out that if endocrine disruption is real, the alarm should be more appropriately directed toward the past than the future, because decades earlier than the 1990s, exposure to chlorinated pesticides and other chemicals alleged to be endocrine disruptive, such as PCBs and dioxins, were much higher. And not only were exposures, but body burdens were much lower in the 1990s than they were in decades prior. So he says these future threats to wildlife from endocrine disruption, as proposed by Theo Colborn and others, had no credibility. Riseborough was also one of the first to point out the potential illogic use of the term endocrine disruptor. He pointed out that because the endocrine system, along with the neurological system, are the major control systems in vertebrate organisms, and because of the homeostatic function of those control systems that strive to maintain a consistent internal biochemical and physiological environment within the organism, almost any adverse effect to an organism or a population of organisms could be called endocrine disruption, because ultimately, by secondary or tertiary means, the endocrine system would be affected as the organism tries to respond to the insult to maintain a consistent internal environment. So he pointed out that the term it could be essentially meaningless depending on how it's used. Now, there were skeptics within the human health arena as well as the wildlife arena. Returning to the issue of sperm counts, a report had been published that alleged sperm counts were declining based on data from New York City, depicted in this figure by the maroon diamonds. The allegation was that sperm count data from the 1940s through the late 1970s showed a consistent decline. However, when one views the sperm count data from New Yorkers in perspective with the rest of the world, including much of the world that is not nearly as highly industrialized as New York City, and to which residents would not be expected to be exposed to nearly as many chemicals, including those alleged to be endocrine disruptors, we see that from the 70s forward, there's no apparent decline in sperm counts. And in fact, any differences could simply be attributed to methodological improvements in counting sperm, as well as to simple population differences across the globe. So that there's not really any clear evidence of a decline in sperm counts to begin with. Now, the next few slides are simply a chronology of various headlines. I'm not going to spend any time going through these in detail. I will note that endocrine disruptive chemicals became known as gender benders, another attempt at sensationalization. That the use of that term might find a different reaction today than it did back in the late 90s. What I want to emphasize from the next few slides, and I think if you look through these, you might agree, that what we see is that the headlines related to endocrine disruption follow the major public health scares and major public health issues of the day, as well as reports in wildlife. So what seems to happen continually is that when there are concerns about infant health, or concerns about childhood obesity, or concerns about observations in populations of wildlife, the endocrine disruptor advocates were always very quick to make the attribution to endocrine disruptive chemicals, and researchers were very aware of the opportunity to gain grant money by making those connections and continuing to study these alleged relationships between endocrine disruptors and public health outcomes. This slide simply continues that theme. Although bisphenol A had been an early target of endocrine disruptor advocates, and many health effects were increasingly attributed to bisphenol A exposure, not only estrogenic effects, but then obesogenic effects, etc. By 2015, 2016, those allegations began to spread to plasticizers in general and many other chemicals. One very prominent example of the opportunism came about with the COVID-19 outbreak Linda Birnbaum, who's the former director of the National Institutes of Environmental Health Sciences, was very quick to allege that sensitivity to COVID-19 virus was exacerbated by exposure to endocrine disrupting chemicals, and that immune system disorders, diabetes, obesity, etc., caused by endocrine disruptors were responsible for increased vulnerability to severe COVID-19 illness. This was just a particularly obvious example of the sensationalization of a public health concern used to bring endocrine disruptors to the forefront of the media and of public health concerns. Continuing up to the present, the continued expansion of the attribution of endocrine disruption to other classes of chemicals and other disorders continues. And of course, as this audience well knows, hair and skincare products have not escaped the targets of the endocrine disruptor advocates and those in the media who propagate those claims. The focus is always on children and developmental problems, and that is the concern over skin and hair care products is no exception. And I don't have time to go into some studies that I've reviewed for journals in peer review and as well as submitting letters to the editor, but some very substandard science often is published simply due to the fact that it will gain readership and gain a lot of attention for the journals. So this is a recap, a list of the expanding set of health allegations attributed to endocrine disruptors through the decades. I think I've mentioned most of these already. I want to highlight that as obesity became a public health concern, that was quickly attributed to endocrine disruptors, and endocrine disruptors were then called obesogens, as well as metabolic toxicants. As autism became more prominent in the headlines, the attribution was quickly made to endocrine disrupting chemicals and the neuroendocrine effects of endocrine disruptors. Even old diseases such as Parkinson's have found, according to some researchers, a basis in exposure to endocrine disruptors. Health disparities between races and various demographics have been attributed to different products marketed to different demographic and racial communities, as well as I've mentioned sensitivity to the COVID-19 virus. So almost any public concern over health outcomes is very quickly attributed to endocrine disrupting chemicals. You have to admit that the activists and the advocates have been very skilled in their marketing approach. Much less prominent have been the skeptics, but they've been there all along. On the left side of this slide is a spoof on the book Our Stolen Future, published by a fellow named Stephen Malloy, who maintained a junk science website for a number of years. He pointed out that the issue of endocrine disruption seemed to be designed to swell the reputations of certain scientists and activists more so than to actually solve any real public health problem. On the right side is a good reason to pause this presentation right now and go to the YouTube site that shows a trailer of the movie made by several endocrine disruptor advocates and activists entitled Brains in Danger. This is a marvelous illustration of the level of discourse engaged in by so-called scientists who advocate the theory of endocrine disruption. Now, I'll leave this slide for you to read, but in the next remainder of this presentation, the next few slides, I'm going to go through some of the major themes of the endocrine disruptor advocates. One is that endocrine disruptive chemicals are active in very small amounts because hormones are active in very small amounts. That glosses over issues of potency. Another big claim is that there are no thresholds for the effects of endocrine disruptive chemicals. Another is that humans are more sensitive to the endocrine disruptive effects of chemicals than our animals, so we always need to introduce elements of precaution to properly protect against endocrine disruptors. I'll address some of these points in the next few slides. Now, before I get to those specific issues, no presentation on this topic would be complete without at least some mention of one of the most infamous and effective publications promoting endocrine disruption that was ever published. In 1996, a paper was published in the journal Science reporting an 1,100-fold synergistic effect of two pesticides that were alleged to be environmental estrogens. There's a fascinating story about the authorship here, but an 1,100-fold synergistic interaction of anything is unheard of in pharmacology and toxicology. And so a number of researchers jumped on this report and showed that it was not reproducible. The senior authors, Lou Gillette and John McLaughlin, were able to delay retraction of that paper, which incidentally was published just a few months before Congress was to vote on the 1996 Food Quality Protection Act and amendments to the Safe Drinking Water Act that required EPA to screen for estrogenic-like effects in humans for pesticidal chemicals and others that appeared in drinking water. So that retraction was delayed long enough that Congress had the opportunity to consider this report and vote. The retraction was too little too late, but you have to point out that it was certainly effective for what many of us thought was its real intent. Now let's turn our attention to the claim of no thresholds for the effects of endocrine disrupting chemicals. The Endocrine Society, in collaboration with a group called IPEN, which is not something you use with an iPad, it's the International Pollutants Elimination Network, which is a coalition of activists devoted to eliminating certain classes of chemicals from commerce and from the environment. Teamed up to publish this guide for public interest organizations and policymakers on endocrine disrupting chemicals, in which they make a number of claims, but chief among them are the concept that endocrinologists have now overturned the basic principles of pharmacology and toxicology, which is dose response and thresholds, and that they have provided incontrovertible proof that there are no thresholds for the effects of endocrine disrupting chemicals. Now, this is an interesting proposition in and of itself, because in science, it's nearly impossible to prove a negative proposition. And not only that, but the authors of this publication have often claimed that, or often challenged toxicologists when we identify no adverse effect levels. They say we can't do this because that's essentially proving the negative. But at the same time, they claim to have provided incontrovertible proof of a negative, i.e. that there are no thresholds for endocrine disrupting chemicals. Let's examine that claim. Now, before we move on, it's important to define what a threshold is. A threshold is the minimum dose of a chemical required to observe a particular response. I won't go through the graph. I'll just give you a quick example. I think we all know just from common sense that there's a minimum dose of any common over-the-counter medication that we take. Let's consider ibuprofen, a non-steroidal anti-inflammatory drug that relieves aches and pains. I think we all know that if we were to chop up an ibuprofen capsule into 100 pieces and take 1/100th of a capsule, that would have no effect on our pain. It would cause no reduction whatsoever in our pain. There's a minimum dose of ibuprofen we need to take before we experience any reduction in pain. So that's the basic concept of a threshold dose. It's the basis of the entire drug industry. It's well established over decades, if not centuries or millennia even. Let's first return to the DES tragedy. DES was a highly potent estrogenic drug given to women during the first trimester of pregnancy under the mistaken assumption that it prevented miscarriages. That assumption was allowed or possible because there was no clinical trial conducted with DES. And so not only did we not learn that it was ineffective in preventing miscarriage, but no standard dose was developed. In other words, we didn't identify a minimally effective dose and a maximally effective dose. So there was no standardization, and consequently there was a 1,400-fold difference in the doses of DES that were given by clinics in the United Kingdom versus the United States. To cut to the chase, all the terrible adverse effects of DES in the offspring, including uterine clear cell adenocarcinoma, observed in DES daughters when they became of reproductive age. And for both males and females, it was a very low incidence of these effects. But they were serious effects, particularly the cancers in DES daughters. But all of those effects were observed in the high-dose clinics. None of those effects were observed in the clinics that gave the lower doses, clearly showing that there's a threshold for the effects of DES. So even the chemical always pointed to by advocates of the endocrine disruptor theory, DES, has a threshold. The advocates never discuss that fact. They simply point to it as an example that chemicals can affect the endocrine system of humans, but there's a clear threshold for DES, and they never discuss that. This is a figure from a publication of mine and co-authors in which we examined the effects of DES in humans versus rodents. And to simply make the point, this figure demonstrates that humans are not more sensitive to the endocrine disruptive effects of DES than rodents. In fact, rodents are quite a bit more sensitive than humans. So this notion that whatever effect we see in wildlife will occur at lower doses and perhaps to a more severe extent in humans than in rodents is simply wrong on its face, and it's wrong even pertaining to what's used as the poster child chemical for endocrine disruption in humans, DES. So the endocrine disruptor advocates avoid the issue of thresholds for DES because that doesn't work for their argument. Instead, they appeal to studies done in temperature-sensitive species of reptiles. In alligators and red-eared slider turtles, sex is determined not by chromosomes, but by the temperature at which the eggs are incubated in the nest. So you can take those eggs out of the nest into the laboratory and incubate them at a temperature that will produce almost all males, or a temperature that's a few degrees different that will produce all females. And that's actually reversed in the turtles versus the alligators. But what was done in these studies is that these eggs were collected from nests in the wild. They were put in the incubators, maintained at, for example, a constant temperature that should produce all males, and eggs that were painted with various putative endocrine disrupting chemicals instead produced all females. And because the researchers were unable to paint a small enough dose on the surface of these eggs to lack an effect, this is what they use to claim that there's no threshold for the effects of endocrine disruptors whatsoever. Now, research collaborators and I inadvertently tested this proposition when we tried to use the egg painting model as a system to study the effects of chemical mixtures. My research collaborator, Tim Gross, is an expert in reptilian toxicology. His laboratory had the capability of doing these types of studies. So we, and I say this with great sarcasm, we made the mistake of starting from the beginning and tried to carefully characterize our experimental system. We first tried to make sure we had a reliable method for painting chemicals onto the egg so that a consistent and reproducible dose would be delivered to the embryo of the eggs. Because if you're going to have an effect on sex, you have to affect the embryo. And to cut to the chase, after 3 years of trying every conceivable method, we were never able to achieve a significant dose of the chemical painted onto the surface of these eggs into the embryo. Not only that, but whatever small amount of chemical was transferred in was highly variable and unpredictable. We looked through the literature on all the studies. All 45 of them had published on this method, and found that only a handful, only 12%, even addressed the issue of whether chemical transferred through the shell of the reptilian egg to the embryo. Those that measured it found the same thing that we did, that only at most a tiny amount could be transferred. It was highly variable, unpredictable, so you could never make the assumption that you had transferred any chemical to the embryo. The majority of these studies just made the assumption that if they painted it on the surface, it must get to the eggs, because they showed some sort of an effect on the sex of the offspring. But 42% of those studies did not even verify that they had a measurable effect using any formal statistics. So this is a good illustration of the level of rigor in the science used to support claims such as those that say endocrine disrupting chemicals have no threshold. So to wrap up quickly, these claims have gone on for decades. They always follow the public health concern of the day. Sensationalism is the rule. Careful and rigorous science seems to be optional. And this is evidenced by a 2021 book, again, with a sensational title, Countdown. This is authored by Shauna Swan, who was one of the people who made some of the original claims about declining sperm counts. So this continues on to the present age, present year. My conclusions are as follows. Endocrine disruption follows the headlines. Whatever public health scare leads in the news will be attributed to endocrine disrupting chemicals. And this is a point I haven't made yet. Accountability is never demanded. In other words, think about bisphenol A, probably the most sensationalized putative environmental estrogen ever. It's been removed from products. Human exposure to bisphenol A is much less now than it was decades ago because of all this product deselection. Where are the public health benefits? Where are the declines in all the adverse human health outcomes that were attributed to bisphenol A? They should be evident, but that accountability is never requested and it's never attempted. And so I don't think the incentive is actually to improve public health. The incentive is to discover new sensational adverse effects of chemicals that will continue to get research grants. If sensational enough, litigation can then ensue, claiming that those chemicals caused broad populations to experience adverse health outcomes. And this expands the purview of bureaucratic agencies who are charged with overseeing chemical safety. So until these incentives change, nothing else will change. I thank you for your attention, and I'm happy to entertain questions.
And bear with me as I bring Chris onto the main screen here. Thank you so much to Dr. Borgert for that very informative presentation. And I guess initially I have a question that came up recently on social media. So there's this dermatologist that has on TikTok 1.2 million followers, and she is one of the few dermfluencers that many of the brands, I'm just going to say this selfishly because I think it's important, many of the brands who purportedly care about misinformation and supporting sci-comm invest in her. So recently, yesterday, I think, or the day before, she posted that products I wouldn't touch with a 10-foot pole during pregnancy as a triple board certified derm and mama to be. And the products she talks about are fragrance in cosmetics. And she says this based off of guidance from the American College of Obstetricians and Gynecologists, who have made a statement that all phthalates,
I mean, issues with grouping chemicals, but whatever. All phthalates are to be avoided because of their potential endocrine disruption impact and therefore are unsafe for people who are pregnant. And this is a statement that she was saying on her social media very loudly. And of course, I mean, like, to my audience, please go look at this because it's quite egregious, and it's quite egregious to see the industry supporting her. But then in the comments, all the dermfluencers who like to like support each other are like, oh yeah, great information with hand clap emojis. So what's your take on this? Are phthalates something that pregnant women should be concerned with, especially the specific phthalate relevant to fragrance and cosmetics, diethyl phthalate? And is this potentially problematic? Like, it seems like pregnant women have a lot of things to be concerned with, but yeah, what's your point of view on this? And thank you so much for this presentation.
Sure. Well, I'm a little off guard. I haven't dug into phthalates for years. I did a report for the Consumer Product Safety Commission years ago, where their intent was to remove phthalates from children's toys, and they were taking an additive approach to the risk assessment of phthalates, which was completely unfounded at the time. It all depends on dose. So I would not advise anyone during pregnancy to bathe themselves in massive doses of chemicals, which is the way all chemicals are tested for toxicity. But to say that you wouldn't touch with a 10-foot pole fragrances that are going to produce a minuscule dose and probably incapable of even reaching the fetus. And I don't know that for a fact. I'd have to dig into the toxicokinetics and look at it in detail. But it is difficult for me to imagine that a product and a fragrance could reach levels in anyone that could affect any physiological process in any significant way. It's just, again, this is the common way endocrine disruptors and other chemicals are basically pilloried in the media. Is we take an effect that can occur in some test species at a very high dose, and we use that as a qualitative descriptor for every exposure scenario that exists. And that's ridiculous. That's just absolutely ridiculous and unscientific. So, as I say, I would have to evaluate the claim in great detail to give you more specifics, but making those kind of general statements is usually a sign of non-science behind it.
This next question comes from Michelle Niedziela, who will be presenting later, Neuroscience. First, great talk. I really appreciate your attempt to validate the methods. How can we encourage more of this? Did I miss you mentioning whether you will be publishing your review of methods used also?
The things that I've presented come from various presentations over the years. So most of this is everything I covered has already been published. What hasn't been published is just sort of the recount of news headlines, and that is incredibly incomplete. There have been hundreds of millions of dollars, I would guess, and I haven't run this down, but probably hundreds of millions of dollars spent on funding research into endocrine disruptors, and the myriad of headlines that have followed publication of that research would take us all day to review. I think that and there are so many things I was not able to get into. One example was the Clarity Bisphenol A project, where there was an agreed upon protocol. All of the samples were done double-blinded. You can look this up. I mean, this is out on various websites. Basically, there were two arms of that huge study. It was involved the academics who were advocating newer methods for endocrine disruption and the National Toxicology Program, et cetera. The protocols were all agreed upon by everyone, but when the results didn't turn out as many of the activist scientists predicted, they began complaining about the methodology and influenced by industry, et cetera. So a lot of the methodological critiques have been published, but I think until the incentive structure in science changes, nothing is going to change. I would highly recommend an interview of Jay Bhattacharya, the new director of the National Institutes of Health, done by an interviewer from the Hoover Institution, Peter Robinson. It's online. It was done several months ago, and Dr. Bhattacharya points up this problem with incentive in science, and I think that is the real problem. I can't really blame researchers for doing what will get their work funded, but until we change the incentives and we focus more on trying to get to a point where we define the safe uses of chemicals rather than basically scoring points and obtaining more publicity and then therefore more grant money, et cetera, for sensationalizing newfound and frightening effects, nothing is going to change.
The last question I will ask, we're a little over time, but we're going to be going into lunch break eventually, and then we'll catch up during that time. So this question comes from Dan, who says, first, amazing presentation, and then follows with a question, what are your thoughts on the new hazard classes on endocrine disruption and the criteria or recent changes in the EU CLP regulation?
Succinctly, the problem with those regulations is that they are hazard-based. And so what I described a few minutes ago, where a qualitative descriptor is placed on a chemical based on an effect observed at a very high dose, irrespective of the dose, irrespective of the kinetics, irrespective of how well that effect actually translates to humans, whether it's even human relevant, that qualitative descriptor is what is used. And what is happening in the endocrine disruptor arena is that the definition of an endocrine disruptor is a chemical that causes an adverse effect by way, as a consequence of, an endocrine mode of action. But in the EU, what they're essentially doing is they're saying, well, if it has an adverse effect on an endocrine sensitive tissue, or it appears to have an endocrine mode of action, we'll sort of assume that if there's what they call a biologically plausible link, in other words, if someone can conceive of how there could be a link, then they'll count that as evidence of endocrine disruption. So it's qualitative, it's hazard based, and what it should be is quantitative and risk based. And so I think they're coming up with political decisions, not scientific decisions.
And that's all the time that we have for this Q&A. Thank you so much, Chris, for such a thoughtful presentation and for your time today on a Sunday. And I just want to let my audience know that my podcast is returning either next week or the week following, depending on how organized I can be. But on this season, Chris will do a 101 episode on endocrine disruption. So if you want more details, listen to that podcast. But until then, thank you so much, Chris, for your time for the summit.
And thanks for having me.
Our next presentation will be about quality control in beauty from Geoff Waby, who brings over 4 decades of experience in quality assurance and manufacturing in the beauty industry. He spent his career at P&G and Estee Lauder, where he led global QA across R&D, manufacturing, and suppliers. Geoff is now an independent consultant, a board director of Obelus USA, and an active contributor to industry groups like PCPC and the Independent Beauty Association. He helps companies navigate compliance with MOCRA and supports the creation of new national standards for the personal care manufacturing space. Without further ado, here's Geoff.
Hello, my name is Geoff Waby, and I'd like to talk to you today about quality control in beauty, or the importance of good science in developing, producing, and distributing cosmetic products. By way of introduction, I spent the first 20 years of my life with Procter & Gamble. I had 10 years of a wide range of supply chain roles, followed by quality assurance roles. I joined Estée Lauder and had 15 years there, leading a number of quality assurance organizations across Europe and also North America and globally. I joined a contract laboratory which was acquired by Bureau Veritas, and now I work as a regulatory affairs consultant with a Brussels-based company. I'm also an independent quality consultant. I've been fortunate across both companies, P&G and Estée Lauder. Quality assurance meant that I worked with research, development, manufacturing and filling and distribution and post-market support. So I saw all those aspects of quality assurance. I'm a member of the PCPC Quality Committee, Micro Committee, and then the Safety, Toxicology and Regulatory Affairs Committee. I'm also a member of the IBA Supply Chain Sustainability Resources Committee. And finally, we've just published a new standard for personal care products by NSF, and I was a joint committee member which developed that standard. The phrase quality control conjures up something very specific, and that's focused really on manufacturing and filling. And the question is, does it meet specification? To check that, then obviously you need a specification for the bulk product or for the finished product. You need parameters, color, odor, appearance, pH, viscosity. You need limits for each one of those parameters. You need a test method, which is used to test it. And you need a sampling plan, which takes representative samples so that you can decide whether or not the batch of products does meet that specification. But quality overall, it's so much more than that. And it covers all the way from research through development to distribution and in-market controls. So what's the business basis of the quality that I'll be talking about? Well, the initial purchase is influenced enormously by quality. The brand makes a promise to consumers, and consumers expect the brand to deliver on that commitment. The way the package is presented also is a great opportunity to reinforce the quality of the promise that the brand makes. The distribution channel, what products are alongside it? The promotional material, what does that say about the product? And the recommendation from satisfied users will all help to drive the initial purchase. Repeat purchase? Well, that's down to the consumer experience. When I use the product at home, does it live up to the brand promise? Am I delighted by the quality of product that I've bought? Has it reinforced my love of the brand that I've just bought into? Is it consistent? Is it repeatable? When I buy a second, a third, a fourth, a fifth package of the product, does it also deliver on all of those promises? And then post-purchase support, if I do have a problem with the product, can I send in a consumer comment? What response do I get? Does that also reinforce the fact that this is a brand that I should be investing my loyalty in? So really the quality I'll be talking about and all the quality systems which I'll be talking about help to bridge the gap between the brand builder who says, just, I love this product. In the laboratory, I love it. I need to get this exact product into the market for everyone to experience it. Then I'll have a successful business. And the quality systems, which I'll talk about, mean that you can then deliver consistent, delightful consumer experience, which all adds to brand equity and drives the business forward. The quality systems I'll be talking about begin right at the start of a product's life with the marketing brief. So what templates do you use? What training has been given? How clear and consumer focused is your marketing brief? What is it important for the consumer to experience when they use the product? What personal needs are to be addressed? How's the product to be delivered? Is it in a tube, a jar, a bottle? Does it need an applicator? What's the gap in the market? And who's the target audience? Is there a hero product we're going after? So does someone else have a very successful product out there and we're aiming to take some business away from them? Or do we have a hero product and we're producing a flanker to support that product and increase the business across the brand? And are there any regulatory boundaries that we must stay within? And what can we truthfully address with this product in our marketing collateral, our online support for the product. Now, there's an example which gained a lot of publicity over the last few weeks, and it's not my intention to throw stones at any particular brand, but the photograph here is important to illustrate, and I've done a little bit to obscure what the product is. The FDA wrote a series of warning letters about mousse-based sunscreens, and they had two problems with it. First of all, they said, look, you're selling a product in a package which clearly mimics whipped cream, and you can't do that. And I know I've had problems in the past with a bath or a shower gel which was sold in a package which resembled a champagne bottle. The other objection the FDA had with it was it's a mousse-based sunscreen. First of all, we're not sure that the mousse product form delivers the sunscreen activity that you're claiming. And secondly, the OTC monograph for sunscreen products specifically applies to products which are oils, lotions, creams, gels, butters, paste, an ointment, a stick, a spray, or a powder. And it doesn't list mousse among those categories of products. So the FDA wrote a series of warning letters. Okay, so now we're into the development phase. So we've got our marketing brief, what are the product characteristics going to be? And then raw materials, they're commercial products. They come in variation. There will be natural variation in those raw materials. Can we cope with, in our development process, the natural variation that we get from those raw materials? What's the product positioning? Is it a natural or a green or a clean product? Or all language that we use these days to denote something which has more natural raw materials in them and a more natural positioning. And natural raw materials bring their own challenge. They tend to be more variable and they tend to bring in more microbiological contamination with them, which has to be dealt with. The lab equipment that you use in your development laboratory, it obviously must be suitable for the job in hand, but it needs to be calibrated, it needs to be maintained, and you need systems in place to make sure that each time you use that piece of equipment, it is within calibration and well maintained so that it gives you the results you're expecting, or it gives you accurate results. Product package compatibility is a very important test which has to be done to make sure that the products in the package don't interact and affect the quality of the product or the stability of the package. Preservative efficacy, very important. I talked about natural raw materials having microbiological contamination. Even synthetic raw materials are susceptible to microcontamination. So the preservative efficacy testing is extremely important to make sure that whatever preservative is in both raw materials and the finished goods are able to support the product during use. Preservatives are not there to combat manufacturing hygiene problems in the manufacturing, which we'll come to later. It should leave the manufacturing process with all of its preservative in place, ready to combat the fact that people will be dipping fingers, putting it to their lips, and doing a microbiological insult to the product during normal use. Stability is important. Accelerated stability, so if you raise the temperature and the humidity, that then mimics the effect of time. But then when you've done accelerated stability, then you want real-time stability to make sure that in real life, the finished product in the finished package is able to support the 2 years or the 3 years, whatever it is, you expect it to be stable. And then freeze thaw. They are shipped in containers, vehicles, which will go through both cold weather and hot weather. So you want to freeze it, thaw it, and expose it to temperature variations, again, to make sure it remains stable. It's important, of course, to have a full set of records and traceability as you explore all of these different avenues and finalize on the finished product specification. You need traceability through all of that process to make sure that you can backtrack if you find yourself going down the wrong path, and you can have traceability when you eventually end up in the right place.
Hi, Jen.
So that you can track back through exactly which raw materials you used, how much variability they had. What are the success criteria? What are the stage gates? So we'll only go through to the technical transfer phase when we've passed certain stage gates, when it's passed certain tests, consumer tests, performance tests, clinical trials perhaps, if it's an OTC type of cosmetic product. And safety substantiation, obviously something which is there in MOCRA now. All products, cosmetic products placed on the market, always had to be safe. It's always been there since the 1938 regulations were passed, but now it is explicitly put on the responsible person, the brand owner, to make sure that their product is safe. And I just made a note here, since I spoke about microbiological contamination, and I'm not putting this all down to preservative efficacy, but 77% of all cosmetic recalls in the USA are attributed to microbiological contamination. That's one of the major problems that has to be addressed through this whole process. The next stage is technical transfer, where you scale up from the lab bench to full-scale commercial manufacture. And again, what systems have you got in place? What templates have you got? What tests do you do? Do you need to use regular vessels, or are vacuum vessels required to prevent aeration of this particular product? What's the size range of finished product vessels you're going to qualify? And you need to cover the manufacturing both in the full-scale launch volumes, but then support volumes afterwards. So you need a range of manufacturing vessels which are qualified to make the product across the full scale of demand. What are the mixing dynamics? How do you make sure that you can replicate at full commercial scale the mixing dynamics that you were able to produce in the laboratory? The temperature, the heating, the cooling, the temperature you hold it at. Again, all very important parameters that must be scaled up from lab scale to full commercial value. And those all have to be controlled during a specific technical transfer process. The training and education, this is going to be handed over typically from one organization to another, and more likely one location to another, from the R&D center into the manufacturing locations. So what's the training and education to pass on that knowledge from R&D to manufacturing? Then in the filling line, many products are shear thinning. So if you put them through too much pressure in the pressure and speed in the pumps and the filling systems, then you can end up with a very thin product when you were aiming for a nice viscous creamy product. So what size, what speed are you going to use in terms of the filling lines to make sure that you don't impact the quality of the product itself? And then supply qualification. You need to, at this stage, where are the raw materials coming from? Who are the suppliers? They need to be qualified to make sure that in the commercial world, you're always buying materials which have been approved and tested during the laboratory investigation. I've got a key over here. So in each of these slides following on from here, I've extracted something from an FDA warning letter in black and something from ISO 22716. The warning letter obviously applies to OTC products because that's what are governed by FDA at the moment. The FDA is committed to producing good manufacturing practices for cosmetic products. They have draft guidelines at the moment, but they are committed to produce final ones, which then will govern all of these areas for cosmetic products. So this is what the FDA said in terms of a particular warning letter that I pulled an example of, but then also ISO 22716, which is the cosmetics ISO standard, that also covers the purchasing of raw materials and packaging should be based on evaluation and selection of the supplier. And there are a number of clauses after that to illustrate that this is a simple expectation that all regulatory areas of the world expect you to be in control of during routine manufacture. And we're into manufacturing. So you need to make sure that capacity matches demand. You need to have agility across the minimum order quantities if you're dealing with a contract manufacturer in particular. At the beginning, you're probably building up a high volume for the launch. After that, the volume may hold up or go higher or may go lower. And you need the flexibility on the size of vessels, the speed of filling line, etc., to cope with all of those. without going into areas which have not been qualified as part of the technical transfer process. Similarly, your raw material and packaging suppliers also need to be able to turn on volume if the product really does take off, or to reduce capacity, reduce volume if the product doesn't take off as fast as you're expecting. You need to make sure you're accepting incoming starting materials, so testing them against specifications to make sure that they are exactly as were qualified during the whole development process. Hygienic manufacturing is all about the design of the equipment, the operation of the equipment, cleaning, sanitization of the equipment. All are very important quality systems to avoid microbiological contamination. Then the bulk product acceptance criteria for filling. Now, viscosity usually builds, or frequently builds. So are you looking at viscosity immediately? Have you plotted curves so that you know the viscosity? If you know the viscosity fresh, you know the viscosity after 24 hours, for example, because very often viscosity affects the touch, the feel of the product, which is a very important parameter for consumers. And which parameters are to be tested? What are the test methods? What are the limits? And deviations. There will be deviations. Things do not always go to plan as they should. And how do you handle that? What are the systems for capturing that immediately to limit the impact and to investigate and to resolve the problems? And again, I've got some comments from a warning letter from the FDA about not testing the final product for conformance to the drug product specifications in terms of identity strength of each active ingredient. But just in case you think that's specific for OTCs, ISO has the same expectation. The quality control laboratory is responsible for carrying out sampling and testing so that the materials are released for use only if the quality fulfills the required acceptance criteria. We've made the product and now we're filling it. And again, hygienic manufacturing is tremendously important. And with the completely understandable drive towards more natural products with fewer ingredients, with the minimum levels of preservatives, with previously robust preservatives now not being used anymore, then all of the other parameters that affect manufacturing hygiene, the training of the people, the way they operate the equipment, the design of the equipment, the cleaning sanitization processes, the maintenance systems, all have to be reviewed and kept in balance as raw materials go from synthetic to natural and as preservatives go from robust to multifunctional ingredients or natural preservatives. It all has to be kept under tight control and balance to minimize the risk. We talked about the acceptance criteria of what's tested, what the methods are, what the limits are. We've talked about handling deviations. Something will go wrong. How do you handle it? Record keeping, obviously tremendously important. If something does go wrong, you need to be able to trace with absolute confidence which product is affected, which is not. Environmental control is very important. We manufacture cosmetics in non-sterile environments. So knowing what levels of organisms are normal in that environment is very important to know. Controlling the packing materials. Printed material is very specific to a product. Get the wrong printed material on the wrong product, then you've got a misbranded product out there. And the FDA in their warning letters have talked about not establishing adequate process control to assure the drug product is the correct drug product. And ISO also says in process controls, whatever you do to measure the cap torque, the fill weight, and other parameters in the filling process need to be defined with acceptance criteria and tested. The quality systems in distribution are also very important. So what are the conditions of storage? Are there any temperature requirements for the storage of the product? How do you control the stock rotation so that the first product to expire is the first product that you ship to customers? So you minimize the likelihood of expired product sitting in your warehouse somewhere. Segregating damaged products. Products do get damaged in handling, and you need again to get very clear areas segregated so that you can move those damaged products out of the normal picking areas into segregated damaged product areas. The last thing you want to do is to ship a product which has been damaged to a customer. Traceability of shipment is important. If something does go wrong, then you need to know which batch went to which customers so that you can bring it back. You need to have mock recalls of finished product. When something does go wrong and you need to bring product back, then everything has to be done with certainty and very quickly. And so you test that out with an annual mock recall of finished products. You need to segregate returns. Products will be returned by customers. They might have been damaged in transit or for whatever reason, they need to be returned. And you need a segregation of those returns and an ability to sort them out and figure out what to do with them. They mustn't go immediately back into shippable areas so they can be shipped to another customer. And again, the FDA have written up warning letters about not testing drugs to make sure that they were acceptable before releasing to distribution. But once again, ISO says specifically for cosmetic products, the release of materials should be carried out by the authorized personnel responsible for quality. In market support, what are the quality systems that you have for monitoring the product once you've sold it to consumers? So you should be monitoring the social media and website posts to see what customers are saying about your product, about the performance of the product, about their impression of the quality when they bought it. And you should be monitoring comments. I've known about, or we found out about a contamination with a product by monitoring comments coming in from websites. And that was the first indication that we got that there was a problem with the product, that it eventually turned out to be a recall, actually. Adverse events. The MOCA regulations for cosmetic products already enforce adverse event tracking, reporting, reviewing. So you need to collect those adverse events. You need to have a way that the consumers can contact you about those adverse events as the brand owner. They need to be collected, trended. You need to react to them and you need to report to them. And those records have to be available to the FDA should they turn up looking for them. You need to stay abreast of regulatory changes, particularly with states now becoming very active in the area of ingredients, in addition to the federal regulations changing. There needs to be annual review of product performance. This is a requirement for OTC natural healthcare products in USA and Canada, where you look at what are all my consumer complaints, what are all my in-process measurements, what are all my finished product measurements, my bulk product measurements. Am I getting the results I would expect when I make these products over the year for commercial distribution? You need the capability to retrieve products. So this is key to mitigating the damage to brand equity. If you do get into a recall, as I say, you need to be able to handle that with all of the retail partners, the distributors, everyone involved to manage both the messaging and the consumers, of course, both the messaging and the physical act of pulling product back, investigating it, solving the problem, making good product to replace it, and getting that product out into the marketplace. And FDA, so this was obviously an OTC toothpaste, but exactly the same comment could be made about cosmetic toothpaste. And once again, you look at what the ISO says, and they again say all complaints that fall in the scope of these guidelines, being cosmetic products, need to be communicated, reviewed, investigated, and followed up on as appropriate. I'm very pleased to have the opportunity today to talk to you about quality control, the quality systems required in the beauty business. Here are my contact details. If you have any questions or you need any help or assistance, then please feel free to reach out to me. Thank you very much.
Thank you so much to Geoff for that presentation, and bear with me as I bring the Zoom over to the live screen. Yeah, very informative presentation, and we got a question regarding
The recent choice scandal, and this was actually the inspiration for including a presentation on quality control at this conference. So the question is from Diane, who asked regarding the scandal in recent weeks regarding the performance of sun filters and some formulations of sunscreens. I wanted to know what the role of quality control is for the company if usually you rely instead of testing done by the supplier. So I guess what is within quality systems, where does auditing the reputability of your testing suppliers or even what your contract manufacturing suppliers are saying? Because like just for some background for this topic, this choice scandal has translated to now we see there was actually a discrepancy for the SPF. So more information, it's evolved. And so now there's a bunch of recalls that are happening. What I heard from some of the service suppliers within this whole equation is that some of them were preferentially using certain SPF testing labs because they had good results. And so, like, where is the accountability in all this, and where does quality control fit into this whole messy landscape?
Yeah. Well, yes. And there are, as you say, there are lots of aspects to this. I mean, the first thing is choose your partners very carefully. So you have to be dealing with people that you can trust. And we're human beings. We are fairly good at picking up signals of who we can trust and who is selling us a line. And the first step on the testing, so it's in two parts. There's the initial testing of what SPF can you claim given the formulation that you've produced. And most people will formulate to a target SPF, and they'll formulate to that. So first of all, the developers need to be making sure that they build in sufficient of the active ingredients to achieve that SPF. Then the next step is have that tested. And as you say, that the problem with life and with human beings is you can always find somebody who'll skate too close to the rules or go over the rules. That may feel like an attractive proposition because then you can get something approved that maybe perhaps shouldn't be. It can come back to bite you. And so the approach should always be formulate to the best of your ability, to the target performance, choose a reputable lab to demonstrate that performance, and then you've got your specification, so you can achieve an SPF of 35. Then after that, you go into the manufacturing facility, and then what people are doing is, and again, it's all based on the integrity of that first test. So you've proven that 4.7% of a certain active ingredient gives you that performance factor that you're looking for. So in the production environment, what they're looking for all the time is a batch. Each batch must have 4.7% within a narrow range of that active ingredient to deliver the performance. So again, you're looking for a reputable operation in manufacturing who are doing the appropriate testing to make sure that 4.7% of that ingredient actually is in there. And then you fall back on a third option, which is the auditing piece, which is where again, each time you sign a quality agreement with someone, you should have the ability, including that agreement with them, that you can go on site and look at their operations, review their results actively in the laboratory, and visit and walk through all of the work that they're doing on your behalf to satisfy yourself that they are that they're preserving your reputation. Because as a brand owner, it is your reputation at the end of the day. So those are three very important steps which have to be taken. And so I fall back to my beginning piece, which is everyone involved has to aim for the right intention of public safety. You have to choose your partners carefully, people you can trust, and then you have all of the steps you need to verify that people are giving you the service that you deserve.
And I think that this is very challenging, especially for indie brands. And a lot of the brands that got caught up with this mess were from indie brands. And so knowing what you don't know and who is reputable is very, very difficult. Do you have any further suggestions for finding reputable people to trust to help you with development?
Well, so joining the Independent Beauty Association, so join groups like the IBA where you get exposure to people who are going through the same activities, brand owners who are going through all exactly the same challenges. So you can talk to people. You also get access to people who've got experience. So they've gone through it before you. And so you can talk to them about the people they use and reach out and speak to people. And as I say, look for, as a human being, we're quite good at judging whether people are being open and transparent with us. If your gut tells you something's wrong in a relationship with a person that you're betting your business on, then chances are that something is wrong with that. So keep looking. And I know that all sounds a little bit like platitudes and a little bit like you're on your own, but like any part of growing a bit, starting and growing a business, the best advice you can always get is go find people who've been through it before you, talk to them, talk to people and see who they recommend, what experiences that they've been. If you're dealing with a contract manufacturer, ask them for references. Which brand have they grown in the past? Talk to that other brand. So just talk to other people. And again, in the context of the IBA is a good umbrella in which to have that whole approach.
And maybe there should be something about like contracts for for who you're working with and what they can do for you if something goes awry. I'll just ask my next question. This is from neuroscientist Michelle Niedziela, presenting later. The question is, are some able to get around the rules with online and discount stores, as I have seen innovative delivery formats, bracket similar to mousses, foams that mimic food, as I've witnessed these on the shelf. And we've all probably seen the recalls that happened with some of the sunscreen mousses that aren't approved formats in the USA.
Yeah. So again, sadly, yes. In any field of human activity, you can push the boundaries and you can get away with things and you can step over the line until the time you get caught. So there are products out there that contravene these rules and other rules. And the border control is pretty good at stopping products coming into the country, which are unacceptable. The FDA has a limited number of resources that they have to find these things on shelf. So sadly, you can get away with things until the day you get caught. And then when you get caught, then that can very quickly destroy the brand equity. So again, the best advice you can always have is really understand the market that you're going into, understand the regulations that apply in that market, understand what's appropriate and what's not, and then comply with it and make the best product and the best business you can within the norms and regulations, so that you're not one of the people who then gets caught. If you're doing something which is outside of the regulations, then there's always that risk, and the risk can be brand destroying.
This next question is from Donatella, who asks, can it be more unsafe to buy sunscreens from online stores during warmer months compared to buying in physical stores or during colder months? Or does the QC process factor these elements in as well?
So it's what I talked about in the development process. So when I saw that question come up, I thought about this, and there really should be no difference, because however it gets to your door, it comes from a manufacturing location in a truck with a load of other products to a distribution center, and it may go from that distribution center to a retailer warehouse and onto a retail shelf, all in trucks, or it may go to an online distributor and again go on a UPS truck with lots of other goods as well. So all of them go through a period of time where, whether the weather is cold or hot, they're out in the open on trucks with a load of other products. So they're exposed to freezing cold weather or hot weather one way or another. And that takes you all back to the what I was talking about earlier on in the presentation of freeze-thaw testing. a high temperature stability testing as well. So if you've a reputable manufacturer or a reputable contract manufacturer, if they're making on your behalf, will be doing the freeze thaw testing, which makes sure that once you take a product and you put it through numerous cycles and put stress on it, then and put stress on it in the final packaging as well, then that product will survive that stress and be handed over to the consumer in the quality that you had anticipated and the quality that you designed in. So again, it's back to what tests are your manufacturers doing? What tests were done during development phase, and what tests is your manufacturer doing to make sure that the product will live up to the various stresses it will endure during normal distribution. And whether it's online or retail, I don't think there's a large difference between those two channels.
In the final question that I'll ask, we're going a little over time, but there's going to be a lunch break, so I'm sorry it's going to be a little smaller, but this question comes from Brassfield Beauty. I thought this was good. I'm not sure if you'll have an answer to it, but I'm going to ask the question anyways. So if it's accepted that we are supposed to apply a specific dose of sunscreen or SPF to our skin in order to reach that advertised level of protection, why isn't that information included on the label? I think there's a lot more to this question too about like, why are certain formats even allowed? Why are we allowed to sell spray sunscreens when it is almost impossible to achieve that marketed SPF or makeup with SPF? Why is that allowed? But also to her question.
Yeah. So and again, I thought about this one as I went through it. I mean, first the first answer I think is the pack is part of what consumers love and what attracts people to buy. So there's a lot of competition for the marketing space on the pack and what people refer to as the legal copy. So the stuff you have to put on there in the font size that makes it legible and so on. So there's always pressure to have the legal copy take up a minimal interference with the marketing copy. So that's one answer to the question. However, the other, I think, more practical answer to the question is it would be very difficult to say, because it depends on which part of the body, how much of the body you're putting on. So you may be on the beach and be putting sunscreen on virtually the whole body. You may be putting it on your hands because you're clothed and you're out in the doing some work out of doors. So it would not be easy, I think, to frame some very clear instructions to people to say how you use it in the different parts of the body, the different areas of the body, and under different circumstances. So I think that is a practical point which limits it.
Very thoughtful answer to a very difficult question. Thank you so much, Geoff, for agreeing to present today. Really useful and important perspectives shared here. And for contributing your time on a Sunday. Thank you so much. And I hope you have a great rest of your day. If you are interested, there's still more questions in the live chat, but otherwise, enjoy the rest of your Sunday.
I'll go to it. Thank you very much. I've enjoyed it. Thank you. Bye-bye.
Our next presentation will be on health outcomes of misinformation, a case example on sunscreen, featuring Dr. Nash, Dr. Ejaz, and T.A Lisante. T.A is Manager of Medical Affairs for Skin Health and Beauty at Kenvue, where she ensures products are supported by science and responsibly communicated to professionals and consumers. Since joining J&J Consumer Health in 2003, she has contributed to product development, clinical research, and scientific engagement, and authored peer-reviewed publications on dermatology, oral health, and sun protection. Jay Nash is a research fellow at Procter & Gamble and a leading expert in dermal toxicology and photobiology. He has conducted extensive evaluation of active ingredients and products, working closely with regulators including FDA, EPA, and the European Commission. With over 100 publications, Nash has chaired major safety working groups and currently co-chairs the International Collaboration on Cosmetic Safety's Sunscreen Committee. Finally, Sadaf is manager of global toxicology and clinical safety at Kenvue, where she leads the team ensuring the safety of ingredients and products worldwide. She earned her PhD in toxicology in Philadelphia and has published on dermal penetration and sun filter risk assessments. She also spearheads programs that use data science to build advanced models for exposures and safety evaluation.
Hi, I'm T.A Lisante, and I'm with the Medical Affairs team at Kenvue. Today I'm going to talk about perspectives on sunscreen among healthcare professionals and consumers. Photoprotection simply means protecting our skin from the harmful effects of ultraviolet radiation from the sun and is a holistic process involving several methods, including the use of physical barriers, engaging in sun-safe practices, and utilizing broad-spectrum sunscreen. Utilizing photoprotection matters as UV exposure is the main environmental factor driving skin cancer and photo damage associated with premature skin aging and pigmentary issues. The key message is that everyone needs photoprotection. Sun damage accumulates over time, regardless of age, skin tone, or lifestyle. As such, daily protection is just as important in everyday routines as it is on the beach. So whether the person is a child, an adult, fair, dark-skinned, the message is universal. Consistent photoprotection is a lifelong investment in skin health. While behaviors such as seeking shade and covering up are common forms of sun protection, sunscreen remains as a key preventative measure of photoprotection. The sun emits both ultraviolet radiation and visible light. UVB rays are shorter, high-energy rays that account for less than 10% of the UV radiation reaching the Earth and are blocked by glass. These are the rays responsible for sunburns and cause direct DNA damage to skin cells, resulting in various skin cancers. SPF is the measure of protection against these UVB rays. UVA rays are longer UV rays and account for up to 95% of the UV radiation reaching the Earth. These rays maintain the same level of strength during daylight hours throughout the year. They can penetrate windows and cloud cover and are responsible for photoaging, hyperpigmentation, as well as skin cancer. Now let's talk about sunscreen. Sunscreen contains active ingredients called UV filters, of which there are two main categories. Mineral filters, like zinc oxide and titanium dioxide, sit on the skin surface and absorb and deflect UV. Chemical filters, also known as organic sunscreens, like avobenzone and sulazole, homosalate, octosalate, octocrylene, octinoxate, absorb UV and convert it into a small amount of heat, which is then released from the skin. SPF stands for sun protection factor and is the relative measure of how much UVB radiation is required to cause sunburn on protected skin, or skin with sunscreen, compared to unprotected skin. The SPF value is determined in a lab under controlled conditions with a specific amount of sunscreen applied, that's 2 milligrams per centimeter squared. SPF measures protection against UVB only. The common misconception is that SPF is a measure of time. However, it is not a measure of time, but instead measures the amount of UVB radiation that is blocked. So as an example, we see here the sun as a shower head, with the sun rays filling corresponding buckets that represent accumulated sun damage. An SPF of 30 sunscreen means that 96.7% of UVB rays are blocked, and 3.3% amount of the rays drip through. These rays accumulate in the bucket below, and for SPF 30, it'll take around 30 minutes to fill the bucket. As the SPF number increases, the jump in protection becomes much smaller after that SPF 30. This means that a higher SPF provides a small but meaningful increase in protection, which is crucial given that most people do not apply enough sunscreen in actual practice. And over time, that damage accumulates. So in the real world, sweat, water, or rubbing over sand reduces the amount of sunscreen on your skin, which in turn lowers the actual SPF protection provided, thus causing your skin to accumulate a higher UVB dose most quickly. Because UVB can never be totally filtered out by any sunscreen, dermatologists emphasize reapplication every 2 hours and avoiding the sun during peak hours with highest UV index. There are 3 types of UV radiation, actually, namely UVC, UVB, and UVA. As the ozone layer absorbs UVC and most of UVB, it barely absorbs any UVA, and the action of sunscreens primarily provide protection for the UVB and UVA ranges. UVA penetrates deep into the skin layer and is primarily associated with aging and pigmentation. In contrast, UVB causes sunburn and DNA damage, which are the underlying mechanisms that can lead to skin cancers. Some filters target UVA2, a narrower but important part of the spectrum that contributes to long-term skin damage. The different UV filters provide coverage for different parts of the spectrum. However, no single filter covers the entire UV spectrum range effectively. And that's why formulations combine multiple filters, creating that broad spectrum protection. In formulating these sunscreens, several factors are taken into consideration. A good sunscreen considers not just the choice of the UV filter and efficacy and safety of the underlying formulation technology, but also incorporates characteristics that are meant to drive patient compliance, such as the texture, the wearability, appearance, sensation, and vehicle type. Ultimately, the best sunscreen is the one people will use consistently and correctly. As such, creation of balanced, acceptable formulations is an important characteristic that drives patient compliance and ensures good, uniform sun protection. So far, we've walked through the what and why of sun protection, but what does this all look like in the real world? To answer that, we went directly to the sources. 2 surveys were launched to capture the behaviors and perceptions of both consumers as well as healthcare professionals in terms of their perspectives on sunscreens, as well as investigated consumer habits and characteristics of sunscreens that drive underlying use. We developed 2 distinct surveys, one for the consumers and the other for the healthcare professionals, in order to get a holistic view from both sides of the conversation, with the intent of seeing where these perceptions aligned and where they diverged. Let's start with the HCP perspective. The survey, which to date is the largest HCP US dermatologist survey conducted, was placed in the United States in December of 2024, and it had evaluated US HCP perceptions of sunscreen filters as well as explored insights as to what factors influenced patient use. 723 respondents, of which about 70% were dermatologists, provided a response. The survey results showed that all HCPs agreed that sunscreen lowered photoaging risk, while almost all agreed that the best sunscreen is the one their patients will use. 96% agreed that sunscreen and sun-safe behavior are integral parts of the counseling practice, and 3/4 of all respondents noted an increase in reported usage of sunscreen among their patients. There was a significant difference in the perceptions of sunscreens used by patients based on years of practice of the clinician. And those earlier in their careers were more likely to report an increase in usage of sunscreen by their patients. When HCPs were asked about their perceptions on characteristics of sunscreen actives and how these characteristics influence the use of sunscreens by their patients, differences in perceptions of formulation characteristics based on the actives emerged. Roughly 3/4 of all respondents agreed that application and aesthetic characteristics were better in sunscreens comprised of chemical filters. In fact, almost all of the HCPs surveyed agreed that sunscreens which offer a better aesthetic and application experience are far more likely to be used consistently by their patients. The results reveal the practical realities of patient compliance, as while HCPs may exhibit personal filter preferences, their clinical experience tells them that a product that feels greasy or leaves a white cast or is difficult to apply will simply not be used, and a sunscreen that isn't used offers 0 protection. These findings demonstrate the importance of ensuring product diversity, as well as the need to ensure the availability of not only safe and effective products, but products that have formulation attributes that directly addresses a primary barrier to consistent sunscreen use, which is the user experience. Now let's turn to the consumer perspective. We conducted a comprehensive survey of U.S. consumers in both 2020 and 2024 to understand their perceptions and behaviors regarding sun protection. The two surveys were designed to evaluate their perceptions and stratified by burner type, how often they burn, ethnicity, family status, gender, and generations in order to explore whether any differences in their behaviors, habits, preferences, or knowledge gaps were present within these subgroups. A quarter of respondents were based in the southern United States, where sun exposure is often a year-round concern. Most respondents fell in the 25 to 54-year range, with a notable increase in the 35 to 44-year age group from 2020 to 2024. The percentage of sunburns among the general population increased 20% in 2020 to 25% in 2024. The most common activities where sunburns occurred were at the beach, but also simply walking outside. And the most common places people were getting burned were on the face and shoulders. These data tells us that while recreational activities are well-known avenues where sunburns can occur, sun damage isn't just happening on vacation. It's happening in our everyday lives. The rise in sunburn incidence signifies that despite awareness among consumers of sun exposure risks, sun protection practices are falling short. When asked about sunscreen preferences, the results showed an evolving landscape in terms of consumer sunscreen use habits. First, in terms of filter preference, a clear movement towards a more balanced approach was observed, wherein consumers who used both mineral and chemically sunscreens equally increased significantly from 2020. In contrast, the preference for chemical filters declined from 2020, shifting towards the more diverse usage pattern. When asked about SPF and product formats, a clear preference for higher protection and user-friendly options emerged. The most preferred SPF was SPF 50, followed closely by 30. And then finally, a lotion remains the most preferred format. However, the increased use of other formats, such as sprays, signifies that consumers are starting to look for variety and convenience and embracing formats that make sun protection a part of their daily routine. Regardless, when considered against the increase in sunburn incidence over the years, the data shows that while knowledge of the risks of sun exposure and importance of sunscreen use as photoprotection were evident among consumers, the message of consistent sun protection has not quite sunk in among consumers as an everyday behavior. The data also signifies that the key to reducing sunburns isn't just about awareness, but it also entails providing a diverse range of products that consumers actually want to use based on their personal preferences. The data from both surveys converges on a key finding that aesthetic and application attributes of sunscreen products are critical determinants of real-world use, highlighting a clear need to prioritize both scientific effectiveness and a user-centric design in order to facilitate consistent, correct, and daily use. In addition to evaluating consumer and HCP perceptions, we conducted a randomized controlled trial to directly measure how perceptions of aesthetics influence actual usage. Our study, a clinical trial with 96 participants of diverse skin tones, measured the whitening effect of 5 mineral and 1 chemical sunscreen. The objective was to directly evaluate how perceived whitening influences product likability and application habits in a controlled setting. The results provided objective scientific validation for the trends we observed in our surveys, wherein sunscreen likability and the application experience were significantly higher in sunscreens that contain filters that were not associated with significant whitening. Critically, participants directly adjusted the sunscreen they applied on their faces based on perceived whitening. Thus, the density of those sunscreens that induced whitening was significantly lower compared to those that were less whitening. This study moves beyond self-reported behavior and provides a quantitative evidence that a sunscreen's aesthetic attributes directly impact the amount applied. This means that a sunscreen perceived as whitening may lead consumers to apply less, potentially compromising the labeled SPF and increasing the risk of sun damage. Overall, research provides a comprehensive and interconnected view of sun protection. We've established that the science is sound, wherein both mineral and chemical filters provide effective and safe broad-spectrum protection when used consistently and correctly. The HCP data shows us the crucial importance of aesthetics for real-world compliance. Clinicians know that the best sunscreen is the one their patients will actually use, and they rely on formulations that are aesthetically pleasing to ensure that happens. The consumer data supports this, revealing a market that is becoming more discerning and nuanced in its preferences. The shift towards using both filter types, combined with the rise in easy-to-apply formats, indicates that consumers are actively seeking diverse options to fit the different needs and situations. Finally, the clinical usage study provides the objective, quantitative evidence showing that aesthetic factors like a sunscreen's whitening effect directly lead to a measurable decrease in the amount applied, confirming that product design is a critical variable in achieving effective photoprotection. The combined findings underscore a fundamental principle that a sunscreen's full photoprotective potential is only realized when its aesthetic and application profile ensures reliable and sufficient use. Thank you for taking the time to hear about this important research.
Good morning, everyone. The title of my presentation is Understanding the Human Safety of Organic Sunscreen Active Ingredients, a Mode of Action Approach. My name is Jay Nash. I'm a research fellow at Procter & Gamble, and for the past 30 years have been responsible for the human safety assessment of consumer products. I am excited to discuss one of the most critical topics in public health, namely the human safety of organic UV filters commonly used in sunscreens. Specifically, I will address the carcinogenic potential of 6 sunscreen active ingredients: avobenzone, ensulisol, homosalate, octinoxate, octisalate, and octocrylene. You've probably seen some headlines that make you wonder about the safety of sunscreen products and the chemicals in them. You may have stood in front of a giant wall of sunscreens and felt confused, because on the one hand, you know how important these products are to prevent sun damage, and on the other hand, you have seen reports that question their safety. Today we're going to dive into the science to get some answers. So let's get right to the big question on everyone's mind. Are the chemical UV filters in sunscreen safe? You might be wondering what is behind this question. Well, in 2019 and 2020, the U.S. Food and Drug Administration, or FDA, published 2 studies showing that tiny amounts of certain sunscreen active ingredients can get into our bloodstream following application of 1 ounce of product every 2 hours, or 4 ounces in 1 day. These studies were conducted over 4 days, meaning that participants applied the equivalent of 2 8-ounce containers of sunscreen product. Now, the appearance of these UV filters in plasma didn't automatically mean they were dangerous, but it definitely meant regulators wanted to take a much closer look at their long-term safety. So how are topical sunscreen products assessed for safety? Well, the individual ingredients and finished products undergo rigorous toxicological evaluations, including effects on the skin or site of application, such as irritation and contact allergy or sensitization, along with evaluations of effects on reproductive toxicity and impact of repeated exposure on internal organs such as the liver, the kidney, the lungs, etc. Today, the question we are focusing on is one of the most important toxicological assessments, namely the carcinogenic potential of a chemical. For the last 60 years, whenever a question like this popped up, the go-to method has been this one standard test called the 2-year rodent bioassay or carcinogenicity study. It's been the default playbook for a long time. But here's the thing. As we're about to see, this old way of doing things has some serious limitations, especially when you're trying to figure out what a chemical might do to a person, not a mouse or rat. On the surface, the traditional methods are simple enough. Give rodents super high doses of a substance, basically for their entire lives, and then just watch to see if they get tumors. But there is a flaw in this logic. What happens in a rodent often has absolutely nothing to do with what happens in human. And these studies are designed to find positive effects, making them, in some cases, completely irrelevant to human biology. If you want one number to illustrate how big this problem is, it is 18.2%. That's the positive predictive value of these tests as presented in the work by Petillo and colleagues. It means that when a rodent study finds a cancer risk, it's wrong about the risk to humans more than 4 out of 5 times, creating a ton of noise and confusion. And look, this isn't just some fringe opinion. This is coming directly from FDA scientists as well, who also acknowledged that these old tests often show tumors, but those results can be totally irrelevant to human cancer risk because the doses are different and the species are different, to name the most common reasons. So, if the 2-year rodent study is unreliable, what's the alternative? We can't just throw our hands up and guess. Is there another way to assess the human carcinogenic potential of ingredients like UV filters? Fortunately, the answer is yes. Because our fundamental understanding of cancer biology has come such a long way, scientists, including those listed on this paper, have developed a much smarter way to assess carcinogenic potential of ingredients such as UV filters, based on something called the mode of action. So what on earth is the mode of action? Well, it's a different way of thinking. Instead of just waiting to see if a tumor shows up in a mouse, which is the effect, this approach asks a much deeper question. It asks, does this substance even have the ability to flip any of the known biological switches that actually cause cancer? It's about looking for the cause, not just the effect or the final outcome, which is often a misleading result. Here's a really simple way to picture it. The old rodent test is like trying to solve a crime by investigating every single person in the entire city. It's inefficient, costly, time-consuming, and you're probably going to accuse a lot of innocent people. The mode of action approach is like a smart detective who knows there are only 4 ways the crime could possibly have been committed, so they check for evidence related to those 4 specific methods, making it focused, efficient, and accurate. Based on years of study, there are 4 well-established ways that chemicals can cause cancer in humans. They can directly damage our DNA. They can promote tumor growth through really strong sustained hormonal activity. They can weaken our immune system's ability to hunt down cancer cells, or they can cause so much chronic cell damage that our body's repair systems go into overdrive and make mistakes. For the 6 UV filters in question, extensive data indicate that they do not exhibit relevant carcinogenic modes of action. Specifically, they are not DNA reactive. All 6 UV filters have been tested in numerous genotoxicity assays, showing no evidence of mutagenicity or clastogenicity. This indicates that they do not cause direct DNA damage. Moreover, there is no evidence that any of their known metabolites directly damage DNA. Secondly, some in vitro and to a lesser extent in vivo studies show weak estrogenic activity. However, these effects are seen at concentrations or doses 100 to 10,000 times higher than those found in human plasma after sunscreen application. Moreover, in human clinical studies, no significant effects on hormone levels have been reported. Thirdly, data from repeat dose toxicity studies indicate no adverse effects on immune function. Further, these UV filters do not cause sensitization or significant changes in immune cell populations. Finally, the concentrations at which any cytotoxic effects were observed in vitro are significantly higher than those measured in human plasma following typical sunscreen use. As well, repeat dose toxicity studies show no evidence of cytotoxicity leading to abnormal cell growth. Thus, for these commonly used UV filters, avobenzone, ensulazole, homosalate, octinoxate, octisalate, and octocrylene, there is no evidence that they activate modes of action that are known to produce cancer in humans. So in conclusion, the mode of action approach provides a robust framework for assessing the safety of organic UV filters used in sunscreens. The available evidence support the conclusion that these filters do not pose a significant carcinogenic risk when used as directed. As we continue to prioritize consumer safety, it is essential to rely on scientifically rigorous methods that reflect real-world exposure scenarios rather than outdated animal testing paradigms. I'd like to acknowledge the expert panel who is responsible for putting together the mode of action and publishing this work, led by Sam Cohen, who is an internationally known expert in cancer biology. I'd also like to thank the contributions of all members of the PCPC Sunscreen Working Group. Thank you for your attention, and I look forward to any questions you may have about this topic.
Hi everyone, thank you for making time to attend my presentation today where I'll discuss the retrospective review of thermal safety studies of organic sunscreens. Just a couple of disclosures up front. I am a full-time employee at Kenvue. The views and opinions presented today are mine and don't necessarily reflect the official position of Kenvue. And the data presented from the studies today were supported by Kenvue. So the scope of our analysis was to look at the greater than 3 decades of skin safety data from RIPT, CIT, phototox, and photoallergy studies that were conducted on our sunscreen products, looking at both daily use and our active use products. And we primarily focused on our 4 main organic UV filters utilized, being avobenzone, octisalate, octocrylene, and homosalate. In the next two slides, we highlight the study protocols for our local safety testings, which I am sure everyone is very familiar with, but just to point out a couple of points for RIPT, which helps us determine the potential for dermal sensitization. Here we do test 100 to 200 panelists, which is accepted as industry standard. And then for a CIT, after the 2 weeks of testing, the sites are graded for the presence and the degree of reaction. And again, for both of these studies, pending on the product type being tested, if it's a leave-on, it's tested neat. If it's a rinse-off, there is an appropriate dilution factor. And because we're talking about UV filters here, we also have phototoxicity and photoallergy testing. Phototoxicity testing is done prior to photosensitization testing. Here, again, 2 sites are tested. 1 site is exposed to UV radiation. If a reaction is observed in a subject, they are challenged 1 to 2 weeks post-study. And if the reaction is retained, then phototoxicity is confirmed. For photoallergy, we have 3 phases: the induction, a rest phase of roughly 2 weeks, and a challenge phase. In both the induction and challenge phase, 1 site is exposed to UV radiation. And then if only the UV radiated site has a reaction, it's classified as a photoallergy. If both sites exhibit a reaction, it's sensitization. And the subjects that did have a reaction are re-challenged 2 weeks post-testing to see if the initial reaction is retained. The way we conducted this analysis was, once we identified the formulas of interest, we went into our database and looked at the RIT, photoallergy, phototox, and CIT study reports. That data was further bucketed into a daily use and active use product type. This was further refined into whether it was a product, a cream, stick, spray, or a serum. Then this was further bucketed into the different combinations of the filters. And then we generated graphs. In the next table, it shows how the groups were bucketed based on the number of filters contained. Here we looked at 355 formulations. This table spans a full range of use concentrations. So again, in our tables, we look at a bucket of products that had all 4 filters, a combination of 3, a combination of 2, and a single filter. I will point out here, we do acknowledge that we do not have a product with a single filter. However, this filter could have been in combination with a mineral sunscreen, which is out of scope for this analysis. So if we dive into the result, all our tables are structured in a similar manner, where we have the buckets of the filter combination up top. On the left-hand side, we have our daily use and our active use, and this is further broken into the product type. Then we look at the number of product and the number of subjects. So for RIPT, we have a very high pass rate for both our daily use and our active use products, with the exception of 3 subjects that failed in the daily use and a total of 4 subjects that failed within the active use. And when we get into the discussion section, we'll call out the common denominator in all of these failures. Looking at cumulative irritation for both our daily use and our active use products, all of the products that were tested, they were categorized as having no irritation to a very mild irritation potential. So this really highlights the gentle formulations that are being developed. For phototoxicity, again, here looking at daily use and active use, all of our products passed for phototoxicity, and the same trend is seen, for photoallergy, where again, all of our products passed photoallergy testing. As I noted up front, we, in this analysis, looked at a range of sunscreen products going from lotions to sprays, sticks, and serums. I'll also point out that these formulations contain different excipients such as glycols, alcohols, and surfactants, which could potentially enhance the penetration potential of the UV filters that we're interested in. However, our analysis shows, despite the product type or the types of excipients that could potentially be included, we do have very safe products. And just to conclude again for RIPT, we had no sensitization observed in both our daily use and active use of greater than 99%. The subjects that did fail, they actually had a product that contained MIT, which was then in 2013 classified allergen of the year. So again, this really shows our testing does exactly what it was intended to do, was to pick up signals of potential irritation and sensitization. For cumulative irritation, no products were observed to be induced greater than a very mild irritation across either category. And then for phototox, photoallergy, all of our products passed this testing. So our extensive safety data does demonstrate that sunscreen products have excellent skin tolerance and safety profiles. And the very large number of subjects that were included in this analysis does help us with confidence extrapolate this into a larger population that's going to be using these sunscreen products. And with that, I thank you for attending my talk today.
Our next presentation will be an industry sci-comm leadership case example featuring Independent Beauty Association, who, for those of you who don't know, I've been working very closely with for some of their sci-comm advocacy, and I think that they're doing wonderful work. This whole summit today was inspired by a collaboration that I've been working with them for the past 3 years, which is their Truth and Beauty panels that they've been hosting at conferences, which I've then gone and turned into this conference today. So I'm really excited to feature them. And to lead this presentation will be Dr. Akemi Ooka and Meredith Petillo. Akemi is CEO of the Independent Beauty Association and has over 20 years of leadership experience across the CPG sector. She has held key roles in product development, sourcing, and supply chain transformation at companies including Clorox, Method, and J.R. Watkins. With a PhD in chemistry, Akemi now leads IBA in supporting independent beauty brands with education, advocacy, and resources for long-term success. Meredith is VP of Technical and Regulatory Affairs at IBA, with more than 15 years of experience spanning regulatory affairs, product development, and claim substantiation. She holds degrees in biochemistry and regulatory affairs and now leads IBA's regulatory programming and advocacy. Meredith is dedicated to helping indie brands thrive in an increasingly complex regulatory environment. And without further ado, here's their presentation.
So IBA is a nonprofit trade association for the beauty industry. We're focused really on small to mid-sized businesses in and around the beauty sector. I think misinformation is a topic that's very interesting to us because as a trade association that's focused on best practices for the industry, legal and regulatory compliance, and also advocacy on behalf of the industry, we're seeing that misinformation is playing a role in each of those areas and is posing challenges, I think, for the industry as a whole, as well as consumer perception and understanding. And what we're really seeing is it's bleeding into policymaking.
Legislators are the recipients of a tremendous amount of information from many, many stakeholders. That information can be presented from various lenses and various areas of expertise. A lot of times policymakers and legislators don't have practical experience in the industries in which they're trying to draft language that is going to be folded into proposed legislation and possibly enacted. It's imperative that industry is able to provide credible, understandable, and practical information to help them make informed decisions and to make sure that the language that is going to be potentially codified into law is providing not only the businesses that are impacted in this area, but ultimately the consumer who's the most important end recipient of the products that this industry is going to be manufacturing and distributing to the American population.
IBA has been very interested in the topic of science communication. For the last 3 years, we've been really focused on how do we get information about the industry into the social media conversation. And part of that is looking to science communicators as a vehicle to share what's really going on behind the scenes in the industry. It's quite interesting because they're a class of experts who have firsthand knowledge and experience, in the industry. And so they can really speak from a place of authenticity and credibility. Some of the things that we've focused on have been a series that we've called Truth and Beauty. And so this is really tackling from a variety of different perspectives, how misinformation plays out in the beauty space. So whether that is in claims language, whether that is in influencer conversations, whether that's in consumer questions and concerns. So we've tried to tackle that from a variety of perspectives. We've actually also started to do more interviews in this area through IBA Studio, where we're really talking to not just science communication influencers, but also with real operators in the industry to provide information about what does it take to bring a product to market? What are the rules and guidelines that you really need to follow if you're going to be compliant from a legal and regulatory standpoint? And so we really want to bring that perspective to life and help people understand that it isn't really the wild, wild west. If you really are developing a product properly, you are following guidelines, laws, regulations in this space. And we're finding that that's really resonating, I think, with not just people in the industry, but people outside of the industry. It's been very successful so far and something that we want to continue to support, both, I think, financially and also with a platform. It's important to make sure that the science communicators who are speaking and talking from experience, have the ability to do the work behind the scenes to kind of bring that credible information to life, do all of the research, do all of the background checking and validating of all the information that they're bringing forward. And we really think that that's an important group of individuals to support.
The IBA Studio is a wonderful opportunity for the cosmetics and personal care industry to provide their expertise in a way that is approachable by anyone. I think that often it's overlooked about how complex the chemistry is in this industry. The end product, the widgets that we make are part of everyday life. And I'm not sure that the average consumer thinks about how complex it is not only to formulate the product, but to make sure that that product is compatible with its packaging, that it will be able to sustain shipment from where it's manufactured through the whole distribution chain to the end consumer, to remain safe and stable and properly preserved from microbial growth. There's a lot that industry stakeholders and those who have spent their entire professional careers in this industry take for granted, that this studio concept from IBA has given, the opportunity to make some of those brilliantly basic facts easily accessible and understood by those in the industry and also outside of the industry.
So here are some examples of some work we've done with the IBA Studio. In this case, we were talking about brilliantly basic facts about the cosmetic industry that we wanted to bring forward and share with operators, consumers, industry stakeholders, and share some of the complexity and the fun and how interesting the cosmetic industry really is.
What's a brilliantly basic fact about cosmetic science?
Mineral sunscreens will always leave a white cast. It is an insoluble white powder, and you just can't change the science of it.
When it comes to hair conditioner, many people think that oils and butters are the ingredients that will make hair soft, but this is actually the fatty alcohols, the cations embryonic surfactants. The ingredients that most consumer cannot consume are actually the ingredients that makes a hair conditioner a conditioner.
All UV filters absorb UV light. It doesn't matter if it's chemical or mineral, they all absorb UV radiation.
Chemical sunscreens, they're actually called organic sunscreens, but the organic word doesn't mean necessarily that it's organically grown. It means that it has carbon. So when we use the word organic, it means that it has carbons.
While the media outlets might convince you that preservatives are bad, they actually improve the shelf life and the safety and the stability of your skincare products.
Surfactants are compounds that combine both oil and water components, which normally don't mix together. These surfactants can help you both moisturize and to clean yourself, and they're really an exciting molecule, and I think everybody should know about them.
This notion about filler ingredients gets spoken about a lot in cosmetics, but fundamentally, every ingredient that's in your cosmetic product is there for a purpose, whether that is for an actual element of the benefits of the active ingredients in the product, or even just as important, in my opinion, the overall user sensory experience of the product, because if you don't like to use a product, are you really going to use the product?
Tell me a brilliantly basic fact about cosmetics. Part 2.
Everyone thinks that natural cosmetics are better. Natural cosmetics can be safe, but they're not per se better than other formulated cosmetic products.
We don't realize it, but cosmetics make up an incredibly immense amount of American revenue, with $26 billion in the United States.
It is literally a product that you use from the day you were born to the day you die. It's part of your life every day of your life.
There are very few approved colorants for the personal care space. There are only a handful, and one of them includes pearlescent pigments, which is not actually a colorant. It is a substrate that reflects light.
Innovation is hard. It's really hard to innovate something that's truly new, fills a gap in the industry where there isn't already a competing product.
What biotechnology is, it's using microorganisms to create products and molecules of interest. Typically, you would use yeast and you would use bacteria, and then you would ferment these rather than run it through a chemical synthesis.
The cosmetics industry is leveraging biotech at an incredible pace, but biotech has been used historically for decades.
Less is more. For example, adding more of an active into your formulation doesn't always make it better. Some ingredients that works best at specific concentrations can be irritating at higher levels. So simplicity is your friend.
The regulatory groups that oversee our industry, specifically the FDA, prohibit manufacturers like ourselves from allowing product to enter commerce that's unsafe, meaning that all of this marketing around potentially hazardous materials is actually a direct violation of the law that all of us cosmetic manufacturers have to adhere to.
There are many products that are outside of color cosmetics that are regulated as cosmetics, like shampoos and hand soap, things that everyone is using every single day, but you wouldn't naturally necessarily think of as a cosmetic.
They are not drugs. They cannot heal anything. They can't restore cells. They can't regenerate cells. They can't make hair grow. A cosmetic is something that makes you look and feel beautiful. If something is touting a claim that says it heals or anything drug related, well, it's not a cosmetic.
Clean and natural do not have an actual definition. So if you come to one of my chemists and you ask for a clean formula, they are not going to know what you mean. What you have to do is you have to pick which clean standard that you want to follow.
People often think of it as a somewhat of a frivolous industry. It's actually all about wellness, self-image. Throughout the world, there are lots of people struggling with that very thing. I think cosmetics makes a very major impact on the world and people's mental health, well-being, sense of self. So cosmetics is a hugely important industry across the world.
Our next presentation will be on the topic of shopping beauty like a good cosmetic scientist, featuring Lanesa Mahon. Lanesa is a PhD candidate in pharmaceutical sciences at the University of Cincinnati, where she is specializing in cosmetic science. She holds degrees from Vanderbilt and Rutgers University, where she completed a Master's of Business in Science and Cosmetic Science. A passionate advocate for accessibility and inclusion, Lanesa has been active with NYSCC, serving on committees and creating educational content. Her research and outreach aim to bridge the gap between the lab and the beauty aisle, empowering consumers through evidence-based knowledge. Without further ado, here's Lanesa.
Hi, my name is Lanesa Mahon, and today I'm here to talk to you guys about shopping beauty like a good cosmetic scientist. And for this talk, in the first part, I'm going to go into ingredient lists, how to read them, what they can be useful for, but also their limitations. And then in the second half, I'm going to dive deeper into the world of product claims, claims language, and the different types of claims that you need to be aware of when you're shopping for beauty products. So shopping for products as a consumer nowadays can be difficult. There are so many products and so many brands that make a lot of claims on what their products can do. There's fear mongering, there's science washing, and somehow everything happens to be #1 dermatologist recommended. And it can be hard to figure out, where do you even start? While everybody's trying to convince you to buy their products, not everybody is putting in the necessary time and effort into product development and testing. You want to spend your money wisely, and you want to buy products that have the highest chance of success. So you have to look for products that are backed by evidence. So that's what makes smart shopping so important. What we have to remember is that brands are profit-driven entities, and they are trying to sell you their products, but their products may not be worth buying. Product development is a huge expense for a lot of companies, and some people cut corners instead of investing into research and development and product testing. The cosmetic marketplace is also extremely competitive. There are hundreds, if not thousands, of products that are all competing for your dollars. So they're trying to make themselves stand out and offer a unique value proposition to stand out amongst the vast sea of their competitors. And finally, cosmetics regulations and enforcement in the US are kind of lax, and you would be surprised at how many brands slip through the cracks with doing shady and even illegal practices. Another thing that we have to remember about cosmetics is that they are not drugs, they are not subject to pre-market approval, and they do not have to prove efficacy in order to be marketed. You have to be able to look at a product, its ingredients, and its claims, and make a determination whether it's worth buying or not. Let's start off with the basics, and that is reading the ingredient list. Reading an ingredient list can be very helpful. If a consumer has a particular concern, they can use the ingredient list to find products that contain ingredients that might help address them. In order to read an ingredient list, you have to know a couple of things. First, an INCI list lists ingredients in the products in descending order of predominance. That means that closer to the top of the list, you'll have ingredients that are at a higher concentration. These ingredients are listed in this order until the 1% line. After that, they can be listed in any order. Now, the 1% line can be very difficult for consumers to identify. It could even at times be hard for me as a cosmetic scientist to identify them as well. There are certain ingredients that can be indicative of this 1% line. Certain preservatives, such as phenoxyethanol, fragrances, they're typically going to indicate where the 1% line is. On an ingredient list, cosmetic ingredients must be listed by their INCI names, or their International Nomenclature of Cosmetic Ingredient Names. Now that we know what an ingredient list is, let's talk about what an ingredient list can and cannot tell you. An ingredient list can tell you what is in a product. It can also help you to ensure that a product contains the ingredients that it claims to have. It can help you find products with ingredients that you might be looking for. On the flip side of that, it can help if you have allergens or any type of ingredients that you are sensitive to and that you need to avoid. And lastly, it can help you figure out if a product has the potential to work. And I say potential very carefully. So when we're thinking about if a product has the potential to work, let's take this example. Let's say that I am looking for a brightening product that contains vitamin C, and I come across this ingredient list. This is a vitamin-enriched face base and moisturizer primer with vitamin C and hyaluronic acid. Well, it says it has vitamin C, and I see hyaluronic acid somewhere in the middle of the ingredient list, but where's the vitamin C? The vitamin C is down here at the bottom of the ingredient list in the form of magnesium ascorbyl phosphate. Now, this ingredient list tells me two things. Number one, this is not vitamin C, but a vitamin C derivative. Those are not the same. Derivatives are modified version of an active, and changes in structure affect ingredient delivery and activity. So, magnesium ascorbyl phosphate is not exactly vitamin C. Secondly, this being so low on the ingredient list, it's likely not going to have a brightening effect. Vitamin C usually needs to be formulated at 2% or higher to observe that brightening effect. So having it down there way below the 1% line, it's likely not going to give me the effect that I'm looking for. So if I wanted a vitamin C product that was going to brighten, this would likely not be something that I would choose because the vitamin C is at such a low concentration. Nuance is also needed when we're talking about how much of an active is in a product. Some actives are more potent than others, and they might not need to be at as high of concentrations. On the right, I have at the top a dose response curve. So this shows the therapeutic response to various concentrations of different actives. Actives that are lower on the x-axis are more potent and therefore do not need to be at as high of a concentration as maybe another active. So a good example of this is retinoids versus niacinamide. A retinoid can be formulated at a lower concentration, often below 1% because they are such powerful actives, whereas niacinamide needs to have at least like 2 or 3% concentration to show activity in a product. Having more active is not always a good thing. Down below, you can see the therapeutic window. So the therapeutic window is the range of concentrations in which a therapeutic benefit is seen. For an active, this would be the range of the concentrations that will show you an effect with your active. If you're below this concentration, you're not going to see an effect. However, if you get too far above this therapeutic window and adding more or having a higher percentage, you can actually start to approach the adverse event threshold. So actually, having a higher concentration of certain actives can increase the potential for irritation and skin sensitivity. So more is not always better with these actives. Now that we've talked a lot about the cans, let's dive into the cannots because a lot of people tend to overestimate what an ingredient list can tell them. An ingredient list cannot tell you how an ingredient is functioning in a particular formulation. It cannot tell you the source of an ingredient, the purity, quality, or grade of the ingredients. And for certain ingredients, such as natural extracts, you will not know an exact composition because these are blends of various materials. Furthermore, one inky can represent multiple different ingredients, such as dimethicone, and this is especially relevant when we talk about polymers. Another thing an inky list cannot do is tell you if you like a product or help you determine product safety or efficacy. And this is extremely important because this is where a lot of the misinformation and fear-mongering in the industry stems from. A lot of these clean beauty companies use fear-mongering as a marketing tactic to manipulate consumers into buying products that are less effective, less safe, and more expensive. And they do this by misinterpreting and misrepresenting scientific information to promote chemophobia and make assertions about product and ingredient safety that are not rooted in scientific evidence. And this has led to so many consumer misconceptions around ingredients. There is this idea that if an ingredient isn't an active ingredient, it's just a filler ingredient and it's not important to the formulation, where a lot of the filler ingredients that they're talking about are extremely important to the stability and sensorial aspects of and performance of the product. On top of that, there's this idea that having certain ingredients makes a formula toxic, that natural ingredients are somehow better and safer than synthetic chemicals. Poison ivy is natural. It's still not good if you rub your hand on it. So a natural ingredient being natural does not mean that it is safer than a synthetic. On top of that, there is this idea now that has been recently perpetuated that preservatives are unsafe. It has promoted a level of chemophobia and fear around safe product ingredients that it has actually made it more difficult for people in industry to do their job and deliver safe and effective products. A lot of the times, consumers do not have the chemical and raw material knowledge to understand an ingredient list. And they then turn to these flawed apps like EWG and Ooka, trying to derive meaning and figure out if their product is safe, and they are being misled. And that is a huge point that I want to make. Ingredient lists cannot determine product safety or product efficacy. And these apps like Ooka, EWG, and the ones that claim that they can look at your ingredients and tell you whether a product is good or bad, they rely on cherry-picked data that is usually irrelevant to topical delivery or product use. Many times, these ingredients are deemed high risk due to oral dose animal studies, and you cannot extrapolate a mouse eating large amounts of something to a person rubbing something on their skin. It also ignores many things that are needed to determine product safety. It completely ignores the foundations of toxicology and the fact that exposure is a product of dose and route, and that is what determines the poison. Anything can become poisonous in the right concentration or when taken the wrong way. Let's take water, for example. If you drink too much water, you can actually get water toxicity. If you inhale water rather than drink water, that can be toxic. So there are a lot of things that you have to think about when you're making a safety determination, including how much of a particular ingredient is in something and what is the route that it is being delivered. These apps cannot accurately calculate risk. And if you have this app on your phone, I suggest that you delete it because it's doing so much more harm than good. So as I move forward, I would like for you guys to keep the cans and the cannots in the back of your mind. These are extremely important. While an ingredient list can be used to figure out if a product has potential to work for a particular concern, that ingredient list still cannot tell you how safe or efficacious a product is. Now, you may be wondering, if an ingredient list can't tell you that much about the efficacy of a product and you're trying to buy a product, what can? Well, that is where we get into the product claims, because if a product says that it can do something, it should be able to provide proof that it can do what it says it does. Claims and testing are a really good way to get an idea of how well a product is going to work. So that brings me to part 2, which is product claims. So most of the time when you're shopping for a new cosmetic product, you're looking to address a particular skin concern. Common skin concerns are dryness and hydration, hyperpigmentation, acne, scarring, aging, redness, and sensitivity. Active ingredients are ingredients that impart skin benefits, and they are a great way to address skin concerns. Product claims are typically going to be made around a product's ability to address these various skincare concerns. Claims are statements that provide evidence for product performance. And there are 3 main types of claims that you're going to see for a finished product: ingredient claims, consumer perception claims, and clinical testing claims. And claims has its own language. There are subtle differences in wording and language that can mean drastically different things for how a product was tested and how the claims were substantiated. It's important to note that all claims, no matter how weak, must be substantiated. However, not all claims require testing. We're going to start with ingredient claims, and these are the most common type of product claim. They are also the least expensive to validate. These are weak claims that don't require any type of finished product testing. However, there are two caveats. Number one, an ingredient that is being called out has to be in the formulation. However, it can be at any percentage. As we saw earlier with the moisturizer, it said that it had vitamin C, even though vitamin C was at an extremely low percentage. The second caveat is that you have to be able to find a study in literature or some type of evidence that supports this claim, whether it be an in vitro study, an in vivo study. Like, you have to find something that is going to support this claims. And that is why these claims are pretty weak in nature. So on the bottom here, you can see a couple of different ingredient claims for 3 different products. So you're going to see a lot of statements being made about what ingredients do in these ingredient claims. A lot of the times, the evidence for certain ingredients, especially some of the newer actives, is really lacking. And I think if you really want to find the best products, you should seek out actives with a robust body of evidence. But what does that look like? Here I have a 3-tier scheme for how I classify ingredient evidence. At the top, it's the largest because a lot of ingredients will have these studies. They're pretty weak studies: in vitro studies, oral dose studies, and animal studies. They're hardly applicable to an ingredient's use in a topical formulation. As you work your way down the pyramid, you get to the stronger evidence. The strongest evidence that an ingredient can have is multiple well-controlled clinical studies. With this new push for the next new trendy active ingredient, there are a lot of bold claims that are based on little to no evidence. You'll see 2 main types of studies when it comes to demonstrating ingredient efficacy: in vitro studies and in vivo studies. In vitro studies are cellular incubation studies. These are done directly on cells, so they're limited in their applicability to real life because your skin is a barrier that prevents the penetration of a lot of compounds. It's hard to take an in vitro study and extrapolate it to real use. On the other hand, in vivo studies, the applicability depends on how the study was designed. And you have to look at things like the controls, the sample size, the composition of the test formulations, and how the measurements were taken. It's important to remember that incorporating an active does not mean that it works in the finished products. Brands should do claim substantiation and testing on the final formulation. So that brings me to the next 2 types of claims: consumer perception claims and clinical testing claims. These 2 types of claims require finished product claim substantiation. They're more expensive and intensive than ingredient claims, and they can increase product costs. It is expensive to run a consumer perception study as well as a clinical study. First, you have consumer perception studies. These are studies where people are going to use the product and fill out questionnaires relating to how the product was sensorially and whether they saw any effects from the products. These claims are always worded as users said or users noticed. So some examples are 98% of users said skin felt more hydrated. These are pretty subjective measurements because it's just kind of asking a consumer how they like a product. Clinical studies, that is where you get those more objective measurements. So clinical studies are validated through clinical grading or instrumental analysis. In a clinical study that relies on clinical grading, even though it may seem subjective, these clinical graders are trained in order to reduce bias and subjectivity. Even though they have a little bit of subjectivity, there are steps that have been taken to make them more objective. The second type of study is an instrumental analysis, where you're going to use something like a cutometer or a TWA meter to actually get an output from the skin. Claims from clinical studies might go something like, there was a 242% increase in skin hydration after 12 hours. There is that language difference in how it's worded that can clue you into whether it is a consumer perception study or a clinical study. Most of the time when you see these claims on a product's marketing materials, they will have a little side note that says exactly how they validated that claim, whether it was a clinical study or whether it was a consumer perception study. Cosmetics cannot claim to prevent, treat, mitigate, or cure a disease. They also cannot claim to make structure function claims, so things that impact function or biology. You'll notice that hyperpigmentation products often say increase radiance or even skin tone, reduce the appearance of dark spots, because you cannot say gets rid of hyperpigmentation because that's a drug claim. You have to be careful. It does not matter what type of claim validation you did, you still cannot make drug claims on your cosmetic products. You may be wondering about these claims because these are some very common claims in the industry. And the one thing that all of these claims have in common is that they are unregulated. And I would even go as far as to call them deceptive. They have no real meaning. They have no set legal definition, guidelines, regulation, testing, or validation criteria to substantiate them. So pretty much these claims can just be thrown onto a product like parsley. Beware when you see these claims. They don't actually mean anything. That brings me to critically evaluating everything, to even critically evaluate the claims. So let's go through an example. This is an anti-aging serum. It is claiming that it is evidence-based skincare that produces a 56% increase in elastin production, 83% increase in hyaluronic acid production, and 6-fold increase in skin density. Those claims are extremely interesting. They are actually, number one, drug claims. But the question is, how did we get this? How did we get these claims? When you look deeper, you find that the results were derived from in vitro tests using cell-based assay models of human keratinocytes and fibroblasts. So this was done in cell culture. This is not strong evidence that this is what this product is going to do in the finished formulation. Here's another example. This is an anti-aging skin serum. It says that it produces 13% firmer skin, reduces wrinkles by 7%, boosts radiance by 32%, and refines pores by 15%. That's very interesting. How did we get that data? This says that this was a self-assessment, and this is why you have to be wary of how these claims were validated, because this is not consumer perception claims. None of these claims say users observed firmer skin or observed reduced wrinkles. These are almost like clinical study, instrumental analysis readings. It says that these results are from a self-assessment of 388 women in a consumer perception study. I don't know how you get to these numbers from simply a consumer perception study. How can a consumer look and say, my skin got 13% more firm, or my wrinkles reduced by 7%? You have to really be careful and make sure that the claims actually make sense for how they were tested. And that brings me to an extremely important topic, which is spotting non-compliance. There are thousands of non-compliant products on the market, and a lot of them end up flying under the radar of most regulatory agencies. But I will show you a couple ways that you can spot non-compliant products, because if a brand can't be trusted to do the basics, how can you trust them on the more important things? If you can't abide by FDA regulations, which aren't even that stringent, how can I trust that you did adequate product safety substantiation and stability testing? Non-compliant products are a huge red flag. This is non-compliance that I see on a lot of online shopping spaces. The first red flag is that this does not have the correct ingredient list for this product. You can look at this and you can tell that this is a non-compliant product because it does not have the correct ingredient list. These are drug claims. One claims to promote collagen synthesis. Another one says that it mimics the body's own mechanism to produce collagen and promotes collagen production. These are drug claims. These are structure function claims. The next red flag is FDA approved. The FDA does not approve cosmetics. Anytime a product is marketed under the guise of being FDA approved, it is not true. That's a lie. The last one is medical grade skincare. This is another term that does not mean anything. If you see something being marketed under medical grade skincare, they are being intentionally misleading. So with that, if you enjoyed this e-summit and want to learn more, I encourage you to go look at my other e-summits. I actually dive deeper into some of the topics that I touched on here today. And lastly, I just want to thank you all for watching, and thank you to Jen for having me back for yet another e-summit. It is always such an honor to be able to present and share my knowledge with you guys. I will see you in the Q&A session.
And bear with me as I bring Lanesa into the live screen here. Lanesa, I can always count on you for doing the best presentations on the topics of critically appraising cosmetic science topics. And this is why I have Lanesa back. She's presented, I don't even know how many times, like 5 or
this
many.
Is my 6th one.
Oh my gosh, 6.
I even missed one on the final slide. I had to go back. I was like, wait, I have 6. This is my 6th one.
It's because she does a really, really good job, as everyone who was watching found out today, if you didn't already know. So my first question came from Jizem. I'm sorry if I've mispronounced your name. Feel free to correct me if you want to. But the question, why aren't these active ingredient claims regulated in cosmetics? Is it too complex to differentiate?
Yeah. So active claims, they are actually regulated in cosmetics. So that's where you have your difference between your cosmetics and your over-the-counter drugs. So for example, if a product is claiming that it is anti-acne, that's actually an over-the-counter drug. So when you are evaluating that product, it should have actual active ingredients listed in the ingredient list that are I know I just said not to say FDA approved, but there are FDA approved actives for treating various skin concerns. It's just
as per OTC. It's not cosmetics, it's OTC drugs,
OTC,
not cosmetics.
Exactly. It's OTC drugs. So these active claims, they actually are regulated. It's just that there are just so many products, there's so many brands, there's so many different online marketplaces. It can be, I guess, challenging for regulatory agencies to kind of keep up with everything. On top of that, previously, I don't know if that's really changing with MOCRA, but you didn't have to register. There was like a voluntary cosmetics registration. But even with that, that's just kind of like, it's not all that stringent or strict. So a lot of products have just been able to get away with crazy active claims, even some pretty big brands that you would expect better from, in all honesty.
Oh my gosh, I just saw it was from SkinCeuticals. I just have to say it because it was so egregious.
We were just talking about SkinCeuticals.
Oh, I think I actually told it to you when we did the They compared their P-Tox serum to a needle. Like, you're comparing your product to a drug. So questionable claims all around, from big guys to small guys, although the intention may be different, because big guys may be intentionally towing the line because they have the regulatory teams and like risk cost equation that ends up making it in their favor, because consumers remember those claims even if they have a warning letter. This is how you get sponsors. Oh. The next question is from Mo, who says, first, amazing presentation. And the question, as consumers, what can we do to combat those illegal claims?
Oh, that's an interesting one. It is kind of hard, but like what you can really do is just, I mean, call out these products when you see them, especially on social media. Social media is huge. It has a really big potential to like make its way around and get visibility. So really, when you see these claims, the best thing that you can do is kind of what science communicators do already. Call them out. Say, hey, this is a drug claim. Did you know that you're making a drug claim? You might get on the nerves of like certain brands or whatever, but like the best way to do it is to call it out. Just because it can be hard to get the attention of like a federal agency really to combat those claims. So the best thing I can say to do is get in their comments, get on their social media, and just say, "Hey, this is what this says," and uh, I know that this is a drug claim. This is not FDA compliant, so that's what I would recommend.
Now, as I'm waiting for more questions, I'm going to ask a question that is actually the theme of an upcoming podcast that Lanesa is going to come on my podcast this coming season about separating hype from science. But I'm just going to ask the question here because I think it's important. What are some very hyped ingredients right now that maybe the science isn't there? What are like the top kind of, I don't know, 3, 5, however many you want to give here.
3 or 5, okay.
Or 1, however many you want to share. Okay, 2.
I can definitely give 2. Exosomes, I do not like the marketing around exosomes. I am kind of skeptical about whether they can do what they claim to do and whether they're even, stable in a formulation, and if they can be delivered through the skin. I haven't seen much scientific evidence. I see in vitro studies, and the biggest thing is like if I see an in vitro study on an active, that's cool. Usually those are like I'm not going to say that they don't have any place. They are important, especially because I actually work on the in vitro side of things. So in vitro studies are important, but like when you see an in vitro performance test, you want to also see that whatever ingredient is being tested can actually make its way to whatever cell that they're testing it on. So a lot of the times I'll see ingredients be tested with dermal fibroblasts to see if it can increase collagen production or increase elastin production. And the question is, with those ingredients, when you put that in a final formulation, can they actually even get to that point? So that I don't really like exosomes. And another one that I don't like, which I've talked about on a, a lot of these e-subs, is tranexamic acid. For me, the evidence is just not there. The body of evidence to show that it can be efficacious as a standalone ingredient, I just haven't seen that. So those are kind of the 2 banes of my existence at the moment.
Yeah, but I guess these answers are why I titled this presentation, instead of shopping beauty like a cosmetic scientist, I titled it like a good cosmetic scientist, because not every scientist, especially who has a public platform, is evaluating the evidence that they're presenting to their audience in adequate, as per like what a scientist should do, way. Sometimes they don't have the tools to critically appraise it. Maybe they've only gotten so far in their academia, and it's not that you can't critically appraise science with only a bachelor's, but like it's hard, or maybe not the relevant expertise, or maybe there's an incentive to get a ton of money by sponsoring some product. Anyways, I'll ask my next question because I think it's really interesting. This one is from Donatella, who asks, is the current political climate in the US affecting the cosmetics industry? For example, when it comes to safety and illegal claims? And I will maybe just say that I've certainly seen an uptick in certain markets people being like, I don't know, especially snake oil salesmen on social media. And like, I feel like people aren't saying anything. And yeah, what do you think?
So I will say there probably has been an uptick in this current political climate, but honestly, there has been an uptick, in my opinion, ever before COVID, but ever since COVID, I really saw that uptick because at COVID, it was a time that people were so concerned about health, right? A lot of people were thinking about, their health, like staying away from getting sick and things like that. And I think that that's more of what kind of propelled a lot of the marketing that we see today. And the political climate obviously doesn't help when you have oof maybe I shouldn't say that, but like when you have somebody who got part of their brain eaten by a worm making healthcare decisions for people, it can get a little sticky. And we are seeing a lot of misinformation. Like I recently they just said Tylenol is not safe. So it's not being helped by the current political climate, because we're at a point right now where everybody is kind of afraid of, for their safety, of the safety of their products, and they're falling victim to a lot of deceptive marketing that is meant to like play into those sensations. So I can't say the politics are helping with that at all. No.
This is a follow-up from GZM, who says, I'm sorry I was vague. I meant that if a product can claim vitamin C on the package, but uses a derivative and used in an amount that wouldn't actually do anything, isn't that deceptive? I mean, it depends on, I think that there's some nuance on this. So what's your
Yeah.
take?
So it depends on what the claims are being made on the product. So if that product was being marketed as, oh, our vitamin C is so brightening, then that is a little bit more deceptive. Just claiming that something just has vitamin C, I mean, technically eh, they're not exactly lying. Has a vitamin C derivative, but I mean, it's not exactly a lie. Where it would be lying is if it was like, oh, this brightening product uses vitamin C at a concentration that has been shown to, you know, target dark spots, like, or reduce the appearance of dark spots. So like that's where you kind of get a little bit more into uh deceptive, but they weren't exactly lying, if that makes sense. Like it has a vitamin C derivative. They're it's kind of like retinol versus retinol. You could say you have a retinoid in it. So it's a little bit deceptive, but like if a product says it has something, it just has to have it. So it's not deceptive to say it has it.
This next question is from Neural, who asks, any tips on detecting or spotting claims that actually mean nothing?
Um, Honestly, you really just have to look at how the claim was validated. And like a lot of the claims, if they sound too good to be true, they usually are. I would say that you just have to be kind of careful. So like I know a really big one is the doctor recommended, or a doctor, number one recommended doctor type claims. It really, if you just see some of those claims and they can't point to how it was substantiated, that is typically how you can spot kind of like a one of those types of claims. Or if you even look up like what the validation criteria, it might require a little bit more research, but if you look up a claim, you see a claim, it's like, oh, that's an interesting claim. You should always ask yourself, like, okay, how did they validate that claim? So if you say like a doctor recommended product, a lot of people think that, you know, it was tested by a panel of dermatologists, and sometimes like the doctor that in question doesn't even have to be a dermatologist. It can be any type of doctor. All it has, it just says doctor. And there can be financial incentives. So if you kind of like look up the claim and like how the claim is validated, and you can't get a solid explanation for how something was validated, that's usually a good indication that it's a deceptive claim.
Ruby made a really good point that I just wanted to highlight. I noticed some big brands are writing like vitamin C CG instead. So I guess they do think it's at least risky for them to call it vitamin C. And I think that this is a really good point about like risk exposure for some of these claims, because like a big guy has all of the class action lawyers to worry about who are going to see this whatever claim, and they can file a class action lawsuit and sue them. Or even just saying that is problematic for a brand. Class action lawsuit against, I mean, everyone can think about the talc case and the perception impact that has had on the general public. Smaller guys are less like they don't have as much money to pay, so maybe less of a target. This reminds me though of the probiotic conversation, and, and so like brands are labeling things as probiotic until who was it? Was it Olay that got sued?
I believe it was.
Oh, sorry, I may have not.
Clinique.
Clinique. Oh, I'm sorry, Olay, that I said it was you.
I believe it was Clinique.
Oh yeah.
Because yeah, they were claiming that they had probiotics, but what they really had was either a prebiotic or a postbiotic. But yeah, that was certainly one of those cases where it was, but that was completely wrong, because a postbiotic and a prebiotic is literally like, it's not even a derivative of a probiotic. Like a derivative, maybe you can get away, but I would still say like, oh, it has this derivative of vitamin C. Like I would say that it is a vitamin C derivative. But like, yeah, you do get into a very interesting space with kind of like the derivatives and everything, and whether they can be called the active or whether they need to be you know, clearly stated that it's like a derivative of the active.
And that's all the time that we have for our Q&A. Always too short. Definitely watch Lanesa's previous presentations. But Lanesa, thank you so much for constantly coming back and giving on-point presentations.
Again, I love doing these. So it's always an honor to be able to share my knowledge. So I appreciate it.
Awesome. Thank you, and enjoy the rest of your Sunday.
All right. Bye, Jen. Bye, everybody.
Our next presentation will be on the Clean Beauty Conspiracy Pipeline, an investigative journalism case example. Presented by Janna Mandell, who is senior editor at Beauty Matter and a longtime reporter covering the beauty and wellness industries. She has contributed to the New York Times and Washington Post and is recognized as an early trend spotter, having reported on K-beauty and natural beauty long before they became mainstream. She has interviewed leaders ranging from CEOs and dermatologists to influencers and academics, offering unique insights into the evolution of beauty and wellness. Without further ado, here's her presentation.
Hello, everyone. I'm Janna Mandell, senior editor at Beauty Matter, and I've been covering the clean beauty movement since 2021, looking at its dark ties to conspiracy theories for the Washington Post, the New York Times, and now for Beauty Matter. For those of you who are not familiar with Beauty Matter, we are a B2B publication for the beauty, wellness, and personal care industries. Beauty Matter takes risks. We tell stories that none of our competitors will touch, and we always dig deep, which is why I wanted to work here. Now, before we dig in, I would like to present a montage of misinformation. I want us to look at where we are now, how we got here, and the role clean beauty may have played in our current situation. We are caught in a full-on assault of misinformation, largely driven by chemophobia and those looking to profit off that fear. Jessica Alba, Gwyneth Paltrow, Michelle Pfeiffer, Dr. Barbara Sturm. These are names that usually are not grouped together with the likes of extremist far-right QAnon social media accounts, MAGA influencers, MAHA influencers, and clean beauty founders and influencers who preach new Germanic medicine known to be rooted in anti-Semitic conspiracy theories. But here we are. Everyone pushes the same message, that our beauty products will give us cancer, that we cannot trust the FDA, we cannot trust Big Pharma, we cannot trust our government. And just by tuning into this summit means you understand our dire situation. Science is under attack, and conspiracy theories that used to be thought of as fringe are so mainstream now, they've infiltrated the US government. We have doctors, dermatologists, chiropractors, cosplaying doctors and dermatologists, all posing as experts to drum up fear for clicks. Every scare study that comes out, regardless of its sample size, regardless if it was there was a conflict of interest with one of the authors, regardless if the paper was widely criticized by the scientific community, most media outlets won't do their homework. and they'll run these terrifying headlines to make readers think they're going to get cancer from their beauty products. The anti-sunscreen movement seems to bring out the most pernicious of bad actors. Where far right intersects with the far left, fear drives these people to come up with the most outlandish conspiracy theories, like that the FDA is putting cancer in our sunscreen to poison us, or that sunscreen is a Jewish trick. We also can't ignore that words like clean and pure are deeply rooted in eugenics. It's no accident that many clean beauty founders and supporters are often white women. The trad wife trend, which leans into do-it-yourself natural beauty, this community also supports clean beauty. And Ballerina Farm, who has more than 10 million followers on TikTok, gives lots of tutorials supporting clean beauty brands. Just calling a product clean or pure inherently invokes white supremacy. Clean brands like Primally Pure, Clean and Pure, 100% Pure, all goes back to the idea that clean and pure means white. These types of products that were traditionally sold at farmers markets, these companies are now buying billboards and spreading their pure gospel. We are at a point where consumer fear dictates what cosmetic chemists are allowed to use when formulating beauty products. These chemists shake their heads when a brand asks them to make something paraben-free, because they know that whatever preservative they are forced to use in its place will not be as vigorously studied as parabens and could cause an allergic reaction or worse. But here we are. When we look at the pillars of clean beauty, we have to start with the words themselves, clean versus dirty. If you say your brand is clean, does that mean that you think other brands that are not deemed clean are in fact dirty? Isn't that why the platform Think Dirty is named that? Even though there is no true definition of clean beauty, it doesn't stop brands from claiming purity, looking for that clean stamp of approval from a retailer, or paying thousands of dollars for that clean stamp of approval when we're talking about the EWG or Made Safe. Science-ploitation manipulation. Whether we're talking about the Environmental Working Group, the EWG, Beauty Counter, or any clean beauty brand, if you dig deep into their science and check the sources they quote, you'll see that the science has been cherry-picked to help drive the clean narrative, and they always leave gaping holes of missing context. For example, the story I wrote for the Washington Post in 2022 about the absurdity of paraben-free products, I interviewed the EWG to directly ask them why on their skin deep pages for parabens, they cited old studies and left out a lot of important context. There were a lot of very long pauses when they had me on mute, and most of their responses were them deflecting. There was the longest pause after when I asked them why they cited studies as definitive evidence of concern, when said studies said results were inconclusive or more data was needed. I gave them many examples of this, cherry-picking science to drum up fear, which again, surprise, surprise, they gave me non-answers for. Timothy Caulfield is a professor in the Faculty of Law in the School of Public Health and research director of the Health Law Institute at the University of Alberta, and a best-selling author. He is also recognized as a leading global expert on science and health misinformation. I've worked with Tim for years, and he is by far my most favorite and valuable source, especially when it comes to misinformation. In his book, The Certainty Illusion, Tim explores how we are bombarded with a constant stream of misinformation, making people more vulnerable to being exploited with sciencey language, hence science-ploitation. Self-congratulatory side note, I am quoted in this book on page 132. So I interviewed Tim for my most recent story on sunscreen misinformation for Beauty Matter. I wanted to share one of his quotes on the clean beauty narrative because it's so powerful and really speaks to what we're talking about today. Tim said, "When we're talking about the clean beauty industry, fear-mongering has become a very effective marketing strategy, especially when it's aimed towards a common goal. There are a couple things happening here, and all of these things have accelerated post-pandemic. One is this erosion of trust. You can't trust the regulators, they're evil, but you can trust us." It plays into their marketing strategy. The other thing that's happening is what's called the Mott and Bailey fallacy, which plays into the clean beauty narrative. Clean brands make a broad claim that everyone can agree with, like, we all want safe products. Then the clean brand shares its research and products. Then, if you challenge what the brand says because there is no evidence backing up their messaging, the clean beauty brand will retreat to the conclusion that if you disagree with them or critique them, then you are the enemy. It's a very effective strategy because it's distracting. It makes the person critiquing the pseudoscience pro-toxin. Thank you, Tim. The premise of clean beauty has always been rooted in mistrust. We've spoken about this. Mistrust of chemicals, mistrust of the FDA, mistrust of big pharma. And when you think about it, it makes perfect sense that the clean beauty world would devolve into dangerous conspiracy theories. The whole idea of clean beauty is built on chemophobia, a fear of chemicals and mistrust. Whether we're talking about clean beauty founders spreading anti-vaccine misinformation, which we will get to on the next slide, it was all about a distrust of government. The idea that the government means to harm us through vaccines. Clean beauty is built on blaming the FDA for not doing its job to keep toxins out of our beauty products. And the big pharmaceutical companies are either purposely putting toxins in our products so they can sell us the solution, or that big pharma cares more about cutting corners than saving money. COVID, the natural progression from clean to anti-vax. The pandemic amplified distrust in the clean beauty movement. My research on the clean beauty conspiracy connection really began in late 2020 when I was working on a story for the Washington Post on how clean beauty founders were spreading misinformation about that vaccine. While clean beauty began with warnings about toxins in beauty products, the rhetoric became a lot more dangerous and serious when these clean beauty founders started preaching about the danger of the COVID vaccine. As many of you know, the Plandemic was a pseudo-documentary that was quickly debunked, yet it spread like wildfire on social media. It basically perpetuated the idea that a cabal of elites orchestrated COVID for profit.
If we activate mandatory vaccines globally, I imagine these people stand to make hundreds of billions of dollars that own the vaccines.
And they'll kill millions.
Many clean beauty founders gave the Plandemic a platform by posting it on their social accounts. One woman, who is the only clean beauty founder willing to speak with me on Zoom face-to-face, believed that she just couldn't believe that I thought she was a conspiracy theorist. She believed that COVID was manufactured, that it was all a ruse so they could profit and gain full control of the people. I asked her who are these people that are trying to control us? She didn't hesitate. She looked into the camera and said a cabal of white men are trying to take over the world. When I asked her who she thought these men were, she said bad men and ended our call. This same founder drew a parallel between mask mandates in ancient times, when Arabs discovered that covering one's nose and mouth broke their will and individuality. She also inferred that COVID was a takeover by the elite and that big pharma owns the media. Hidden amongst the flowers. Many clean beauty founders hid their anti-vax rhetoric in beautiful, innocuous images. When social media platforms like Instagram and Facebook started heavily enforcing banning anti-vaccine misinformation, clean beauty founders had to get creative, and they often posted what looked like a typical clean beauty skincare photo, like the one you see here. Maybe it's a founder walking through a field of flowers or smelling flowers or dipping her foot in a creek. But when you dig deep into the caption, you would find dangerous anti-vax rhetoric like, we are so removed from the natural state of things that we think that injecting a live virus mixed with aluminum and fetus tissue would be better than elderberry, zinc, vitamin C, vitamin D, and more. Clean beauty founders cosplaying doctors, with affiliate links, of course. During the pandemic, I noticed many of these founders were doling out medical advice. From NAD suppositories to sunlight, these founders shared what they believed was either an alternative for the vaccine or treatment for COVID, profiting off their cloud of false hope for followers. And of course, all of these medical recommendations were tied to affiliate links. COVID, when sunshine and roses become pernicious rhetoric. When denial devolves into aggression. When I tried to talk to some of these clean beauty founders about their pretty posts masquerading as misinformation vehicles, I was met mostly with denial. When I asked the founder in this photo, let's call her S, about the anti-vax rhetoric in her posts, she deflected and seemed genuinely surprised that I would classify her as a conspiracy believer. I followed up with her when she posted this in her stories, praising an article that blamed Bill Gates for starting the pandemic. The authors are Vandana Shiva, an anti-GMO activist who perpetuates conspiracies, Such is the claim that Bill Gates is trying to buy up all the seed banks in the world so he can control the world's food supply. The story was co-authored by RFK Jr., who needs no introduction. When I questioned S about this, her denial turned to anger. And of course, she expressed her anger by creating a beautiful post entitled Ice Storm with an image of a frozen flower. Apparently, I am the ice storm in this metaphor. She sent me this post and then she blocked me. Blatant hate and QAnon-esque conspiracies. There is one founder that is the most polarizing in the industry. Let's call her J. On her Instagram grid, commingled with glammed out selfies and staged product photos, you will find her blaming the Democrats from everything from starting the California fires to running a pedophilia ring to supporting Kanye West and his beliefs. She infamously bragged in her Instagram stories about being at the January 6th insurrection, posting anti-gay sentiments, and of course, pushed an anti-vaccine agenda during the pandemic. When I reached out to Jay for an interview, she said she would only text. Once I gave her my number, she bombarded me with 47 texts within 8 minutes. In these texts, she mirrored other clean beauty founders, suggesting a regimen of supplements and organic foods as a natural COVID vaccine. My question to her was, even if her expensive regimen worked, it would only protect the small percentage of people around the world that can support it. And of course, she deflected rather than answering. Staring at the sun, from clean to benzene free. Since 2021, I've covered the lab Valisure for the Washington Post and the New York Times. This lab is infamous for announcing it has found benzene in popular consumer products, like when it announced it had found that best-selling sunscreens contained dangerous levels of benzene the Friday before Memorial Day weekend. Valisure is known for purposely drumming up fear in the headlines. Valisure is widely criticized for its problematic science and ethics. Valisure amplified mistrust of the government and the clean beauty community. Valishure's attempt to discredit the FDA supported the clean beauty narrative that you just can't trust the FDA to keep you safe. Clean brands jumped on the benzene bandwagon. Bass, Kula, Jackson, even though Valisure science had been discredited many times over by the scientific and dermatological communities, clean brands wore benzene-free like a badge of honor, another chemical for their never list. Clean Beauty's mascot, the EWG, spread fear so users would buy EWG-verified sunscreen through its site that, of course, was benzene-free. When anti-sunscreen sentiments become something sinister. Earlier this year, when I worked on a story for Beauty Matter on anti-sunscreen conspiracy theories, I revisited the dark side by researching on extremist social media platforms like Truth Social, 4chan, Rumble, Gab, Getter, to see where the far right and the clean beauty and wellness industries intersected on the anti-sunscreen movement. I knew to expect cherry-pick science, fear-mongering from the usual suspects, Maha, wellness influencers, and QAnon supporters. What I wasn't expecting was to find an anti-sunscreen anti-Semitism connection. 4chan users were giving out anti-Semitic red pills like candy. One common anti-sunscreen conspiracy on 4chan is that sunscreen is a Jewish lie or a Jewish trick. I spoke with researcher Beth Davies, who wrote Sunscreen Skepticism, an examination of sunscreen and sun exposure conspiracy theories, while working at the Center of Terrorism, Extremism, and Counterterrorism at the Middlebury Institute of International Studies at Monterey. In her paper, Davies cited that some wellness influencers follow Germanic New Medicine, which is rooted in anti-Semitism. Riek Gerd Hamer, which I'm sure I'm not pronouncing correctly, proposed Germanic New Medicine as an alternative to mainstream clinical medicine, which he viewed as part of a Jewish conspiracy to eliminate non-Jews, Davies wrote. Some sunscreen truthers believe sunscreen is one of the many tools that a vindictive Jewish medical industry uses to undermine whiteness. Anti-Semitic anti-sunscreen conspiracy theories can also be found on incel sites like lookmax.org, a community board for men looking to improve their appearance because they are involuntarily celibate. The platform averages around 3 million monthly views. And if you've seen the Netflix series Adolescence, the main character is radicalized by incel ideology. This site is a magnet for angry incels spewing Jewish hate-filled anti-sunscreen rhetoric. One user said sunscreen is a Jewish lie to get you to run through more product, while another said that rubbing Jewish chemicals like sunscreen on your skin will only make it worse. There are so many of these posts, I can't go through them all, but here are a few more. The Dr. Sturm to QAnon pipeline. I found something else I wasn't expecting in my research, though I probably should have. Buried in an X thread posted by Matrix Mysteries, an Illuminati believer spreading far-right QAnon-esque conspiracies like Pizzagate, New World Order, and Big Pharma, I found the sunscreen conspiracy, sunlight causes cancer, a fear-driven lie. This conspiracy theory is obviously a common one, particularly with the Big Pharma QAnon crowds. But what made this post unique was seeing a smiling Dr. Barbara Sturm, the founder of her namesake luxury clean skincare brand, with the words "sunscreen caused this" among the propaganda. Dr. Sturm is not your average clean beauty founder. While most clean beauty brands lean heavily on nature and holistic branding, Dr. Sturm's brand is sterile white and meant to evoke science lab. Her molecular science serums and moisturizers, and I put that in air quotes because she does not have any training as a molecular scientist, her products range from $200 to $400. Though the German former orthopedics doctor has not received any aesthetic training or licensing in the US for cosmetic procedures, she openly discusses injecting patients with hyaluronic acid and Botox. She also flaunts her celebrity clients as much as her clean lifestyle. Her clean lifestyle may have inspired her to appear on bro biohacker Jerry Brecka's podcast. For context, Brecka is a self-proclaimed human biologist, biohacker, and longevity expert. Please note he is not a licensed medical doctor, nor is he a PhD. His devoted followers are mostly Mahon biohackers, and he tends to leave a trail of medical misinformation in his wake. When Brecka recently appeared on the Joe Rogan show, after praising Bobby Kennedy and his Maha movement, Brecka demonized seed oils and described the FDA's GRAS designation as a way the FDA can decipher whether a company has permission to micropoison the population.
And so I think what you're going to see is these GRAS guidelines, generally regarded as safe, which is essentially how the FDA decides whether or not you can micropoison the population.
This wasn't a question of whether Dr. Sturm was blind to Dr. Brecka's conspiracy theory gospel before she appeared on his podcast. The two collaborated in 2023 on Dr. Sturm's virtual skin school. But even knowing Brecka's stance on big pharma and seed oils, it's unclear whether Dr. Sturm would approve of being used as a poster girl for far-right QAnon propaganda. This post originated on X and has been viewed over 1.4 million times, reposted on X by MAGA supporters like this guy, who's the treasurer of the MAGA Coalition Super PAC, and this one, this MAGA supporter trying to make MSGA a thing, make sunscreen great again. And then this QAnon supporter who also recommends not wearing sunglasses. As expected, Dr. Sturm's smiling face was also reposted to extremist platforms like Truth Social and Gap. In conclusion, we are obviously in an epidemic of dangerous misinformation, incredibly dangerous because it's become so mainstream. The clean beauty industry needs to take a good hard look at their messaging, who they align themselves with, and ask themselves, is there a chance that through the support, they're helping to amplify these conspiracy theories?
And bear with me as I bring Janna over to the big screen. There you are. And here we are for the presentation. So the first question came in from Neural, and excellent presentation. Thank you so much for putting so much time and thought into this. And I think this presentation really highlights the interdisciplinary nature of sci-comm online as a journalist, how journalists can be a part of it with just fantastic, some of the best investigative journalism I've seen in a really long time with your conspiracy pipeline post about sunscreen on Beauty Matter. Really, really good. So this question came from Neural, who asks, should we not trust clean claims at all? Are they even valid for consumers to make assumptions that they're better and safer choices? Maybe I'll quickly say from a scientific point of view, I would say no, but what's your point of view?
I think that I've always felt like clean brands should sell more on what's in their product rather than what's not in their product, right? So it doesn't mean that every clean brand, the product itself doesn't work, right? So there's a chance that it works. It's just using bad marketing by telling you what's not in it. You know, as everybody knows, the dose makes the poison. And if there's anything I've studied, it has been benzene. I've spoken to many toxicologists about it, and there's been so much fear about it. And a top toxicologist told me, he's like, Janna, there's a reason why all the studies are done in China, where people are working in a factory for 8 hours a day, 5 days a week. That's how you are putting on sunscreen for the rest of your life is not going to do anything. They've had, benzene is ubiquitous, let's say. So I don't trust the claims. And I just wish that a lot of these brands wouldn't sell themselves as clean, because there are a lot of beautiful products out there. Talk about what's in them, not what's not.
Yeah. This next question, I guess the products may be fine, but the marketing is very damaging in terms of the net spread of misinformation. And so I have a really hard time supporting any product that uses these kinds of verbiage.
Well, hold on, with the caveat that you have to limit the shelf time. That you have to keep in mind that a lot of these products are not using the preservatives that are going to keep it on your shelf for long. But I do see where you're coming from. And I agree that the marketing itself does need to change, because it means absolutely nothing.
This next question is not so much, well, it's kind of a question. I'm going to ask it anyways, just in case you want to add anything to this, because I think that you really highlighted the end game or end outcomes for some of this marketing. So this is from Michelle Niedziela. Oh, I guess it is a question now that I'm looking at it a bit more. A question that maybe you can add more to what you haven't said. Okay, the question. Okay. I always wonder, what is the end game of pushing these conspiracies? It's kind of, I am interested in how you're going to answer this question. So that's the question. What's the end game here?
It depends on who's spreading the conspiracy, right? So if we're talking about clean beauty in general, it's for money. Fear drives traffic, fear drives clicks, and fear drives money, right? People are scared, so they're going to buy a product that they give them this false sense of safety. That is their end game. What they don't realize are the ramifications of that marketing, right? Which is what you saw today in my presentation, that just being a clean beauty founder and talking about your no lists could end up being supported by QAnon propaganda, right? Now, when we're talking about the anti-vaxxers, I think that those women really believe it. I think that they're not doing it necessarily for money, but I kind of put them in that whole QAnon community where they actually believe it, which is different than a clean beauty brand founder who's telling you that your beauty products are going to kill you. That's for money, right? They want you to keep buying it so that you feel safe. It's a blanket of safety, false safety.
So something that I have observed, we've all observed, and you've highlighted this in your presentation, that there are some gaping issues with expert vetting with the media for many platforms, where you see all these people get platformed and they're really not the right experts. And so then the wrong messages about, for example, the Valisura outcomes for benzene get promoted. As an example, there was a presentation at the American Academy of Dermatology recent conference from somebody from Valisura to then talk to dermatologists about the negative impacts of benzene in different products, whether it's from benzoyl peroxide products or sunscreens. These were the focus of that presentation, to my understanding. And then after that, there were a whole bunch of dermfluencers who were going online to talk about the dangers of benzene. And then media started to quote them to talk about the health outcomes of these products. And not only that, I had heard through the grapevine that there were dermatologists in their practices that were talking about the risks of benzene and sunscreen and benzoyl peroxide products to their patients, like some systemic issues here. So how do you view this ability to expert vet from journalists in our current media landscape of like fast and free. It's really hard, especially, everyone has timelines and everyone wants quick attention. And what suggestions would you give for journalists who may be watching in navigating this and doing a better job with their expert vetting?
So if I were to see that presentation, my first thing would be cross-reference who this dermatologist is and if there's a conflict of interest. And Valisure is very good at manipulation. And in terms of the dermatological community, dermatologists want their patients to be safe, and they are not toxicologists. So they do not have that specialty. So if you get a dermatologist saying there's no safe level of benzene, and one of Valishure's spokesperson, Dr. Chris Borgert, who I've interviewed before, he does not work for Valisure, but he certainly represents them. And he's quoted everywhere in the media saying there is no safe level of benzene. So, but I've asked him, I'm like, do you have a toxicology background? Like, how are you to say that when I've talked to the two top ones in the world who are telling me that's not true? And it's very hard because when we talk about something like Valisure, most people don't understand the science. All they hear is the fear, right? So if you look at the headlines, you'll see all the scare headlines. What you don't see is when they got debunked. You don't see that. You don't see it when in the headlines, they're quoting a paper that's considered a zombie paper. It's already been redacted and they're still quoting it. Like my paraben story, like the woman, the scientists who originally said that parabens will give you breast cancer, she said, not only do I no longer believe that, but I worry about formulators using a different preservative that we haven't studied yet. So what I tell my writers at Beauty Matter is you've got to check your work. You've got to check where's the money, right? So conflicts of interest can be everywhere. And in terms of the dermatologist too, I question mine all the time. Like, you have to do your homework, and it doesn't matter what the deadline is. Don't be lazy. It's a lot of laziness.
With your
I don't know if that answered your question.
It did. It's something to think about. It's a really challenging topic, and people who are watching will find more perspectives throughout the day in our next presentation from Dr. Niedziela. I have a presentation, and then also Dr. Michelle Wong and Jess Stokes-Parish, Dr. Jess Stokes-Parish. You'll hear their takes on that, so it's useful to have your perspective as a journalist. And on the topic of your sunscreen conspiracy pipeline article, really great investigative journalism that Beauty Matter published. Why was this not taken up? Because I think you presented this to your previous publishers and it wasn't published. So like, why are things like that not published in other media, important topics not published in other media platforms? What's preventing the truth from being published? Why is misinformation, seemingly from what I observe online, it's dominating what's being published right now in most media platforms? Like, from a journalist point of view, what's your answer to that?
I think that negativity gets clicks and fear gets clicks. And just to be honest, lawyers cost money, right? And some of these topics that I've wanted to talk about, especially with Valisure, they're just risky. And a lot of these national publications didn't want to take that risk. And they also didn't want to lose their readers that might love clean beauty and lead a clean lifestyle. And they were afraid they would alienate them, even though they knew it was the truth. And they saw the documentation. And there's going to be another story that I'm going to come out with Beauty Matter that was also not included in the New York Times that we will definitely have a lawyer look at, but I've got the receipts. So it's like a teaser for what's to come. I've got the receipts, and I just think there's a lot of fear around publishing something that might piss off too many people.
You guys have a little bit more time for questions. You've got a lot of compliments in the chat. Many people are saying like, oh, best presentation of the day so far. So yeah, really great presentation. All the presentations were really good today too. I will say that. It's been a phenomenal lineup. So thank you to Janna and everyone else who has presented today. So along the lines of expert vetting, so I think a big challenge, and you have alluded to some of this in your answers so far and in your presentation, is understanding relevant subject matter expertise. A lot of people don't know that there are all these different experts behind all these different topics that touch even just a single industry. It's not just one true expert, as many people believe. Do you have any tips for understanding subject matter expertise for topics? Because I think that's kind of like step one for understanding who's going to be the credible expert, from my point of view, at least, on a certain topic. And it sounds like you also share that point of view.
So it's whether I'm like pitched an expert or I read an article, the first thing I'm going to do is look at what they've written, right? So I'll go to Google Scholar, I'll go to PubMed, I'll see not only which papers they've written, how often they've been cited, who cited them. And I really dig in to make sure, like to your point, that they're like, for me with my benzene, I didn't want just any toxicologist. I wanted the toxicologist, the one who had written papers that everybody quoted about benzene exposure. So it's lazy if you don't take those steps as a journalist and you don't ask questions. And it's lazy if you just grab the sources that you've seen and, quoted in other publications and just use them, because that's how Dr. Bunick, the no safe level of benzene, that's why you saw that everywhere. And he obviously does not have a toxicologist background. So why is he being quoted saying that? So when that's why I wouldn't quote him saying that, because he's not an expert in that field. So there's a lot of ways you can look. I think that some, will wear their little white lab coats and you'll look up their CV to find out they're chiropractors and they're pretending to be dermatologists, right? So, I mean, there's a lot of, you just have to do your research. I like to follow the money. And as I tell our writers at Beauty Matter, like, you have to cross-reference and make sure there is no conflict of interest. I don't know if that answered your question.
It did. And I'll maybe conclude this with a props to Beauty Matter for giving journalists at the media platform the space to do their due diligence, because I know that space is not given by every media platform who, like, I think a lot of journalists are kind of in a hamster wheel scenario and they have to publish like five is a lot, but sometimes like 10 articles a week. Like, how can you possibly do your due diligence? And then there's all these other layers, but like, how can you do your due diligence, especially if you're trying to get clicks? And sometimes what's click worthy isn't actually accurate. So I really appreciate the space that Beauty Matter gives to the journalists. And I really appreciate your work, Janna, for your investigative journalism. You've done really great work. So congratulations. And thank you so much for this phenomenal presentation.
Thank you, everybody.
Have a great rest of your Sunday.
You too.
Our next presentation will be on the market misinformation feedback, a behavioral science point of view, featuring behavioral neuroscientist Dr. Michelle Niedziela, who is also founder of Neuroscientists, working at the intersection of neuroscience, consumer behavior, and market research. With experience in academia at the Manel Chemical Census Center, in industry roles at Johnson & Johnson, Mars Chocolate, and HCD Research, she brings cognitive science into applied consumer studies. Michelle helps organizations integrate neuroscience and behavioral tools into product design, research, and innovative strategies. Without further ado, here's Michelle.
Hi, my name is Michelle Niedziela, And I come from the world of sensory neuroscience, which is studying how people perceive taste, smell, and the world around them. So I'm not actually from the cosmetics or beauty space, but I have done a lot of work in it. I got my PhD in behavioral neuroscience, and now I specialize in applying neuroscience and psychology to understand consumer behavior, whether it is in the cosmetics area or the healthcare area or consumer products of any sort, like food and beverage and anything really. And I'm helping clients navigate this fairly complicated space of applying neuroscience and psychology to understand consumer behavior and human behavior. I focus on using science responsibly to uncover what drives decisions and help companies make evidence-based choices, a sort of research doula, if you will, where I educate and I advocate and I help my clients get actionable insights from their research. So today I'm going to talk about market misinformation in terms of a feedback loop, which is really a behavioral science point of view. Now, when I give talks about consumer behavior, I do like to start by talking about just us as humans, because we live in this very complex world where we have to make decisions constantly, whether it's what to eat or what to say or how to dress. My interest has always been about what drives these types of choices. Like, why did you wear that shirt today? Or why did you buy the car that you drive? What's making you crave a specific lunch or a snack? And our decisions, as we understand them, stem from a mix of factors. Could be internal states like hunger, or emotional states like or emotional drivers like loyalty or just habit, and external factors like cost and availability. And our understanding of this mix comes from behavioral science research, which is really a mix of psychology, decision sciences, and behavioral economics, as well as neuroscience and consumer science. Now, understanding human behavior is crucial, maybe most particularly in sensory and consumer research, because it allows us to grasp not just what people like, but why they like it, which is certainly very important for marketing as well as product development. This deeper understanding can drive more effective marketing strategies and more successful product designs. So, as a primer to baseline all of us together on what's called systematic thinking, I like to talk about how we experience the world in really two ways: as it really is, as we perceive it. And our perception is very subjective. It can be shaped like factors like our physiology, like, for example, I wear glasses. It could be your personal history or how familiar you are with something. It could be an emotional state, like how stressed are you today? And all of that can actually color the reality that you're experiencing. Now, when we make decisions, we can often seem to be of two minds. On one side is our impulsive Homer, which is really driven by instinct. And on the other side is our more logical Spock, who plans very carefully. Now, this idea is also known as dual process theory, and it's not new. Philosophers used similar things like Chariot's allegory, or Freud talking about the id, ego, and superego, and behavioral economists like Kahneman popularized it with System 1 and System 2 thinking. Psychology's dual process theory explains that we think both automatically, like Homer, and also rationally, like Spock. And we tend to blend these processes together. So, for example, buying a car isn't just Homer impulsively wanting a flashy Lamborghini or Spock logically choosing a budget-friendly Honda Civic. We actually integrate both impulses and reasoning, which is why Civics outnumber Lamborghinis on the road. The Homer approach, or System 1, is fast. It makes assumptions. It makes mistakes. The Spock approach, on the other hand, or sometimes called System 2, is slower. It weighs the facts. It takes more effort. And according to Kahneman, we actually vacillate between the two, depending on the situation. Now, interestingly, since we're talking about misinformation, in my field, in the early 2010s, neuromarketing emerged. And this was this idea where academic research on how the brain worked was cherry-picked and then sold to clients to say that you could understand consumer behavior due to this finding from a neuroscience lab in academia. but it was a huge leap. The original studies were done in highly controlled lab settings, leading to exaggerated claims about how the mind worked and that we could do mind reading, and that we should distrust explicit research, which is asking questions with things like surveys. Now, as a result, many neuromarketing claims became later disproven because they were just simply overreaching. And the industry found much of the work really disappointing because they had really exaggerated what they could do. Now, the desire to find easy ways to read consumers' minds persisted. Neuromarketers then started to lean more into Kahneman's theories of System 1 and System 2 thinking, claiming incorrectly that 90 or sometimes 95% of decisions are all non-conscious. So why would you bother asking people questions if all these decisions are being made non-consciously? Now, ironically, this actually misinterprets Kahneman's work in Thinking Fast and Slow, because there's no actual way to definitively measure whether a process is implicit or explicit, conscious or non-conscious. And the number didn't even come from Kahneman. It's actually from sociologist Gerald Zaltman, who described it without any supporting study. Yet, many neuromarketing companies do still cite this misleading statistic to sell their tools, which you can see here. And you can see here. And if you visit many neuromarketing type business web pages, even today, you will find this number prominently displayed as you should use their tools, their magic gadget to read minds. Check it out if you're interested in where he talks about this, Zaltman, that is. It's in his book, How Customers Think. And it's not in Thinking Fast and Slow. But the main point here is that our decisions and our motivations are actually influenced by all sorts of different factors. So why is this idea of a blatant lie so appealing to us, even to scientists? Well, first, there are the numbers suggesting that there's a real study. Unfortunately, there is not a study. And this company that had this ad actually says there is a study, but it's not even possible to measure whether something is conscious or non-conscious. So you could never even do this study if you really wanted to. But also, it fits with schema that we already have. So ideas like trust your gut or that we only use 10% of our brain, these sort of communications really fit with these preconceived ideas that we have. Now, unfortunately, this led to a whole narrative that you couldn't trust what people say. So if you were doing consumer research, you had to worry that consumers lie in surveys. And of course, the only solution was to buy into a suite of expensive mind reading tools. Now, I'm a neuroscientist, and I'm here to tell you that there are no tools that can read minds. Our brains are simply too complicated for it to be that straightforward. But that's a conversation for another day, and feel free to reach out to me if you'd like to know more about that. The main point here is that our decisions and our motivations are influenced by all sorts of factors. For example, how is this woman feeling? Feel free to type it in the chat or yell it out in your home or whatever suits you. But as soon as you see this photograph of this woman, you have a pretty good idea of what she's feeling. You can look at her and tell that it's negative, that maybe she's sad or stressed. You don't actually have to think about it too much or spend time trying to analyze her facial expressions for clues. You just know. This is System 1 thinking, or as Kahneman said, right? It's automatic, it's intuitive, and it requires no effort. You don't have to spend any time carefully thinking over, you just know. Now, quickly, how much is 11 times 4 or 17 times 14? By contrast, you may not know the answer right away, but you probably know how to solve it. And you could work out an answer, but that would probably require time and effort. First, you'd have to remember the rules of multiplication and go through each step involved. You might work out 17 times 10, then 17 times 4, and then add the two answers. Doing so, however, requires manipulating the numbers in your head, taking up your working memory, and sapping your concentration. Kahneman calls this slower, conscious, and rational style of thinking System 2 thinking. So System 2 thinking is deliberate and effortful, and it requires mental work and concentration. In fact, when you're engaged in System 2 thinking, your body actually also gets involved. Your muscles tense up, and your blood pressure rises, and your pupils dilate, meaning they get bigger. The reality is, our brains are wired for shortcuts. We don't fact check every headline or product claim because that's a lot of work. Instead, we use heuristics. If something feels familiar or simple, emotional, or comes from someone we trust, we're actually more likely to believe it. These shortcuts usually help us make fast decisions in daily life, but in the context of misinformation, they can trick us into adopting and sharing myths. So when we are approached with any given decision, we often rely on these things, these little shortcuts. So for example, the availability heuristic. This is that we judge something as more likely or true if examples are easily coming to our mind. So for example, if we've heard about toxic parabens in 3 headlines and 1 influencer video, we assume that parabens must be dangerous, even if the science says otherwise. Affect heuristic. This is where we let our feelings like fear, disgust, hope guide our judgments more than the facts. So a label like chemical free feels safer, even though everything, including water, is a chemical. Fear cues win over rational nuance. Confirmation bias. This is where we actually seek out and favor information that supports beliefs that we already have. So if we already think, for example, that natural is somehow better, we'll notice and share content that confirms that feeling. And then we'll start to ignore evidence to the contrary. Authority bias. This is where we're more likely to believe information if it comes from someone who just looks like an expert. Like a brain scan image in an ad, or maybe with a person with a white lab coat, or maybe seeing the phrase clinically proven. All of that can make a more weak claim feel more credible. Bandwagon effect or social proof. This is where we assume something is true or worthwhile if lots of other people believe or do that thing. So, for example, if we see thousands of reviews on a product, or lots of likes, or influencers repeating a myth, like blue light protection skincare, that makes it feel more validated. Another interesting one is negativity bias. And this is where we actually will pay more attention to potential threats than we will to neutral or positive information. So seeing something that says something like this chemical is dangerous grabs our attention more than seeing this chemical is safe within regulatory limits. That's not nearly as exciting. There's also the illusory truth effect, and this is where repetition makes information feel more true, regardless of the accuracy. So hearing parabens are toxic over and over and over in ads and in blogs and in conversations makes it feel like fact, even if debunked. So when we talk about misinformation, we often picture it flowing in one direction. A false claim gets made, people believe it, and that creates the myth. But in reality, misinformation works more like a loop. And it's a loop that may begin small and just get stronger because it's not static, it's self-reinforcing. So here's how it works. First, a claim or myth spreads. It could be something emotionally sticky, like chemicals are dangerous, or your skin needs detoxing. These ideas are easy to grasp, but they're also easy to share, and they feel true, even when the science doesn't necessarily support them. So next, a consumer then picks up that claim and they repeat it and they share it on social media and they ask their friends about it. And the idea becomes part of everyday conversation and part of consumer demand. The industry then has to respond. If enough people believe that parabens are dangerous, even without seeing the evidence, companies have to start putting paraben-free on their labels if they want people to use them. If people start worrying about blue light damaging skin, suddenly there are moisturizers marketed as blue light protective. And that response from industry doesn't make the myth actually go away. It validates it. To the consumer, it looks like proof. If brands are making products around this issue, it must be real. So now the loop begins to tighten. Media picks up on the stories because now they're good headlines. They're simple, they're emotional, they're click-worthy. And the coverage and the influencer amplification makes consumers even more convinced. And the cycle just repeats. Claim, consumer, industry, media, back to consumer again. Claim, consumer, industry, media, back to consumer again. And with each turn of that loop, the myth grows stronger. So take chemical-free claims. Everything is made from chemicals, including water. But once that phrase caught on, consumers demanded it. Brands put it on packaging, and media reinforced the idea that chemicals must be harmful, or detox skincare, right? Now, your liver and your body detoxes your body, but creams don't, right? But the word detox is very sticky. It feels good. So the loop keeps spinning. And then there's things like blue light protection. Yes, blue light has effects, but the evidence that phone screens are harming your skin is minimal. Still, once the concern takes hold, the cycle makes it a market trend. This is the danger of the misinformation loop. Once industry adopts a myth to meet consumer demand, it doesn't just validate the belief, it actually entrenches it. And breaking out of the loop just becomes harder and harder and even harder. One of the most important parts of this misinformation loop is that role of industry, because companies don't just respond to myths, they often amplify them. And from a behavioral science perspective, this actually just makes sense. Firms are designed to meet consumer demand, not necessarily to fact check it. They're looking for trends. Take paraben free, for example. The science tells us that parabens are safe at regulated levels, but once consumers started fearing them, companies rushed to put paraben free on packaging. And that label doesn't just reassure consumers, it also reinforces the very fear that it was meant to address. So the myth gets stronger. Or consider neurocosmetics, like getting into my area of neuroscience. We know that sensory experiences like certain types of smell and touch can influence mood. There is academic research supports that. But the leap to claiming that a cream releases endorphins or rewires brain pathways is not so scientifically clear. Yet the idea is really irresistible because it starts to feel futuristic, neurocosmetics. It feels empowering, so companies use it as a differentiator. But in doing so, they amplify hype more than science. So, what does industry get from this? Well, in the short term, these claims deliver quick consumer trust. They signal that the company is listening to consumers and following trends and has a concern, and sales often follow. So, it ends up feeling like a win for the industry. But the long-term risks are real. So first, there's credibility issues. If a company builds its brand on claims that don't end up holding up, consumers will eventually lose trust. Second, regulation. Governments are paying more attention to misleading claims, especially in health and beauty. Now, third, there's confusion. When the myths unravel, consumers can feel misled, which damages not just one brand, but it can also damage whole categories. And finally, brands can get stuck. So if you build your whole identity around being clean, what happens if and when the science moves on or the definition of clean changes? When you're chasing trends like that, trends do change, and you've trapped yourself in a narrow positioning box. So while feeding the loop may look profitable in the moment, it can be deeply risky in the long run. And the challenge for companies is to meet consumers' need without locking themselves into myths that will erode trust and credibility over time. So far, we've seen how myths like paraben free or neurocosmetics can get locked into a feedback loop between or among consumers, companies, and media. The big question is, how do we break that loop? Now, behavioral science does give us some tools. And just because we have those tools doesn't mean that it's easy. As I said, some of those heuristics that we use are really strong. And so breaking habits and breaking loops can be very challenging. But here are a few ideas from behavioral science. The first is pre-bunking. We know from psychology that it's far more effective to inoculate people against misinformation before it takes hold rather than trying to debunk it afterwards. So think of it like a vaccine. If we give consumers simple, sticky narratives up front, like safe doesn't mean chemical free, we protect them against myths later. Second is this idea of reframing. Facts alone don't move people, but feelings do. So if fear sells, then maybe empowerment can be the antidote. Instead of saying this ingredient isn't harmful, we can say this formula is designed to protect you and your skin. So instead of saying not toxic, we can say proven safe. The science hasn't changed, but the way we frame it taps into the same emotional drivers that made the myth sticky in the first place. Third, we have choice architecture, and this is an idea that comes from decision science. It's really the strategies we use within our choices. And transparency should be the default in when we're making decisions. Clear ingredient lists, easy to understand safety labels, plain language claims. All of these help consumers feel informed without needing myths to guide their choices. When clarity is the norm, misinformation has less space to thrive. Fourth is feedback intervention. Doing active social listening and for those trends and those consumer insights shouldn't just be about trying to find the latest trends. They should be early warning systems. If you see a narrative like blue light protection starting to gain traction, you can address it before it spirals into a full-blown myth that then your company is like blindly following. Now, finally, there's collaboration. No single group can fix this alone, and it can be very daunting for any company to try to set out on combating misinformation on its own. But scientists can provide rigor, and industry can provide scale, and communicators can actually provide resonance to sort of have a antidote to misinformation feedback loop. When these groups work together, credibility can build, and credibility is the best antidote against misinformation. So breaking the loop isn't about shutting down the myths with more facts. It's about using behavioral science heuristics to work with, not against, the way people actually process information and think about things and the strategies they use when choosing products. So by pre-bunking, reframing, designing for transparency, monitoring feedback, and collaborating, we can start to shift the loop away from misinformation and back towards trust. So the bottom line is we can't just dismiss misinformation. We need to understand the psychology that fuels it and respond with evidence and empathy. So thank you so much for joining and listening in. And thank you so much to Jen for organizing this and inviting me to be part of this event. It is so important, and it is such a important thing to me personally about misinformation and the world that I see from my perspective. If you have any questions, feel free to reach out to me or visit my website, but also I'm here to have a discussion with you live. So let's start that as well. So any questions?
And thank you so much, Michelle, for that presentation. And bear with me as I bring her over to the main screen. Just one moment here. Lots of compliments in the chat. A really great presentation. Just checking that I'm unmuted on all applications, and I think I am. I think that this topic is underappreciated, maybe, as far as I've seen in the general zeitgeist around misinformation, but very, very important. Very important topic. So yeah, thank you so much for contributing this to the summit. And while we're waiting for questions, I want to bring up something that I think we talked about. Michelle was on my podcast last season. We had a great episode conversation, so go listen to that conversation. But I want to rehash something that we brought up, or I brought up, and you talked about. Thinking about short-term benefits. And I know you brought this up, but I just want to flesh this out a little bit more. Short-term benefits of misinformation for companies versus long-term risks, where it is, from my experience, just as an example, I had a conversation with a conglomerate. I brought this example. I'm sorry for being repetitive on my podcast, but I had a conversation with a conglomerate about this, where they didn't want to use free-from claims because they knew that this created more misinformation by teaching consumers that these ingredients are things to be fearful of. And so they held out for a really long while from putting those free-from claims on their label. But because of market appetite, their sales went down. And all they had to do was silently, because they didn't make a fuss out of it, they didn't go and put out additional misinformation. All they did was put free from claims on their label. Their sales went up. So it taught them in that immediate example that there's a benefit, and also the long-term risk. They didn't have this time and space to hold out. And even investing in an educational program to kind of correct this, there's an uncertain financial benefit in the future for addressing misinformation or for holding out against using some of these claims. I'm sorry, Christina, thank you for letting me know. I didn't have the live screen on, but you could hear my voice. I'll stop talking. Michelle, what do you think about this whole equation, and how can brands better think about the short-term versus long-term risks and benefits for addressing misinformation, or not pandering to it at least?
I mean, this is the tough thing, because it's kind of the way industry is run, right? Where a lot of these decisions are being made in marketing, who certainly have to chase what the consumer wants, and they have to listen to that. And ultimately, they're holding the purse strings on how long, say, a product is going to be out there, or how they're going to communicate it. And so they're just kind of following that money a bit. And so for those of us that have been in those conversations, where it might be the R&D scientists and the formulators and the researchers alongside with the marketing specialists talking about those claims that can be put on the label, it really is a tough battle, right? And the science doesn't always win there. But I think it's also just really hard for any of those people in that room to take that long-term look, because ultimately, if they don't get the sales within a certain amount of time, that product is going to be pulled off the shelf. If marketing is no longer going to support it if they can't guarantee that within 6 months it's going to be able to make however much money. And that sort of cycle makes it really hard to think about those long-term gains. I don't really know how to solve a problem like that, because it is so self-perpetuating in a way. Certainly, some of the things that I talked about, I feel like are really good from a broader perspective. But when it comes down to those moments in those meetings with all the people involved and the stakeholders, ultimately they end up bending to what is going to ultimately make that sale, right? I know it's depressing.
I know. It makes misinformation very, very difficult to address. This brings up, I would be interested in your take on this. While we're waiting for questions, ask your questions. I know you say this is a great presentation. Bring your questions. Although this came up on my feed recently, and I'm interested in your perspective. So recently there was this very popular dermfluencer who posted an ad about this detox meal plan. And so it was really egregious to me, because it was like, wow, this is a state of medfluencing, and like, this is, kind of scary. But it makes me think about like some of the temptations for some of these like headlines, and really meeting these misinformation trends from people who have platforms. And then on the flip side, the dermfluencers who are posting stuff like this, she's one example, but I brought up another example of this, like one of the most famous at this point dermfluencers in the world just made a statement on her platform with a following of 1.2 million people about the impacts of fragrance. And if you're pregnant, you need to avoid this based off of their endocrine disrupting impact. And now that's out there. And then so that's a catchy thing that works with the social media algorithms. And then because she gets attention, then brands want to work with her. Brands want to work with influencers who get attention. And so then despite the fact that they may be like fighting misinformation and promoting science, whatever, by working with a dermfluencer, that's the appearance, they work with somebody who's spreading misinformation, who's pandered to the trend, or like the temptations, I guess, that algorithms fuel for attention. And then they're supporting misinformation. And then it's this cycle again. So like, how do you think about this from a behavioral science point of view?
Yeah, it's really unfortunate that is kind of like the rewarding aspects of how algorithms are built, right? And
we end up only being exposed to things that are more sticky, that have more views. Things that are more fear-inducing are going to garner that attention, and it's just going to be strengthened by the fact that more people are going to watch it, and then marketing has to pay attention to it. These influencers are, they understand, they can see their own metrics and they can see what is hitting best. And so saying something that has to do with fears involved with pregnancy, so any of us that have, been pregnant or know someone who's been pregnant understands how strong those fears really are, and you're worried about any possible thing that you may be doing that could be harming this life, right? And so I think that it really plays into things like that. And then as that just gets strengthened by those algorithms and we just end up hearing it more, and then the influencer is rewarded even, right? It really is self-perpetuating and it spins out of control. It's amazing to me to see just how well, even if it is just the algorithms, it just immediately starts feeding into these heuristics that we have even before these algorithms existed, right? That there are these things that just appeal to the way our brains work. And those are the things that I think are showing up more and more in our social media, et cetera. I think that is truly amazing to some degree, because I think it just kind of shows how powerful those heuristics really are and those shortcuts that our brains take. And then it really ends up being a matter of, well, how can we break out of that cycle, right? And it's unfortunate that so much of that cycle is just very rewarding, to be honest. It's rewarding to the influencer, it's rewarding to the short-term gains that the companies are making. It's rewarding to the people who are being supported now in their fear, right? So I think we're all being rewarded by the misinformation, unfortunately, and that just makes it all the more strong.
And the only people who aren't being rewarded are the people who are doing good science communication. Stay tuned for the next presentation.
Well, that's hard. That's hard. It's too hard, right?
Okay, we had a question from Neural who asked, as a founder or of the marketing team for a certain cosmetic product, what do they need to know and be aware of for the consumer or target market in terms of building trust regarding their product while also having short-term and long-term success? Hard question.
I think consumers do remember, right? And when you break that trust, and that's kind of why I bring up that problem of sort of the long-term issues, is that you can, like, if you follow the trends too hard, you can end up being bucketed into something that could be disproven later. And then you lose that trust. I think that is something that you can probably think about with some brands who really, have banked their whole being on some form of messaging that could easily be debunked. I think when consumers lose that trust, it's really hard to gain it back. You'll always be seen as, a bit tainted. And so I think, in a way, I think what we kind of need to bring into people who are founders of marketing groups is maybe a little bit of ethics, right? And maybe a little bit of also understanding consumer loyalty and what that really means, and that trust that you're really building, right? Long-term effects of that sort. I think that ethics is missing in a lot of the equations that we've been talking about, like in the previous talk, before mine and really all day, is that there does seem to be a missing link of considering how you're saying something and what you're saying and the long-term effects it's really going to have.
And I feel like a lot of this comes down to, at least with larger companies, maybe a disconnect between their marketing and science department. I see it like all over the place. Like, for example,
they work in silos.
They do
actually talk to each other very often.
With a few exceptions. Some companies do a good job at this, but most don't. And so, do you have any suggestions for, or maybe a call to action for industry that's watching?
I mean, this would be really important, not just for, the ethics and the loyalty of the customers and misinformation and all of that, but also just an innovation. So, whether the innovation is being driven by marketing or by the R&D, or the, all the research and development that's going on with the product, or how long the product gets to be on shelf, there is a huge disconnect between marketing and R&D. I think that One solution that I've seen that's worked out really well is doing something called research-based strategic foresight. So instead of thinking of strategic foresight as something that you do at a large enterprise level, really thinking about it on a per project basis. So if R&D teams and marketing teams can sort of work together to sort of plan out what's going to happen from this R&D project and come up with the different scenarios that could play out, like what happens if your competitor makes something similar, what happens if news comes out and breaks out that, debunks something that, is an ingredient, or, a misinformation science claim comes out of something that's in your product. How can we potentially deal with that and think about that before we release something out? I think all of this working together with all the stakeholders would actually really improve things. So finding ways like using a strategic foresight approach to bring those teams together to have those real discussions about what's going to play out in market before you even get there would certainly help the situation quite a bit.
And I think that there's like a systemic challenge across the industry. I see this a lot at conferences that are geared towards indie brands who are maybe not so aware of the technical expertise that certain people should have. And so, like, there's kind of this feeling that the regulatory folks are like the bad guys. They're the annoying people. They're the pedantic dweebs. Don't listen to them. Let's talk to this like
I've
person.
been in some pretty harsh meetings where those people are made fun of a lot, right? Like, oh, it's them again. They're going to be saying, we can't do it.
And you see this at conferences too with the presentations. I find this may be changing. Maybe I'm in an echo chamber as I'm saying this, but I find that there are regulatory people who are getting platformed more at conferences in certain pockets, not all pockets, but like there's a lot of conversations that are like, it's teaching the industry, I think, things that aren't right because the wrong people are teaching it, but then it's like this underappreciation systemically across the industry for regulatory.
Oh, agreed. Sometimes they don't even bring in the regulatory people until like too late on the end, right? Of the development process or the ideation process. So should we be making, a fragrance lotion that we're going to make some sort of claim that there are neural fragrance-based effects on orgasm? Should we be making that? No one stops to think like, should we though? Right? Even though that claim is just not even in the realm of possibility, a regulatory person could probably easily say, I'm not sure that we should even look at this as a possibility.
Yeah. This is reminding me of a recent claim that came up, using the power of epigenetic science, where creating this product that will purportedly impact your epigenetics. Okay, so then you've talked about this feedback loop, and you alluded to this in your presentation, but I think we should lean into this a little bit more. How can brands think about creatively interrupting this feedback loop to positively impact this messy information space that we're in?
Well, and some of it is just kind of like that rewording. So I think if you can take a step back, and again, this would really involve working with marketing really intensely, maybe a retraining of marketing instead of just always chasing what the consumer wants, really thinking about the best way to communicate science to a consumer. So if this brand in particular is worried about that this could actually be an initiative of theirs. So instead of saying, paraben free, maybe there's a way of saying, kind of still leaning into those fears of wanting to protect skin, of talking more about how this is about protecting your skin, but it, isn't sort of feeding the fear of the parabens, right? So I think if care can be taken to maybe identify some of these misinformation themes even, which is definitely helped by you and the platform that you're building with all these speakers. I think if we're highlighting some of these misinformation, hashtags essentially, that perhaps R&D teams and marketing teams can start to target those to find better ways to communicate that are in the long term going to be more beneficial for the companies, right? So they're going to build more of that trust and actually in the long term be built off the science as well, which is certainly going to be more effective, right? So maybe there is just some sort of retraining that needs to be happening with platforms like yours, maybe bringing this more into those cosmetic, and you're doing this for sure, bringing that into more of those cosmetic conferences where it becomes a real discussion about how can we reframe how we're communicating these things or addressing these trends that are coming out on social media or through these influencers. How can we combat that and just rephrase things, rethink how we're communicating and sort of meeting those consumer demands, right?
This next question comes from Nural, who asks, how do we detect manipulative and non-ethical brands before we become a consumer? Are there any red flags that people should watch out for?
I mean, I think some of them were kind of brought up in the previous speaker. A lot of times you have things that seem a little obvious, too obvious, right? When you have the white lab coat or, things that seem too good to be true. In my field and talking about the neuromarketing story, when people are saying things that don't seem too good to be true, like, oh, we can read minds with this gadget. Stop and think about it. Sometimes when people put a number on the claim, well, what's the evidence behind that? Like, why, we know that putting the number on there makes people immediately believe there's a real study. So really checking to see if those claims are real or not, or in the context they're in. Right. So I think that puts a lot of work for the consumer. But unfortunately, that's a little bit of the world that we're in at this point. I think when we see, the white lab coat in the ad, just recognizing that that's placed there for a reason. It's very much the trust but verify. Right. And that's the world we're in, even with AI, right? That we are looking at information and needing to second guess everything a little bit. Understanding that this sort of machine behind the background is just kind of going with what is going to be the most common denominator and what's going to be the easiest thing to convince you. So I think you just have to be a lot more cautious now than we ever had to in the past.
Echoing that sentiment, check in with what they're saying. Something that came up, I'm not going to say the brand, but they're a really big brand. They were propping up this very popular cosmetic chemist and then calling him a doctor. He only had a bachelor's. And so check in because that's deceptive. They're doing that for a reason. So this next question is from DT. This will be the last question that we have time for. But the question is, any journal article recommendations about motivated reasoning or the neuroscience reframing? And maybe I'll say journal articles and or books that you've enjoyed.
Yeah. There are a lot around nudge theory that come from more behavioral science. I don't want to just be self-promoting, but I do have a reading list that's on my website, on my blog. And so I've kind of compiled a bunch of these. But looking into more of the books around nudge theory or around even thinking fast and slow, and actually read the book, because a lot of people in the behavioral neuroscience or neuromarketing area don't actually read the book. Instead, they just quote from it. But understanding that you might even be fooling yourself a lot of the times when you believe something, but understanding a little bit more about the way your brain works and makes those shortcuts can help you sort of maybe change your own behaviors. I think that Habit by Charles Duhigg is actually a really good one as well. It really focuses on the habit loop and how we can break out of those habits. So recognizing the habits that we have and being able to break out of them. I think that all of that is really important to understanding the drivers behind your own behavior and also potentially around the consumers that you might be making products for. And just being, a little bit more aware of those perceptions and of those drivers. So I would go with the book route instead of the article route, because I think that can be a little overwhelming when you go straight to the journals or the articles.
Would you mind putting the link to your reading suggestion in the chat link? I would love to read your suggestions. And that's all the time we have for this Q&A. Thank you so much, Michelle, for agreeing to contribute your time and expertise, especially on a Sunday. I'm so sorry to all my speakers for making you do something on the weekend.
Thank you so much.
And
Great job.
Thank you so much, and have a great rest of your Sunday.
You as well.
Our next presentation will be on the value and challenges for good sci-comm, presented by me. A little awkward to introduce myself, but here we go. I'm a cosmetic scientist, science communicator, and founder of the EcoWell. I co-founded Beauty sci-comm, a social enterprise dedicated to elevating science communication and beauty. I host the EcoWell podcast, and I've interviewed more than, at this point, 1,000 subject matter experts on topics that span cosmetic science. I regularly moderate panels, organize e-summits like these, and do technical consulting as well as consulting on science communication. I'm currently pursuing a PhD at the University of Ottawa, and my research explores how misinformation is impacting environmental outcomes in the cosmetic sector. Without further ado, here's my presentation. So I'll be taking on the topic of good science communication. Specifically, I'll cover its value in beauty and beyond, the challenges, especially for independent science communication, and opportunities. My name's Jen, as you probably know. I've been doing sci-comm for the last decade, in addition to my regular paid work, which increasingly sci-comm has also been a part of. I'm now also helping other companies think about how they can effectively communicate their science across platforms. Many of the slides I'll be presenting came out of previous collaborations with Michelle at Lab Muffin Beauty Science, including via our social enterprise, Beauty sci-comm, which we launched to address some of the challenges I'll be raising in this presentation. So with that, the problem. There's too much misinformation in beauty and beyond, and not enough people well placed to tackle it. We live in what many people call an infodemic. With the rise of social media, there is so much information out there, right and wrong, now presented without any kind of expert intermediation. With our fast-paced news media cycle, looped in with our desire for quick information, coupled with algorithmic factors that incentivize sensation over substance, no matter who you are, whether you're a PhD scientist or not, finding truth, especially when faced in areas that aren't our own expertise, is extremely difficult. Turning to beauty, consumers are overwhelmed. The industry itself has some responsibility for the misinformation we see. For example, with the free-from claims that gained popularity in the early 2000s, first with sulfate-free, then paraben-free, and so on, we've effectively been teaching the public that chemicals in beauty are things to be fearful of, and that our regulatory frameworks aren't doing enough to keep consumers safe. Because when people see free-from claims, they assume the ingredients the products are free from must be bad. Fear is a powerful marketing tool because it taps into our biases for negative information. It also has a significant role in the spread of misinformation. When people are fearful, they're also more likely to share. The traction of free-from claims has made it more challenging for consumers to understand the larger picture of safety for these products, including the differences between hazard and risk, which you would have heard a lot more about earlier in the day from Mo. The success of fear marketing has shifted consumer expectations, where they now seek out these claims that, from a scientific perspective, are deceptive and drive science illiteracy. This also created an opening for NGOs like the EWG to gain traction. While this NGO is often viewed by the public and some legislators as a scientific body, the tactics the EWG has used to drive its narratives has been via cherry-picking studies, misrepresenting study findings, and using misleading citations. These are hallmarks of pseudoscience. For the general public, it's becoming harder to distinguish pseudoscience from legitimate science. As an example, about 7 years ago now, I sleuthed through the EWG Skin Deep database entry on methylparaben, which, disclaimer, now looks a little different, but I think illustrates a trend across their publications. Where EWG says there's an endocrine concern, they use studies and reports that don't actually support what they're saying, or are just low quality or not quite relevant to the specific context. Later in their entry, they cite stronger, newer, and more relevant data that directly refutes their endocrine concern statements, which they seem to selectively ignore. When they talk about allergies, they leave out the fact that parabens used in cosmetics are some of the least allergenic of the preservatives used. As a result, they frequently win the non-allergen award of the year by the American Contact Dermatitis Society. Why was this not included? For me to see this trend of cherry-picking and misrepresentation, it took me reading through all their technical references. Most people will not have the time to do this. The use of references like this that often don't even support the claims being made is a common tactic for charlatans. And when most people see these long reference lists, they assume the authors are using them in good faith. From EWG, there's been a slew of other NGOs and apps more recently who seemingly follow their playbook, and an ever-confused consumer base whose sentiment drives the industry. Today, consumers increasingly reach for products due to misplaced fear, which has led to changing retailer standards to meet this demand, pressure on legislators who are also prey to misinformation, and pressure on brands to reformulate to meet misinformation-fueled market demands. And around we've gone. On the consumer side, this may be leading to worsened health outcomes. For example, people are fearful of chemical sunscreens now, which don't have the same white cast issues as mineral sunscreens, which many people find alienating. And so they're either using mineral sunscreens they don't like and not applying enough to offset the white cast issues, which to get the marketed SPF, you have to wear 2 milligrams per centimeter square of your skin, a lot more than what most people are using. Maybe they're trying their own DIY sunscreen and not getting the protection they think they are, or they're just foregoing sunscreen in general. And on the industry side, a huge amount of economic waste due to a constant need for reformulating. We do this at the cost of innovation to actually improve products from a performance, health, and environment standpoint. Misinformation gets in the way of the support needed for progress. All of this is tangential to the dynamics of parasocial relationships online. In this noisy information ecosystem, people are turning to folks who seem trustworthy to find truth. For example, this toxicologist who at first glance would seem like the right place to find safety information. I think a lot of people don't realize how big of a problem expert-led misinformation is right now. Due to appeal to authority factors, it tends to be stickier and, based on what I've observed, may be disproportionately more impactful in the net spread of misinformation. Part of this is because a lot of other influencers with even larger platforms use these expert influencers as their information sources. To highlight this, Yvonne recently posted this on her platform based on this study. This was shared by many other highly credentialed influencer accounts. She was then platformed by a much bigger platform with Diaries of a CEO, where she brought this all up. At this point, the fear over the study outcomes went viral on social media. To address this, over at Beauty sci-comm, we did a briefing note to break the study down with the help of toxicologist Dr. Lyle Burgoon. The study actually had gaping issues, including the fact that its data didn't match its conclusions in the abstract. If the people who posted about the study read it, past just the abstract, they would have seen that the study was not a cause for concern. What Yvonne was saying was not consistent with the actual takeaways from the study itself. As you may imagine, responding to this kind of expert-led misinformation requires a lot of time, effort, and specific expertise. Considering Yvonne seemingly didn't actually read the study she was talking about, there is a disproportionate burden on the people trying to debunk. To cite Brandoloni's law, the amount of energy needed to refute BS is an order of magnitude bigger than what's needed to produce it. Before I move off this example, just quick on the journal that the study was published in. It was the same journal where that black plastic study that also went viral was published, which had basic math issues that, when corrected for, actually pointed to safety of these products, despite all the headlines that were published on the original study. That study was the last straw after a trend of study issues in the journal that ended up getting the whole journal delisted from Web of Science. Despite this, there are still expert influencers with big accounts being massively platformed talking about this study as a reason to avoid black plastic. For example, this physician on Susan Yarrow's podcast. And here we arrive at the problem with scientific studies. Science is complex and also a human enterprise. Papers are written by experts for experts with technical jargon and specific methods. Unless you have the specific expertise of the study, it will be very difficult to critically appraise it. And critical appraisal is fundamental. Not every study is created equal. Often you'll see this hierarchy of evidence as where you go up the pyramid, that means stronger evidence. But what studies got into the review? Garbage in, garbage out. Just because it's a review doesn't mean it's good evidence. Research fraud is a huge and seemingly growing problem. Today, it's even turning up in journals that are considered top tier for reputability. Predatory journals that will essentially publish anything for a fee without proper peer review, are a thing. Interestingly, in beauty, I've observed a trend of journals that have been called out as predatory being popular places industry members are publishing in. Peer review also doesn't equal reliability. While this process should act as a quality control measure, in reality, it's deeply flawed, where reviewers are unpaid volunteers and journals, as a consequence, struggle to find qualified reviewers. The culture of publish or perish in science has led to the same kind of sensationalism issues in science as we see with other media, where scientists are under a tremendous pressure to publish frequently, journals preferring exciting results, and negative results in replication studies rarely being accepted. These points were recently covered on my podcast with research sleuth Dr. Mu Yang. The episode is probably a must listen for anyone navigating science literature. Ultimately, bad science is a bigger issue than many realize. And if you read science, this is something that is crucial to be aware of. You have to be critical when you're reading science, otherwise, you're likely to come to the wrong conclusions. For example, this germfluencer who went on to talk about cypress oil as a means to stop hair growth. Mo, who presented earlier, took the time to read the study she referred to and ended up finding issues of fraud, which she later plagiarized from when she eventually corrected herself, or all of these medfluencers who tout rosemary oil as an aid to stop hair loss. Michelle over at Lab Muffin Beauty Science was the one to spot fraud issues with that study that they were all citing. In 1992, Nature published this paper on the growing inaccessibility of science. Well, many like to point out the fact that it's behind a paid wall. The bigger issue here is around specific expertise requirements. Careful interpretation of science is needed, and that requires specific expertise. A general background in science is usually not enough. For example, I do not have a background in neuroscience, and so if I were to try to critically appraise it, I would have a very hard time doing that. I wouldn't know the specifics of the common methodologies, nor would I understand the context and the technical jargon. And that's where science communicators with specific expertise come in. They could help me understand. Despite the structural issues in science, it is the best tool we have for understanding the world around us. Considering how interdisciplinary science is, science communication, even within science between disciplines, is crucially important to foster the collaboration and mutual understanding needed to drive societal progress. Science communication, or scicomm, is a form of science commentary. Scicomm is arguably very different from science reporting in that it puts the science in context and translates it, doing the critical appraisal for the audience so the audience doesn't need as much expertise to understand. Whereas the studies are the primary source of information, scicomm content are the secondary sources, kind of like a good academic review, which are arguably more important for the general public and non-experts. As we've already talked about, science is messy, and communicating it effectively is hard. While the good scicomm you see out there on social media may look easy, every piece of content takes a lot of expertise, skills, and time. Good scicomm makes complex science understandable, but not oversimplified, because oversimplifications generally translates to misinformation. Generally, reality tends to be complex, which competes against our natural human biases for simple information, which has a greater likelihood of being wrong. Our biases fuel social media algorithms, and this is what scicommers have to compete with. Good scicomm is accurate, yet engaging. A single post you see first requires scicommers to analyze the topic in science, identify and appraise relevant studies. Generally, to critically appraise a single study, you have to be aware of the full body of scientific evidence it belongs to. Where does that study fit into that body of knowledge? Scicommers then have to apply the science to the right real-world context. For example, is it even relevant to the specific exposure scenarios in cosmetics given regulatory requirements and dynamics of formulations? And then finally, create the content you see as a one-person creative agency. Not only do we have to have technical expertise to understand this stuff and appraise it, we also have to be able to speak in front of a camera, edit video and imagery, keep up with platform changes, answer questions in our comments, etc. Independent sci-commers often do all this on top of their real job for little or no pay. Right now, public understanding of science is crucial, but trust in institutions is declining. This includes trust in companies, governments, and trade associations. The public is less likely to be receptive to the information coming from these groups, but rather, they're looking for truth from people in their network that they do trust. Parasocial relationships are a big driver for misinformation online. These are one-sided connections, often formed with influential figures. People believe influencers are celebrities they feel connected to, even if they're not experts. The idea of parasocial relationships can also help steer people towards the truth. There's a thread of research about trusted messengers. They are people within communities who already have that community's trust and are better positioned to relay information to that community, especially if it confronts community preconceptions. There's quite a bit of research showing their importance in things like public health messaging and climate change advocacy. Independent science communicators can be viewed as trusted messengers on social media, making them an important player in the fight against misinformation. They're more agile and have already built trust with their followers. For many, sci-commers are their main exposure to science in school. Sci-commers can help influence beliefs and behaviors with profound societal impacts. Today, science communication across the board is important. For example, in beauty, companies should be considering having a science communicator on staff to help communicate their science and think about how they can navigate this messy information ecosystem without just pandering to the misinformation trends to meet misinformed consumer sentiment. This is very hard because it means going against the current and investing in something that may only be a benefit financially to a company in the longer term. A big shout out to the companies who've been trying already. This is all important, but arguably, based on what we currently understand about how people are receptive to information sources, independent science communication is probably more important. Unfortunately, incentives are stacked against us. Earlier, I brought up the difficulty in addressing expert-led misinformation. This kind of work requires very high effort and skill compared to other types of content. Just an example from me, the amount of time needed for a single podcast, Instagram post, or reel, sometimes up to around 30 hours. And for my summits here, we're into the hundreds of hours. And I wouldn't say this time need is unique to me. Because of algorithmic factors on social media, good sci-comm also gets lower engagement, which leads to less funding opportunities. For example, brands who work with influencers usually work with those who have high engagement, making it much easier for those who are putting out misinformation to make an income, much harder for those who do good sci-comm. I know people want free content, but at the end of the day, sci-commers need to feed themselves. And that's where things like sponsorships are tremendously important to make what we do sustainable. In general, the income of sci-commers is low and inconsistent or zero. And this is a really big problem. Did you know that many experts with big platforms are unethical clout chasers who rip off actual experts who do the hard work without crediting them? I think a lot of people don't realize how big of a problem this currently is in the space of independent science communication. Plagiarism in turn creates more misinformation. The plagiarizers look like experts while simultaneously killing off the subject matter experts who do independent science communication who are needed to debunk it. It's not only demoralizing to see your content ripped off, I've also seen this happening from companies in beauty who take sci-comm content and reappropriate it as their own. This also robs sci-commers of funding opportunities. Sci-commers who focus on debunking work also have to deal with looking very closely at misinformation on the daily. Being so online in general, like sci-commers on social media have to be, already isn't great. But then adding in the fact that we're going out of our way to regularly confront misinformation, as you may imagine, this is not a great recipe for good mental health. Neither is the abuse we often receive. It is not uncommon for science communicators, especially women, especially for those who do debunking, to be harassed. You need extremely thick skin to survive on these platforms. In light of the challenges sci-commers are facing, Burnout in attrition is extremely common. We need to change how we view science communication and place legitimacy on this type of work. What could that look like? For the general person, engage with sci-comm content and share. If someone's content has been valuable to you, consider reaching out and letting them know. For subject matter experts who don't do sci-comm, consider supporting sci-commers with your expertise. Not everyone is well suited for science communication. Many people are better suited for focusing on their own science, and maybe this is an unpopular opinion, but that's totally okay. Good sci-comm is a very specific skill, like good science, and through collaboration, we can all do better. On my platform, as an example, there are many subject matter experts who I frequently reach out to fact check me, to contribute expert commentary, or to speak at conferences like this. My platform has been made possible because of the willingness of subject matter experts to share their expertise. For companies, consider hiring independent sci-commers as consultants. They can, for example, help you think about how you can effectively communicate science, or even think through product development. Investing in sci-commers via sponsored posts or speaking opportunities is also a tremendous way to support the sustainability of independent sci-comm. When you have them out for speaking engagements, pay them. On the flip side, when you have independent sci-commers travel out to your conferences and speak with no payment, you are actively harming independent science communication by making it a less sustainable career path. My free e-conference series, which the Truth and Beauty e-summit you're currently attending is a part of, is an example of how industry can support independent sci-comm. I started this conference series about 4 years ago to tackle the accessibility and quality issues with existing conferences. This conference series is possible because of the support of my summit sponsors, without which I wouldn't be able to invest the level of time needed to vet everything, to put together the programming, to manage the logistics and streaming, and so on. Shout out to my summit sponsors, Kenview, our silver sponsor, and BASF, who sponsored every conference I've hosted in 2025. Thank you both for your industry leadership and support for my science communication. There is currently no infrastructure to support independent science communication, and that is a problem. A call to action to help. And a big thank you to those who are already trying to change that. And that concludes my presentation. Thank you for your attention. And it's now time for Q&A. And bear with me as I bring myself onto the live stream. And here I am. So we had a question come in from Michelle. I think this is an excellent question, which was, as a peer reviewer and journal author, the system is broken. More often, journals are trying for fast over accurate, even in high-rank journals. How can scicomm address this? I think we're already seeing how scicomm can help address this. Specifically, I'm thinking about the Black plastic study and the science communication that happened out of some of the sleuthing that spotted the issues of that study, how it was reported on, and then how that went and in turn with the response of the authors of that study led to the delisting of that whole journal from Web of Science. That was a response due to, I would say, the attention. Obviously, there are many people that needed to be a part of that, from the sleuths to the journals to the science communicators, but science communication can help scientists even, because I think sometimes scientists don't even realize that the issues are as great as they currently are, and the public help them understand that these are issues that need to be addressed and are important to be addressed, and frame it in a way that isn't like a anti-science rhetoric, because that's sometimes what ends up happening with that. So helping the public, whoever that is, whatever stakeholder that is important to the conversations that are happening with the issues, systemic issues in science, understand that there are these structural issues that need to be addressed. For example, the financial incentivization of the journals, important to address. At the same time, context. Science is the most important tool we have for understanding the world around us. So science communicators can help unpack some of these difficult conversations to help drive progress in actually addressing them. Another question from Michelle. Thank you so much for your questions. Anyone else have questions? Please ask me. Otherwise, I'll just continue talking and rambling. Please ask your questions. Okay, the question is for Michelle. Are there other conferences you recommend on these types of topics? I will say I don't think I attend enough conferences on misinformation, and that is a problem for me. So I don't know if I feel comfortable giving recommendations based off of what I've seen out there. I will say with respect to cosmetics, I started this conference series as an answer or a response to issues that I saw in conferences with quality, also accessibility, but I found myself getting very frustrated with the vetting of the speakers who are platformed, and so I wanted to do better. But I don't know if I have recommendations for other conferences, that's a bad on me thing that I haven't attended enough conferences on misinformation. I have many of my own conferences that dig into many of the topics that were covered today that would be good to churn back on, including last year I hosted another Truth and Beauty e-summit that I just take different angles each time I present this topic. So there was a different angle at that summit. So the replay would definitely be worth listening. And actually, on that topic of truth and beauty, I will say trade association that I think has been doing phenomenal work, and I would say disproportionate work in the landscape of trade associations in the cosmetics industry, especially in light of their limited budget as an association that represents indie beauty. You would expect this kind of a effort to come from some of the more well-funded associations, I would say. The Independent Beauty Association has been hosting a series of truth and beauty panels at conferences, and I always am the moderator of their panels. We come at the topic from various points of view at each conference that we present on. I was at the Surfactants Congress, the World Surfactants Conference, earlier this year, and we came at it from the topic of the surfactants landscape. But in October, we're going to be at the Society of Cosmetic Chemists California chapter Suppliers Day, and we're going to be coming at it from a legislative perspective. I would suggest tuning in, coming if you're out there, but also tuning in, because the other thing that they do, which I really appreciate, is we try to get everything recorded so that the conversations can then be replayed on my podcast, so it's widely accessible to anyone. So that's my answer. I don't know if it was a good one, but there we are. Okay, the next question. I'll come back to your other question, Michelle. I see it, but I'll answer the question from Nural, who asks, how do I spread the awareness and the importance of sci-comm to my circle that doesn't even understand science in general? I don't know if you necessarily have to go and advocate for science communication. It's great that you want to, but I think advocating for critical thinking about headlines and some of the content or information that you're learning from science communicators, I think that could be really useful. So when somebody's telling you, for example, about your brain has a spoonful of microplastics, then take some of the information that you learned earlier from Ollie, why that doesn't make sense, So share some of the good content from science communicators. I think that effectively shows the value of science communication, but also helps improve the outcomes of the efforts from science communicators. There is another question from Annie. I'm sorry if I've mispronounced your name. What could the average person or other scientists in other fields do to help with the misinformation issue? I think if everyone just slowed down a little bit, and when they see a headline, if they just took a moment to pause, I think that pause could do a lot so that you actually can think about what you're seeing a little bit more. Pause before you share. I think if everyone did that, that would have a tremendous impact with respect to the spread of misinformation. This next question is from Brassfield Beauty, who asks, well, comments first. The esthetician community has received a lot of false information attention. It largely stems from out-of-date textbooks and sales reps spreading their agenda as education. What can we do to help? What can we do as an industry Sorry, the question was separated, so trying my best here. Okay, the question, what can we do as industry professionals to better educate ourselves and perhaps even demand better education? This is a really important point, and it's not only within the esthetician community. I've seen this crop up, I think, like everywhere. In dermatologist books, there is misinformation about cosmetic chemistry. For example, about mode of action of UV filters. And it seems like a really innocuous piece of misinformation that's like, actually, all UV filters work via absorption predominantly. That's roughly 90%, even for mineral sunscreens, of the mode of action. It's led to a lot of other misinformation that I think a lot of people don't really appreciate. Or within derm textbooks, there's like basic errors about like the difference between creams and lotions. So it's not just the estheticians, but certainly this is something that I've seen with estheticians as well. Also with cosmetic scientists. Certainly I've seen misinformation peddled unintentionally. I think people have good intentions when some of this information is out there, but there's been a gap with the necessary relevant experts to do good sci-comm between disciplines. The whole point of my talk. So if you're an industry professional, I would make noise about this. And we saw this with the UV filter stuff. So the AAD had on their website up until I think just last year this information that mineral sunscreen reflects and chemical sunscreens absorb. And it took a group of dermatologists with Michelle as well I think they did a letter to the editor that resulted in recently the AAD corrected it. And so that's one example. You guys can do whatever space you are in, you can do that by presenting good information. And this may come from some of the science communicators, maybe even in collaboration like what they did. The dermatologists in this case didn't necessarily have the relevant expertise for mode of action of UV filters, but they partnered with a science communicator who was well versed on this topic. And then they had impact. And so there's this opportunity for collaboration, but also raising your voice to let your specific groups know that this is misinformation and should be corrected, because otherwise maybe they don't even know. The next question that I have, just one second as I sorry, just one second. It's hard for me to. Okay, I'll go back to Michelle's question. Okay, so she says, me again. Are there sorts of social listening trackers on emerging misinformation themes to sort of find them in early stages to help with pre-bunking sci-comm? I'm sure there are. I'm not that familiar with. You know who will be a really good person to ask that question to? Jess Stokes-Parish, who's going to be presenting next. Oops, my session timed out. Just one second as I bring it thought I was idle. Just one second as I bring my video back up for you. And here I am, and I think I have... Oh, ask Jess. I think she'll have a good answer for you. This next question comes from Kajol, who asks, my question is not similar, but in the future, AI could analyze or how the AI will play in science communication, especially journal, whether it can be helpful. I guess it's not so much a question, but AI is currently being used as, firstly, there's like issues with fraud that's generated with AI, but there's kind of like an arms race right now within the sleuthing community with AI to then find the fraud. So there is tremendous opportunity for AI to be used for both good and bad. I don't know if I have more questions, so I am going to leave my presentation there. Thank you so much. I'll have another final thank you at the end of Jess and Michelle's presentation, but I just want to thank you here. Thank you so much for attending the conference, and I hope you've been enjoying the whole day. And a call to action, I may be annoying with how many times I've been posting this in the live stream, but something that I've seen other people do, and I've certainly done it myself, is make little reports of conferences I've enjoyed, and then I share it with my network to help spread some of the good information. I see a lot of people doing this for other conferences that are typically kind of highbrow to attend, very expensive. I would love to see something like that for my conference series. If you guys do that, I would greatly appreciate to see your take-homes, and it would be tremendously helpful for me spreading some of the accurate information, but also supporting this whole initiative. So I would super appreciate it if you guys did that. And thank you again for attending, and that concludes my presentation, and we'll move on to Jess and Michelle's presentation. Sorry, I keep saying Jess because Michelle won't be able to attend the live Q&A for that, but if you have questions for her, then certainly she can answer them for the ebook, but Jess will be a really great person to answer all of your questions. Okay, that concludes my talk. Thank you so much. Our last presentation of the day will be on finding credible information sources, featuring Dr. Jess Stokes-Parish and Dr. Michelle Wong. Jess is Associate Dean of Student Affairs in the Faculty of Health Sciences in Medicine at Bond University. A registered nurse with a PhD in medical education, her research explores workforce policy, practitioner preparedness, and science communication. Jess is passionate about storytelling and translating evidence into accessible formats, which she shares through her social media at j_Stokes-Parish. She is also the creator of the CRABS framework, a widely used tool for evaluating the credibility of information sources. Michelle is a cosmetic chemist, science educator, and the creator of Lab Muffin Beauty Science. Since 2011, she has built one of the world's most recognized science communication platforms in beauty, explaining the chemistry behind beauty products across YouTube, Instagram, and TikTok. Michelle holds a PhD in chemistry, is also co-founder of Beauty scicomm, and author of The Science of Beauty. Her work has been featured in outlets such as The New York Times and Wired, and she regularly collaborates with brands and speaks at international conferences. So, this topic we're going to be covering with a fireside chat, and we're going to be featuring two people that I trust a lot for navigating this topic, Dr. Jess Stokes-Parish and Dr. Michelle Wong. Why I think this topic is so important is, well, it's harder and harder to find truth. The information landscape is becoming more and more complex. You have to have relevant expertise to delve into some of these topics. When people are telling you to do your own research, well, good luck with that for the average person, in my personal opinion. And therefore, you have to find an expert that you can trust. But how do you do that? There's a mess of different qualities of experts on the interwebs these days. So, how do you navigate the expert landscape? This topic is going to be about finding credible experts. My first question is going to be to both of you. What is the issue for finding credible experts? Jess, do you want to start?
Sure. Oh, Jen, I totally agree. We are absolutely overwhelmed with information and people who look like experts. And I think for me, what I'm looking for in somebody that's an expert is somebody who transparently states what their training and credentials are. So, what are their certificates? What's their undergraduate degree? What other specialty training do they have? But I'm also looking at their actual work experience. So there is a difference between somebody who goes and does a master's degree in health sciences and then never works in any sort of space clinically at all, has never been trained how to have clinical consultations, and yet their whole brand on Instagram is all about coaching you and being your clinical coach for skincare. And that's a really, it doesn't matter what the specialty is, it doesn't matter whether it's skin, nutrition, any of that. It's a really common trend that I've seen is people present themselves as having a Bachelor of Health Sciences or neuroscience, and then they go off into a rabbit hole of kind of claiming that they have the necessary expertise to treat you.
Oh, that's such a good point. And relevant to cosmetics, like it's very specialized. So even when we're talking about like formulations or toxicology, I see a lot of people opining on this topic, but then they don't actually have the relevant context. So like say you even have maybe even a PhD in toxicology. Without the relevant experience in the cosmetic sector to understand the regulatory context, to understand what's happening with formulation, you're not really going to understand it as well as somebody who has, even if they have less education, relevant experience in the cosmetics industry. Michelle, do you want to chime in on this question?
Yeah, I completely agree with Jess's point where it's really hard to see who has what credentials. I think it's really difficult for people to understand what different credentials are, which ones are more relevant to a particular topic. Like a lot of the time, you'll see people confusing, let's say, medical doctors and thinking they know everything to do with bodies and health. And I guess another big part of this is that you'll see a lot of people commenting on things outside of their lane. So, for example, recently there's been a big trend of medical doctors commenting on the safety of consumer products. And this is something that they just don't have the background to understand. Like you mentioned, Jen, with regulations, for example, medical doctors don't really understand the regulations that go into, for example, consumer products and their safety, like the safety of sunscreens or even medications. But yeah, like it's really difficult to see who the right person to trust is. And it's especially the case when people do confidently wander outside their lanes while claiming to be an expert. And of course, we have experts who have conflicting opinions on topics. And sometimes it will be two people with the same credentials, because sometimes people shoot their mouths off online without thinking about responsibility and how much their credibility lends to whatever information gets out there. For example, there was a dermatologist a while back who said he avoided chemical sunscreens because They cause kidney disease and birth defects. And when I asked him for a source, it turns out it was something he didn't quite remember 12 years ago. This was after he'd been saying this for about 4 months online. He had posted it on his social media accounts that went viral. He'd said this to a bunch of journalists. Yeah, I guess a lot of experts maybe don't have the training to understand how social media misinformation works, how saying something off the cuff can very quickly spiral out of control. It's not like back in the day where when you said it, it would go to maybe like a friend of a friend and that would be it. These days, you say something as an expert and that can go extremely far.
I think a big challenge in all of this, and you had highlighted this, Michelle, is that a lot of people don't really understand relevant expertise. And especially for an area like cosmetics, most people don't, even if they're scientists, know that there's like all these different layers of expertise. It's such an interdisciplinary industry. And the reason why it's functional is we all work with each other because we can't understand everything. For example, there's toxicologists, there's environmental scientists, there's chemists, and those chemists, that is also like widely interdisciplinary depending on where they are positioned, whether they're a formulator or whether they're in ingredient development. That's a different wheelhouse that they'll develop based off of the expertise specific to their position. This brings up this chart that I made for Beauty sci-comm to unpack some of the layers of expertise in cosmetics, and you should know that it's just the tip of the iceberg, and I've left out many of the expertises in cosmetics, such as I had highlighted environmental scientists. I'm starting to get slightly annoyed about the environmental communication aspect of cosmetics because I feel like a lot of people don't understand who the relevant experts are in the sustainability space. There are relevant experts that actually have relevant training. I find a lot of people just call themselves sustainability experts. So maybe stay tuned and I'll make another chart about that. But just to highlight who has more direct expertise on certain subjects and who has less direct expertise. And I think that this chart would be really useful for example, journalists for understanding who the right person is to reach out. Because I find many journalists have this assumption to no fault of their own, because that is often the communication that's out there, that, for example, you've probably heard this, dermatologists are the one true expert in cosmetics. And so they get asked to talk about topics like toxicology, like formulation. And as you can see from this chart, they don't quite have the relevant subject matter expertise. And for cosmetic chemistry, cosmetic chemist may be the more appropriate expertise. Even in cosmetic chemistry, though, it's challenging because it should be emphasized that there are quacks in every space, regardless of how credentialed they are. I think this leads really well to my next question. So I'll direct it to Jess. Jess made this really great framework called the CRABS framework. So can you take me through the CRABS framework?
Yeah, I think one of the keys to being able to determine expertise and to determine whether information should be considered or should be thrown out, we need to think systematically and we need to have a routine and a habit for it so that we can reduce that cognitive load that we have. And so CRABS was born out of that. And it is every educator's dream to come up with an amazing mnemonic, and you'll never forget CRABS for various reasons. But C is all about conflict of interest. And this is really trying to understand the person that's sharing the message. Do they stand to benefit from the message that they're sharing? And in what way? Is it financial? Is it profile, like social profile, or is it political? So finance is the one that we often think of, okay, they want to make money from this. But in the age of social media, social capital and politics are becoming a much bigger player in this space, in my opinion. Finances don't always mean that somebody's information is not accurate, because the funding has to, get to the research somehow. And sometimes there's some interlinks there. But you might want to take caution. The other thing that I think about when it comes to being conflicted is what is the underlying bias or viewpoint that that individual might have. So do they have a particular ideology that informs their beliefs or their views or interpretation? Because that can be a really good indicator of somebody being fixated on a particular topic or issue. The R is for references. So are there references? What do they include? Are they recent references? Are they from a reliable journal, or are they from potentially a predatory journal, which are journals that really take advantage of authors and they go and solicit papers that may not meet the same quality standards as others? And you're looking here to see if there's a breadth of the body of evidence and if all of that information is there that would replicate it. So it's not enough that there's a reference. You actually have to go and look to see whether the reference is relevant or whether it's recent, whether it's in a reputable journal, and so on. A is for author. So who is the author? This talks into that expertise that we were discussing. You know, what's the training that they have? What's the credentials that they have? What types of work experience do they have? How do you make sense of their sitting in the world? And also, how are they regarded by their peers? Are they well regarded by their peers? Do they speak at conferences that are considered reputable? Are there concerns about their credibility? And if they're a health professional in Australia, you can look up on the medical register to see whether they have any sanctions against their name, whether there's suspensions or warnings or things like that. So you can actually look that up. And in most countries, you can do that, which is really good. The second to last one is buzzwords. So this is really to emphasize the emotion and the jargon and the marketing ploys that might be used in a particular message. And are there phrases that are being used to emotionally hook you in and hijack your ability to process information? So I guess in beauty, it would be, you know, clean beauty, non-toxic, low tox, you know, those kind of classic ones. I'm sure there's more that you both would rattle off. And then finally, scope of practice, which Michelle's been referring to as stay in your lane. And scope refers to the concept that an individual profession has a realm in which they can operate safely and a regarded area of expertise that is considered universal to that particular professional specialty. So as a registered nurse, I have a particular scope in intensive care nursing because that's my particular expertise. And so it's really appropriate for me to talk about toxicology because I worked in a toxicology ICU where I cared for people who had accidental overdoses or otherwise and poisonings and things like that. So you're really thinking about the author's expertise and their training, and you're thinking about the knowledge that they're sharing, whether they have the relevant training and expertise and whether it fits within that container of where they stand in their profession. And I think that's probably the easiest way. Sometimes scope people find quite difficult to understand, but if you can just think of it as a container, you know, you might have a nurse standing here that works in ICU and works with this particular expertise, but then you've got the physiotherapist who also works in the ICU. And while we might have some crossover about lungs, they're not going to be looking at urinary output or kidney function or brain function where I might. So you're really trying to determine that nuance between, what you're trained for and what's firmly within your container of expertise.
Maybe I'll just add a point that just because somebody doesn't have relevant subject matter expertise doesn't necessarily mean that they're a bad source of information. With, for example, general science communicators, there's a lot of people who do really, really phenomenal work on topics that they don't have the right expertise for, but oftentimes they have a network of people that they can fall back on to get assistance for these topics. This is something actually I do a lot for my content. I've talked to enough people, I feel like over 1,000 at this point, lots, where now I have a network of people to ask questions to put out content that isn't quite in my wheelhouse, but is in my networks. it can sometimes go wrong. So that's something to be mindful of. If I'm putting out content that you see isn't in my wheelhouse, then I would be more likely to get it wrong.
I agree. And I think this is where it's really important to have principles and values in the way that you science communicate. And part of that is transparency and a willingness to, in academia, we call it epistemic humility. So you have this space of being comfortable to say, one, this is outside of my expertise. So feel free to correct me if I kind of overstep. And two, you invite other relevant expertise, others to contribute. And three, you have to be so comfortable to say, hey, I got it wrong.
So I was inspired by Jess's crabs framework, and I started putting more into another acronym, which isn't quite as catchy. It's like MUDCAPS. So this is based on, well, both Jen and I have been doing lots of posts about red flags for spotting whether experts can be relied on. And I messed around with it, and the shortest I could get was MUDCAPS. It's like a cap to prevent your brain from getting splashed with, all the bull mud. Yeah, so M was misleading about their credentials. And I think this is one of the things where, like, when people want to look like more of an expert than they are on a topic that they're not actually qualified in, they might pretend that their qualification is in a different field, or they might pretend it's like more rigorous than it is. So let's say a diploma is actually a full degree. This is one that's quite relevant for chemists because there are cosmetic chemistry diplomas. And then after those, people will say they're a chemist and they don't really have the right training. Like a lot of these diplomas, they do teach you chemistry, but you don't have to know the chemistry very well to pass. Like you don't even have to do a mole calculation or know what a covalent bond is. So it's not really as rigorous as you would hope. Also, it's just a red flag that people are being misleading. And so if you can't trust them on this thing, you might not be able to trust them on other things. Also, I think this is quite relevant for health as well, because there's so many like chiropractors and naturopaths who really try to come across like they're medical doctors. So yeah, checking LinkedIn is really, really good for this. U is undisclosed like anything. So undisclosed conflicts of interest, undisclosed use of filters, sponsorships where they try to bury the hashtag ad at the bottom of the caption. Yeah, basically if someone is okay bending the truth in some areas, again, they're probably okay with bending the truth in other areas. D is defensiveness. So if the expert is really defensive and hostile when people ask them questions relatively politely, then that's a red flag that they're maybe not very confident in what they're saying. C is credit. So do they say who they got their information from? So this is the transparency thing, which really applies when you see a general science communicator. If you see where they're getting their information from, then they're a bit more reliable. Also, you can see if they're citing scientific papers. Does it seem like there's someone they're copying who they cut out because they don't have the right background to understand scientific papers? So basically, like if someone's not giving credit to the right people, it's a sign that they maybe care more about looking good and looking smart rather than giving you the right information and supporting people who are making accurate content. A is authority. So if someone is leaning really hard on appeal to authority, that's generally not really good enough. If they properly understand a topic, they should be able to point out why they're correct. P is peers. If an expert collaborates with a lot of dodgy people or they follow and promote a lot of questionable sources, that's probably at least a sign of poor judgment because they do have that expertise behind them. They can superpower a lot of misinformation with authority bias, and that's a massive problem when it comes to navigating experts. And then S is spotty track record. Basically, because we have the internet, you can scroll back and see everything someone's posted in the past, unless they've deleted it, which is also a red flag. But if they've got a spotty track record, then maybe they don't have the highest standards for what they're saying. Or if they have a pattern of inconsistent opinions, like in skincare, if it seems like their new favorite moisturizer, like they are raving about how a moisturizer changed their life every week, then yeah, maybe they don't really have high standards for what they're saying. And maybe you should also keep that in mind when assessing their information.
Okay, so to wrap up this chat, do you have any take-homes that you'd like to leave our audience with? Jess, do you want to start this?
I think the easy thing to say would be don't trust everything that you see on social media, but that seems really flippant in the environment in which we work and live and how information is shared. Yeah, so I would say use an acronym or a mnemonic like crabs or mudcaps to systematically work through information just so that you get into some sort of habit, and then it becomes a little bit more rote for you when you are engaging in this kind of content.
I completely agree. I think practice is really important. And I think the other thing is just collating reliable sources is really important, I think. If you do find a source that's reliable, obviously they might not stay reliable forever, and people who do put out dodgy information might improve. So it's always going to be dynamic. But I think if you can find a few good sources who are responsible about their platforms, who use their authority bias very carefully, who are honest, yeah, I think that's really valuable. And also, it's a lot easier to assess the reliability and the credibility of an expert than it is to become an expert yourself and assess the information directly. I think a lot of these red flags are very easy to spot. Things like, are they disclosing their ads properly? Do they seem a bit sus? Like, do they seem a bit too shiny? Like, there's no negative comments. No one ever argues with them. Do lots of their peers put a lot of clapping emojis in their comments and not much else? Like, I think signs like that, it's a lot easier to assess based on that than it is to try to work out the information for yourself. As commendable as it is, if you want to do that, and that's great. But yeah, there's just too much in our everyday lives to do that for every single topic. Like, we have to rely on experts, and unfortunately, not all experts are worth relying on. We need to develop these tools to work out which ones can be trusted.
And I guess I should have said this right at the start when explaining the issue. In my opinion, in the beauty space, probably beyond, a lot of the misinformation that is gaining a lot of traction, I think, is actually coming from the expert crowd. Like, for example, some of the sunscreen misconceptions, I think it started from, at least gained traction from some of the dermfluencers that then some of the other influencers are following, and you see them quoted in magazines getting things wrong. Expert misinformation is a huge underappreciated problem, and therefore learning how to spot credible and not credible expert sources is, especially with this messy information landscape, more important than ever. So that concludes our fireside chat. Kind of an odd way to conclude it with a point that I should have started it with. And it's now time for Q&A. And bear with me as I bring Jess to the main screen here. Oh, there we are. So I think I'm going to start with my own question. I feel like that this topic of expert-led misinformation is very important, but I feel like different entities aren't thinking hard enough about the misinformation that's happening from their own spaces and how they should be addressing it. And is it even their responsibility to address this? Specifically, I'm thinking about there's just a lot of misinformation coming from experts right now. I will just say, like, dermfluencer misinformation is a weird space right now, and it seems to be concentrated in certain areas. And I think that medfluencer misinformation in general is really difficult. And this is kind of a tangential question to the topics that we were talking about, but how should... And I will also say, similarly, there's a lot of misinformation coming from cosmetic chemists. And so, like, how are our cosmetic chemistry associations thinking about this? So how should our boards and associations think about misinformation that's coming within our space? Because I read a recent study, I think it was in JAMA, about, like, the utter lack of any kind of penalization for misinformation coming from physicians. I forget the stats, but it was minuscule. So is it even their responsibility? I've also had conversations with, like, Dr. Ejaz Adamson, where he doesn't think that it's necessarily within the medical board responsibility, and it's problematic. So yeah, what's your point of view? How should these groups be thinking about this?
Yeah, this is a really good question. And I think it's different in each country and each setting. So culturally, there are different perspectives on monitoring peers' missteps, I guess, is probably the way to frame it. And it also goes to different professions too. So different professions are more likely, in my experience, to want to report each other. And more broadly, regulation in that space is typically operationalized through passive monitoring. So it's not that the college or the organizing body is sitting there watching the content online. It's that you or I might see the content and go, hey, that is wildly inappropriate, and I'm going to report you to your board. There is some contention about it, because there's some schools of thought where people feel that it's discourse and that it's conversation, and so you shouldn't stifle discourse or conversation. And largely that comes from people that I think don't truly understand the wide-ranging impact of social media to public perception, to trust in the healthcare setting. And I think there's a little bit of naivety there, because we'd like to just think, look, it's just over in this one corner over here. Let us keep doing medicine over here. And that's certainly my experience, and my experience as well with other professions and their boards that would monitor this kind of stuff, is they don't actually have the necessary expertise to understand what the impact in a social media context is. So multi-layered, and I don't think there's any particular one right way.
Oh, we had this question earlier in the day from Michelle Niedziela, and I said, you would be a good person. You might know the answer to this, because I didn't. So the question was, are there sorts of social listening trackers on emerging misinformation themes to sort of find them in the early stages to help with pre-bunking sci-comm?
Not specifically for misinformation. And the reason for this is, again, kind of relates back, like, who decides what's misinformation and what are the kind of realms of misinformation. But there are tools that you can use to track information to get a sense of what are emerging trends. So, of course, you've got Google Trends, but there's also other tools like Hootsuite and Sprout Social. Most of them have sentiment analysis or listening tools that you can program to think about what the current topics are. So, which is a really important one, because that's something that I think that organizations could do. Organizations could invest in listening tools to have a sense of what's trending, and then they can be responsive to communities' questions, and they can actually engage in that conversation in a more timeful or meaningful way that's in a timely manner.
This next question is from Naral. It's specific to beauty, but I feel like you can take this and make it more broadly applicable, because I feel like there are broad implications from, like, if you kind of generalize the question. But the question was, what about beauty advisors? From my own experience, and what I've noticed is that beauty advisors give solutions to consumers with skin concerns and needs, but the priority is gaining sales. And I guess you can say the same thing about, like, health coaches, wellness influencers on social media, where they make suggestions for different diets, different supplements, different whatever in a lifestyle routine to have some purported outcome for their community. So she's saying, what about them? Maybe I'll just say, like, how can people think about these folks when navigating the interwebs? Where do they fit in? And how should they think about the information that's coming from these people?
Well, I think you should invite them into the conversation, because we do need to think about, I think, as the commenter highlights, they are trying to sell. I mean, that's their job. And if the training that they go to is actually business training, then they're being trained to problematize everything. So I think you have to really think about what what you want to discuss with them. How do you engage them in the conversation? Because they're a really important trust factor. People trust these people because they're more like them. There's an opportunity to leverage that. And so if you can build relationships with people like this, that can be key leverages for accessing accurate information, then you could you could really engage there and move into a space that you might not have.
And now, a topic that I brought up earlier in the day, it's something that I've been thinking about a lot lately, and I would love your point of view, especially in terms of how industry can think about this with who they are supporting financially. With social media algorithms, I find that there is just a temptation to increasingly put more and more sensational content out. So I see this happen for a lot of different accounts where they are initially good information sources, but then they deteriorate. They deteriorate and pander to the trends that will gain attention, because attention is ultimately what gets reward. It not only gets reward for them for engagement on platforms, but also it's what companies are looking for when they're looking for influencers to partner with. So now there's this trend from industry from wanting to support, like I say it loosely, science communicators, science influencers, dermfluencers. I see it all over cosmetic conferences when people are talking about influencers. Like, dermfluencers are the next frontier because they have consumer trust. That's something that I've heard a lot of. They seemingly want to support based off of what they are communicating, at least to the public. I'm unsure based off of the approach to support good science and combating misinformation, but then they fund the people who are just like increasingly going down that rabbit hole of worse and worse information. And the people who are putting out good information are alienated and lose funding opportunities. And I feel like they're also, I've been feeling this about my own content recently, because I feel like you become kind of like an outsider of the space where everyone's like hand clap emojis and boosting everyone in the algorithm, and then your post just like you deteriorate with your engagement as you're putting high quality, what I would see as good sci-comm with like nuance and accuracy as the focus. So how do you think about this? And how can industries better support good science communication? And like, what should the public know about all this? And how can they think about supporting this? This is a giant, like, $1 million question.
Yeah, we need to not be a capitalist society. I think attention is economy, and an economy is money, and what these companies are purchasing is the perceived credibility of these individuals. And I know that it's something that you and I have talked about, Jen, before, is we're not willing to trade our own credibility for likes, profile, money. And so that then comes with a cost in a system that is set up the complete opposite. I think that it's such a difficult one. I'd be really interested to see if any of your viewers today have any kind of thoughts on it as well. But it's, you have to be authentic to yourself, and you have to engage where you can. And I think this is where we have to get into roles where we are influencing policy, and that we are part of these organizations that might, if we think about professional organizations, how do we get onto their boards or onto their interest groups to actually influence and to raise to them the importance? I mean, it's very, very clear that social media is a commercial determinant of health. And it's a lever that we really need to think about in a different way. Maybe turning up on social media is not the way to get that change. Maybe it's the behind the scenes. I mean, you've been doing a lot of work with beauty sci-comm and other ways that I think can have a real impact.
People in the comments,
Please let us know your thoughts too. We want to know. We want to know. Okay, the next question is from Ruby, who asks, do you think that we need to change education to navigate to make navigating online misinformation a required competency for healthcare workers and education? It's tricky, especially for like teachers who then are teaching people and maybe they're misinformed and then maybe they're spreading misinformation in their classrooms. So should should education be required on navigating online misinformation or maybe social media literacy? And if so, how should we go about doing that?
I mean, yes. In most Western societies, schools are integrating it into their education for their students. I think we probably forget about it in other degrees or other certifications and things because we assume that people have that knowledge and maybe that's where we go wrong. I think it should be there. And I think digital literacy, social media literacy, just general media literacy is really important. I mean, we can see that just jumping on Facebook, and the amount of people that believe an AI post is just astounding. But again, I think this is where we have to take different avenues, libraries or other sources, spaces. How can we get in with parenting groups? How can we do that? But then I guess it's about experts as well. It's about educating experts. And if we can get to the experts, then we can reduce some of the downstream effects. Interestingly, I'm about to start a study which is exploring what do science communication experts think that undergraduate or pre-registration health professionals need to learn about science communication, because it's ubiquitous now. Whatever role you have as a health professional or a trained scientist, you will be science communicating in some way, whether it's small scale, big scale. And it's very easy to be overconfident with our own expertise in science communication. And I think that's where we're seeing a lot of this issue happening with experts, is because they actually don't understand the science and the theory behind science communication. And so what I'm hoping to get out of this study is a schedule of curricula that health professionals should, tick off in part of their quest to be good science communicators.
So clearly this is a tremendously complex topic, the topic of misinformation, many of the topics that we've explored today, including this one of finding credible experts. But that concludes this Q&A. Thank you so much, Jess. And Michelle, for agreeing to be a part of this session. I couldn't think of two better experts to lead this presentation. And so now we are at the end of the Truth in Beauty eSummit. Thank you so much to everyone who attended today. Thank you so much to all the speakers, the subject matter experts who contributed their expertise to help make this event possible. Thank you so much to the sponsors who have allowed me to continue hosting these events. It literally would not be feasible for me to do these free of charge, considering it takes like hundreds of hours. I wouldn't be able to invest this level of time without your support. So thank you so much to our silver sponsor, Kenvue, who presented today with a really great presentation about the health outcomes of misinformation on sunscreen. And thank you so much to BASF, who was our bronze sponsor, but BASF also sponsored every single one of my eSummits this year. And that was just a tremendous help for me having the confidence that I can sustainably do this. So that was a huge support. So thank you so much. Thank you so much for your thought leadership. And thank you so much for supporting my independent science communication. A couple last minute requests. First, well, I've been saying it all throughout the day, please share. It would really mean a lot to me if you wrote a little take-homes. Share your take-homes from this conference. Did you learn something valuable? Please share. That's the whole point of what I'm doing. So please share, and if you do, tag me at the EcoL on most platforms. On LinkedIn, I mostly go by my personal LinkedIn, which is Jen Novakovich. And the final request I'll give is that I'll be sending out an attendee feedback survey tomorrow when I send out the replay of this conference. Well, share the replay too. But if you could fill out that attendee feedback form, that would be tremendously helpful to me. Most people don't. Usually I only have like 15 people of the over 1,000 people that registered fill out that feedback survey. So like, please fill out the feedback survey. They're incredibly helpful to me to continue improving these events. My next conference is going to be on the science of beauty. I'm starting to plan out the agenda. It's going to be the first Sunday of December. So if there are topics that you want explored at that summit, then let me know in the comments or via email or however you want to let me know what topics you'd like to see. Also, if you have any suggestions for future summit topics, let me know. I'm still thinking about my summit topics for 2026. I'll be doing annually the Truth and Beauty Summit and the Sustainability Summit as kind of my bread and butter conferences, but there's 2 other topics that leaves space for. So let me know what topics you'd like to see covered, and I will consider that for a future summit. So that concludes the day. Thank you so much for joining me on a Sunday, and enjoy the rest of your day.